morning all. Of our national seminar on Chhattisgarh Basin and its environments. Today, we have a total of 4 sessions, followed by a panel discussion. We'd like to start the session, today's first session today, that is session 4 of our seminar. In this session 4, we'll discuss the mineral exploration in Chhattisgarh Basin and its basement. So, keeping in mind of that, I would request Dr. Deepak Sinha, Director AMD, to give us his keynote address, which will be followed by the session. Sir, welcome.
First slide you can project. Namaskar. And after yesterday's very good session, now we are stepping into second day. And as usual, the second day is devoted to mineral exploration part. We have heard about the geology, we have heard about the structures, and to some extent mineralization. But ultimately, the goal of geologist is to explore. So this session is devoted to the exploration aspects of Chhattisgarh Basin. And we know that Chhattisgarh Basin has got very good resources of limestone, but we are unfortunate that we don't have any paper on limestone. That could have been a very important aspect of Chhattisgarh Basin, economic aspect, but we are missing. But we know that Chhattisgarh Basin is explored for many minerals, and being from Atomic Mineral Directorate, I have taken this topic of 6 decades of uranium exploration in Chhattisgarh Basin, and in fact, this is the basin which has been worked a lot. Many things have emerged during exploration part that I am going to share with all of you. And my presentation time is 20 minutes. I have only 12 slides. So I'll be finishing my presentation within the set time. 6 decades, as I say, Chhattisgarh Basin, lot of information has emerged. Lot of exploration models are being modified. Yesterday we heard that somebody says it's a sag, somebody says it's a rift basin, somebody says some different type of basin development. All those things have emerged in, say, 30 years of span. Earlier, we used to know Chandrapur, Raipur, and then fine. Then somebody added Singhora, then somebody added Kharsia. So the stratigraphy is getting evolved. Stratigraphy is not changing. Whatever stratas are there, they are there. The perception is changing. And this perception is nothing but out of our own exploration, or out of our own interest, and the availability of new instrumentation. We are fortunate to have new type of methodologies, new type of exploration, which is making us to view same stratigraphy in different perspective. For example, if I take yesterday, we heard zircon related information, and he has nicely explained his point of observations with the help of zircon mineral grains, which was not possible earlier. LAIC PMS, of course, it is again very important instrument and available in a few institutes. And the data is very difficult to get nowadays. But earlier it was more difficult. People were not having LAIC PMS data of the zircon. So the ACE was a constraint that time. Now that constraint is removing. And in AMD, we have done a lot of work that I am going to share. And I'll just share the informations, what perception we have. AMD being exploration agency, we see the third dimension. Third dimension is nothing but the depth dimension. Usually when a professor goes or a field geologist goes, he sees only the surface. And based on that, he interprets the third dimension. But we have the advantage of having knowledge on the third dimension by various methodologies. All those things are there in my presentation, and I hope that it is going to enrich the knowledge of Chhattisgarh and your perception after that. Next, please. Coming to the well-known map of Chhattisgarh Basin, everybody knows that this is the Chhattisgarh Basin, and again Chandrapur, Raipur. If we take, this is the Singhora Basin, this is the Baldwat Sub Basin, Hirri Sub Basin, and these are the 4 blocks. Chhattisgarh Basin in general is undeformed. Everybody says, agrees also. But when we take the border area, in border area, the situation, the tectonics are different. They are deformed, and many of yesterday's presenters have accepted this, presented also. Beautiful data has been discussed yesterday. With that idea, yes, Chhattisgarh, this portion is deformed. Number of things are there which needs understanding, because they show the post Chhattisgarh related deformations and subsequent mineralization. When I say mineralization, to me silica is also mineral. So silica mineralization is also an important aspect of any metallogeny. Again, this portion, if I see, here also the deformations are seen, and beautiful paper were presented by my colleague Bedia yesterday. A lot of deformations he has shown. So one can see the basin is deformed, the basement is deformed, whether they are deformed simultaneously or subsequently. All those things are there. The evidences, they speak with that idea. Coming back to this margin also, this margin is equally important as this margin. Here too we have similar type of things. Data have been collected, and fortunately this area has been worked a lot. Probably people have concentrated considering proto-basin and considering the aspect. And in this area, the people have worked for limestone, but the marginal part where the exploration agency like AMD and GSI, they look for mineralization related evidences. So this is a very, very important area. Coming back to the western margin, it is also straight north-south Tapa fault we say, and it extends along the contact of Khairagarh and Chhattisgarh. This become another loci, a fault which is separating Khairagarh and Chhattisgarh Basin, whether it is a pre-fault, pre-basin fault, post-basin fault, or reactivated fault. All those things are important features of Chhattisgarh Basin, where the basin is involved subsequent to the deposition. I will be taking all those aspects into picture, and AMD being premier organization for Helimon Geophysical Survey, we have carried out geophysical survey, and we have very good data out of that. We have magnetic data, we have electromagnetic data, we have radiometric data. All those data, when integrated, they give a beautiful picture of third dimension. That a few aspects I am going to share here with all of you, that will give you a different perception. And in this area, we have done the geophysical survey here, we have done the Helimon survey here. Here also we wanted to have, still that program is not completed. We wanted to have Helimon survey along this border. From last year also we tried, but because of obvious reason, the socio-economic that problem is existing in this part, so we could not complete the Helimon geophysical survey data. But if that could have been completed, our knowledge certainly would have been enhanced, and the knowledge of adjoining Khairagarh Basin, which is probably the source rock for the Chhattisgarh Basin, has got many, many references. So I'll be touching upon the basement, that is Environs of Chhattisgarh Basin and Chhattisgarh Basin in particular. Next one. Again, same picture. I am not deviating. I am just bringing you to the subject. These are the places where we have recorded some anomalies. When we say anomalies, it could be uranium anomaly, it could be thorium anomaly, it could be potassium anomaly, and these minerals give you anomaly. And these minerals can be accommodated in a mineral, say monazite. That is the prevalent thing, and that is usually available all along the conglomerate. Somebody was saying that all along this conglomerate he has corrected zircon, and the probability of zircon having uranium and thorium is fair. And in that you have the monazite mineral, that is a cerium lanthanum phosphate. there also you have some incorporation of uranium, thorium, and they give the anomaly. So this type of anomalies have been picked up by our methodology, that is a surface radiometric survey. We do survey by GM counter and centrometer, and we record the anomalies. So these are the early anomalies located during early phase. 70 years back, all those things have been picked up by the counters, and they were indicating that some thoriferous mineral or thorium related mineral is available in the basal conglomerate. This is the basal conglomerate, what now we say Chariatic hole. Earlier it was known as the base of the Chandrapur. So all along basin, if you walk here to here, you are going to see heavy concentration in conglomerate horizon, and that is nothing but having zircon and monazite, which is giving you radioactivity. So this is a prevalent radioactivity and prevalent mineral which is available in the basal part of conglomerate, which is a very, very remarkable feature of all Proterozoic basin, including Chhattisgarh. So this was identified in early 60s, and then subsequently we were trying hard to get mineralization, good mineralization where we can concentrate. Next, please. Similarly, in 85, around 85, one borehole was drilled in the Durg Stadium. Steel Authority of India Limited drilled one borehole, deep borehole, and there they recorded gamma ray logging. We do logging, and that logging gives you some data. So we could get some data that yes, this portion has some mineral which is not like earlier heavy type of mineralization. So this give a clue that Chhattisgarh Basin, when at the center of the basin, you are recording at a depth of say 500 meter, we are recording some anomalies. So probability of getting mineralization was fair. With this idea, a dedicated project was started in 80s and 89 to 90. Continued 87 to 92, it continued basically, and we have taken whole basin as one project, and that whole basin was worked. We have done profiling all along that, geochemical sampling, all those things, all those data has emerged, and that time only we could get, next please, next, we could get again in the border area, in the Juba area. This is the again Singhora basin, and I was talking this basin margin and this basin margin. Along this, these are the red spots where we are finding anomalies. When I say anomaly, that means higher concentration of uranium, thorium, and potassium. So we could get within the basin and along the contact, which is the basement. In this case, the basement is your Sambalpur granite. In this case, the basement is your Sonakhan belt. In this case, the belt is your CGGC and Gondwana contact. So with that perception, when we went, we could find that mineralization is available in the sedimentary rocks of Chhattisgarh Basin, and locally they are known as rhyolitic hole formation of the Singhoda Basin. And those who have seen or not seen, yesterday I was talking to Partha, but he said that he has not seen that type of pyrite development. We have seen pyrite bed of 10 meter, 20 meter type of thickness, and that is something which reminds you the English movie of Mackinac Gold. If you go there, you will smell the sulfur dioxide, S2S. All those things, they are thick, they are beautiful places where one can observe. Even 38 years of service, I have never seen that type of observations, that type of outcrops which are Chhattisgarh having. And I am hardly seeing any paper dedicated to the development of pyrite of that type of thickness. So on that basis, AMD has given them a Juba member under rhyolitic hole formation. It is published and it is well documented. People can read, people can understand. So that was the place where some activity of sulfur, dedicated activity took place. Diagenetic sulfur is also there. Then subsequently we get epigenetic sulfurs in epigenetic sulfides and all those having various mineralization. So this area was proved that yes, mineralization is there. It has got uranium. It has got some other epigenetic metals like copper, like gold, like silver, like lead. All those things are available. So this then gave us a direction in 94, 95, and that time I am happy to say that my in charge, Dr. Hansoti, is sitting here. He was my party in charge who guided us to take up this area, and we had explored that area. We have done extensive drilling in that area, but we could find subsurface mineralization, but we could not prove the continuity. Economic geologists need continuity of the mineralization so that some resources can be established. That is not possible here. Probably the mineralization is there, but it has not reached to the grade which can be exploited. The quantity is less. Quality is there, but quantity is less. We need quantity as well for going ahead. So this is the evidences which came from here. And then subsequently, in the subsequent years, this area was, this line, which is a faulted bone, there also we could get some type of evidences along the unconformity. We know that unconformity is a tabular surface, and tabular surface was recording. We were very happy that we could get a big deposit in that, and the evidences were showing, were telling like that. But at the same time, when we explored, we could not get the continuity or exploration. Yesterday, Sachan Sah was describing the same thing. I am just repeating. He was the in charge for that, and he could say that. Now, recently, from last 2 years, we have again taken up that area with the idea that, okay, tabular surface is there. Added with our Helimon Geological Survey, we are trying to locate that some faults should be there, which could be a loci for bringing some solution from deeper source, which is spread along the unconformity. What could be those reasons? And yesterday, Mr. Bedia has shown you various evidences. They are coming from that area. So this area is showing evidences for mineralization, evidences for reactivation, and the work is continuing. Probably we hope that we may establish, maybe it takes a lot of time. Any exploration takes 5 to 10 years to prove or disprove that something is there or not. So all these things are continuing. Next. Next. Now coming to the Helimon survey, what are the picture is emerging? As I said, the third dimension. Now this is the third dimension. This is nothing but a image including magnetic radiometric. This is a TMI image where one can see something about the Chhattisgarh which is hidden. Say this is a data of 1 to 2 kilometer deep, which is showing white area, this area. Then you are seeing Singhoda area. Singhoda area, here some disturbances, and all those disturbances, what has been talked in a form of faulting and all those things. So there are post Singhoda faults. They are occupied by silica vein. They are occupied by quartzo-feldspathic veins. They are occupied by fluoride vein as well. And fluoride veins are not in one generation. They are in more than one generation, 2 generations. Many times we get northeast, many times we get northwest. So how Chhattisgarh Basin can host fluoride vein? Fluoride, we know that it's a very good mineralizers. Wherever fluoride is available, certainly it will bring some metal with it, complexing. It's a very good chelate, and it will give you a very good source as well as very good material for transportation. So when fluoride can come, naturally metal has to come. Where they have gone, that is again search. And one can see this type of lineament, a mega lineament. This has got a further westward continuity, and it goes beyond Chhattisgarh, and this is basically basement feature which we are seeing through the Chhattisgarh Basin. And this has got some 500-kilometer length. It touches the Darekasa, further south of Darekasa, and further go towards west. So this feature is which is a important feature, and where we are finding. Otherwise, then the eastern margin, if you see this area, which is near to Sonakhan belt. This is a Sonakhan belt, but this is the near to Sonakhan belt. And we are aware that that area, which is of Singhoda Basin, which is near to Sonakhan, has been affected by Sonakhan-related volcanism. Again, whether that is a Chhattisgarh or that is a, again, granitized Chhattisgarh, we don't know. I mean, all these things are questionable. But we are getting molybdenum mineralization. GSI is working in that area. It is north of Saraipalli, Kapudi, Vichya. AMD is also doing, because we have evidences of uranium. But they are rhyolitic hole formation. How rhyolitic hole formation will have molybdenum, high temperature minerals? So either they are not Chhattisgarh or they are Chhattisgarh, but something granitization has taken place post Chhattisgarh. All those possibilities are still there. Not concluded. All options are open. But these are the new aspects which are now emerging with the concepts of Helimon Geophysical Survey, advanced instrumentation, advanced technology available with us. So ultimately, we are hoping for the best. Probably we may get someday some good mineralization from this. In addition to that, of course, diamond is also there. That is not my domain. That is the domain of GSI. And yesterday we have heard that many diamonds in Mahasumund district have been identified. And this type of TA magnetic survey helps to get the signatures for diamond-related chemolytic pipe which are hidden in the Chhattisgarh. Next, please. Again, I said that second aspect what we take from Heli-1 survey, that is your radiometrics. So in radiometrics, 3 elements are identified: thorium, uranium, and potassium. And this is the color. Different color code, you can get the map. And if you get white color, this is the white, where green, blue, and red are in equal quantity, then you get white color. So wherever you are getting white color, they become important loci. So one can see this is the UTHK map of the whole basin, and one can see the trend lines, beautiful trend lines. All these trend lines are important for exploration point of view, which nobody can see from surface. They are the data collected from gamma ray logging data, and they are representing, say, 1 meter depth data. It is that type of information which is emerging, and this has to be correlated with present day structures as well as the magnetic data which is coming from, say, deep of 1 kilometer depth. So all those things, when we integrate again with EMI data, TMI electromagnetic data is interpreted with this information, it gives a very good picture for understanding of any conductor in the basement or above the basement, above the unconformity, and all those experiments are continuing. Next, please. I'm not going to too much details of all those things. They are the projects and they are continuing. We are hoping that some good information is going to emerge. Next, please. This is over. Next. Now, northern margin, that I told, and similar evidences. This is the evidence of white color. Same philosophy here. White color, and in the northern margin I'm tracking, which I said it was worked earlier. Now northern margin has given us white color. Probability of having UTHK integration is fair in that one, and we can get some information, probably some good source which we could not get earlier, now with the help of Heli-1 geophysical survey. So all those data are getting integrated, getting tested with new model. Now we have a deeper digging of deeper facility, say 1 kilometer deep. Now we can go. Now earlier it was not possible. So with the help of that, we are probing deep into deep to fathom the basement of the Chhattisgarh and related tectonism, maybe fault, maybe fold, where the solution is coming and it is giving you this indications. Otherwise, one can see we are not able to say anything, but this is the area where we have worked and we have found the evidences of probability of U and thorium. Next, please. Next. Now I'll take something from western margin. Western margin, which I said we are working for Heli-1 survey, but because of problems, our helicopter could not do the flying, and we were not given permission, and we have stopped. Of course, some area we covered, but still that assignment is live. Hope this year we may complete. And this is the Chhattisgarh Basin, and this is the line. Those who travel from Nagpur to Raipur, this is the Tappa place, and where the boundary of Chhattisgarh and Khairagarh or Dongargarh belt crosses. This is the line, and this is a well-known Tappa fault. It is written in the British memoirs everywhere. And the boundary of Chhattisgarh and Khairagarh is a fault line, which is straight line, which is north-south. And then the western side grain is again north-south. This is a famous Sita Ghota syncline of SN Sarkar. And yesterday somebody was presenting the data from this area, which is a rhyolite, and in that rhyolitic conglomerate of Sarkar, now that has become agglomerate, all those things are exposed. Here why I am referring the basement, that this basement has got everything for concentrating mineralization. Mineralization comes in the volcanic rocks, and volcanic rocks ultimately comes from mantle. So the rhyolitic magma came into existence in a form of Billy rhyolite, andesite and basalt came into existence in a form of various flows, say Pitepani, Sita, Gota, Mangi, Khuta, Kotima, and then again sedimentation, which is plotted here in a form of Karutolas, Bortalao, Gogra, Kotima, and all those things. So all these things are available pre-Chhattisgarh. Now pre-Chhattisgarh, and when we have surveyed, we could find number of places the anomalies related to structures. These are the structures well documented by Sri S.N. Sarkar. Subsequently, they have been worked by many geoscientists of AMD, GSI, university also, and it was proved that this is a very fertile place, fertile area. Even many concepts have been generated for this. Here Chandi Dongri mine is there, and in a one concept, this has been considered as a rift zone which goes northward like this Chandi Dongri, and probably it gets connected with Malanjkhand, and Malanjkhand granitoid and Dongargal granitoid are probably of coeval time. Of course, one is calcline, the other is I-type granite. So that difference is there. But at the same time, they have the connections because Malanjkhand comes here. So copper is there, gold is there. So somebody has again given this type of concept that is riptogenic basin, and probability of getting IOCG type of mineralization are fair, where you get RE and copper related mineralization. All those basement, the basement of Chhattisgarh is again fertile, and this has provided resources, this has provided sediments to the Chhattisgarh. When all these things is recycled, dumped into Chhattisgarh, that becomes important, and that evidences we are trying to locate below Chhattisgarh. This basin, this type of basement has to be below Chhattisgarh. What could be depth, whether it is a faulted basin because of this fault or the fault is post-sedimentary, all those are questions which are to be answered now in the light of latest evidences. Next, please. Again, again, this is again yellow color is your Chhattisgarh basin, and this circle one can see these are the places which I just discussed. But if you take them further southward, it goes up to Bastar. If you remember yesterday, I was commenting to the Lucknow University scholar that rock has got 150-kilometer length, and it goes up to Pratappur of the Bastar. It has got 150-kilometer and 30-kilometer line. And that type of formation, that type of unit is a very unique type of thing, and hardly you get. So that type of volcanism has taken place, that type of agglomeration has been developed. All those things will bring metal from mantle to the surface, getting concentrated, subsequently recycled, subsequently should be sent to the Chhattisgarh basin, if you think in basin development thing. So with that idea, the basement has already been worked, and we have understanding of Bodal Bhandari Tola, where one is in Pitapani andesite rock, this one, and this is in rhyolitic rocks. Some evidences of multimetallic deposit where uranium, copper, and other things are available. And this is in Bortalao formation, which is overlying formation of that. Why I am referring all those things, that the basement of Chhattisgarh shows good resources where we have deposits, where we have occurrences of mineralization, where we have very good source. And if those sources are there, Chhattisgarh is again subsequent overlain by that. Why not such type of things are possible below the Chhattisgarh? Nobody has proved those things. If we think a borehole of say 3 kilometer or 5 kilometer, are you going to get all those things below Chhattisgarh? Well preserved, not at all weathered. Post Chhattisgarh time, that type of concept is now emerging. Here I'll just share one information, recent information, and it has been published in Chinese journal that they are going to drill a 3-kilometer borehole where they are going to tap the resources, of course, multi-metallic resources. They have reached up to 1.5 kilometer. Beyond 1.5 kilometer, they are trying to develop, and at 3 kilometer, if they can plan, we should also think in this line. In this similar concept, I'll again quote back, I'll also quote below Deccan trap. Similar type of things are possible in below Deccan trap. The Kaladagi is going inside, Bhima is going inside, Vindhyan is going inside from north, from Chittorgarh side. So Deccan trap is also, you remove Deccan trap and then think, you will be getting the whole area, which is again has been visualized by Geological Survey of India as a uncovered Deccan trap project. So all those things are there, which are likely to be there in, say, in coming 20 years, where the methodology, where the instrumentation and where young minds is going to play a very important role, which we will be looking forward from the youngsters. Next, please. Now, if I summarize things like this is the thing which are available. Dongargarh Kotri Belt, I explained. And in north also, north I said CGGC, and these are the mineralizations, so they also become a part of that. And in Chhattisgarh Basin, I have already explained. Next, please. Next one. Now, coming to the last slide. What is perspective and what is the challenge? My presentation is in different mode. It is just bringing the subject and giving you thought for thinking. Strategy to target deeper parts. Yes, everybody will agree. Then target identification of subsurface exploration for concealed unconformity type. Again, unconformity is a very important surface which has to be explored. Then emphasis on geophysical signature. It is very, very important. If you want to see peep through 1 kilometer deep, you have to have the geophysics frame. Then casualty source of hydrothermal activity and their halos like younger cordophil with veins and fluorite, already explained. Exploration will provide ample opportunity for development of many minerals, not uranium, many minerals, including diamond, including many metallic minerals which are possible. And for this, AMD welcomes your association in this endeavor of societal development with the joint effort of all earth scientists, sociologists, and environmentalists. Now, earth scientists cannot work alone. We have to have sociologists with us who can explain the problem of exploration to society, and then environmentalists, that we are not going to destroy the forest. Whatever forest is given, we will give back the forest in much better way. That type of scope, that type of thinking is now required from all of us. Thank you very much for this paying attention. Sir. Yeah, please. Previous slide लेके जाइए.
As you said, this deeper parts of the basin and its environment. For deeper parts, we are well equipped in MECL, in geophysics especially, and we are latest acquiring one equipment, magnetic telluric also, which can go deeper sensors up to 10 kilometers, and it is expected to arrive within a period of 4 to 5 months. In that way, we can also help. And any kind of survey, if we collaborate, we can also take up that.
Right, sir. This green line is for that. This is a green field area. That's why the line is green.
Yes, sir. Yes, sir. You have made everybody green.
Green field area is open for everybody.
Yes.
We are looking for green field areas. Anybody can come. I am looking for university. I am looking for organization, Navratna like MECL. Geological Survey is a part of us. So I don't consider that we are two. And you are also part of us. So
Yes,
we
sir,
have
yes.
to, our effort has to be joint effort. That's why AMD welcomes your endeavor.
Yes, sir.
So
Very nice of you. Thank you.
Yes, please. Anybody else? Okay, please. Sir, you are from GSI?
Good morning, sir. I am Ajay Kulkarni from GSI. I am a geophysicist.
Okay.
So, have you ever attended the overlay of our NGPM data with any of your uranium deposit? The National Geophysical Survey data, we have got gravity and magnetic data of every one station in 2.5 square kilometer.
Right, sir. You are right. But your data we take, but they are very coarse data. We need very fine data. And this data, what I am talking, Helivon geophysical, it is very fine data. So coarse data is always helpful. Just like we are
especially
seeing
delineation of the regional structure, any deep-seated regional structure, we can
right.
easily
we are taking 5 milli, all those data which are available through GSI portal.
The work
You're
is
right.
done, you can take.
So work starts with quarter-inch sheet.
Okay, sir.
Same way it starts with your feedback. Then we land to our detailed area.
And this report has got interfaces also, radial power spectrum and everything. So you can see that how the layering and different interfaces are there.
Right, sir.
The tentative interfaces. what you can encounter in our area.
Right, sir. We are taking help, and we are also collecting. You might be aware how much area we have collected,
Mhm.
and all those things. Usually, prospect is hardly 1 square kilometer.
Yeah, that's true, sir. That's true. But
So your lines are not in that
see,
point.
that's true, sir. That's true. That
So-
it's a very large scale data.
Right. So mostly our prospects are located in 1 square kilometer. If we can get 1 square kilometer, that is going to be Olympic type, I think.
Okay. We are attending, sir. We are
Right,
taking
we are
the-
taking help.
we are taking the aerogeophysical survey, and then we are trying to overlay with our gravity and magnetic data.
But this is a helimon, sir.
This is a heliborn, sir.
It has got certainly advantage over now fixed wing.
Yeah, sir. That's true.
And GSI is starting helimon survey. You are taking help to do the helimon survey now. So this data is certainly much better
That's a
data.
very good presentation.
Thank
sir.
you.
Actually,
Thank you,
I
sir.
got 2 ideas, sir.
Thank you. Sir, just wait. हाँ, yes, sir. वो mic दीजिए सबको, mic दीजिए. ये दीजिए. Yes, sir. I'll be very happy.
Aware that Wyoming granite, it was, investigated how it contributed uranium to roll type of uranium deposits in USA.
Sir.
They attributed to emplacement of epidote veins in the granite. And at what time it took place. So they prepared Concordia Discordia diagrams using uranium lead ratios. So why we cannot apply such things in especially western margin of Chhattisgarh Basin? At what time the rhyolite or any other uranium bearing rock of Kairagarh Basin could contribute uranium to Chhattisgarh Basin?
Yes, sir. We can try. Epidote veins, we have to search. We are finding some epidote. Yes.
Any other
Right, sir.
event like that,
Right, sir.
we have to identify that.
Yes, sir. Now we are doing.
That
sir.
is my suggestion.
No, I could get your point, sir. And now with the help of new instrumentation, it is possible. Earlier we were thinking, but we were not able to do. Now, right, sir. Now MD has got a very good teams we have now. So with the help of teams, yes, possibility is there. Yes.
Sir, actually, GSI is also doing drilling work in the marginal parts. So, what care we should take in terms of uranium minerals, because we are doing phosphorite, glauconite, and glauconite is in Singhoda Basin also.
Balukona.
Balukona formation.
Balukona.
So, what cutoff we should consider
For potash?
for uranium, so that we should be careful?
No, cutoff is already fixed. Neither you nor me.
Ji.
Nobody can know. It is already notified in AMCR.
Because
60 ppm.
now we are
60
sending
ppm.
RE reports to AMD for vetting.
Right, you are right. So cutoff is already fixed.
Yes, sir.
Cutoff is notified in AMCR.
Second, sir,
You can see
question.
250 ppm.
Up to what depth we have drilled in the Chhattisgarh Basin?
Up to what?
Depth.
We have gone up to basement. Up now basement varies.
Yes, sir. Just,
So your depth will also vary. It could be.
Rough explanation.
Sail borehole could not touch the basement.
Mm.
1 kilometer probably,
1
1100 meter. We could not get basement. But in eastern part, yes, we have touched the basement. So it varies. I mean, still that fathoming is required.
Good morning, everybody. Myself, Dr. Pravir Kumar Naik. I am Regional Director, Central Groundwater Board, Raipur,
Welcome.
Chhattisgarh.
Welcome.
I will also present and some places in groundwater fluoride and uranium is also reported. In groundwater, we are analyzing the groundwater sample, na?
Right, I know. Yeah.
On that. Then the origin of fluoride after the Chhattisgarh, deposition of Chhattisgarh Basin, that fluoride deposits happened. It is post Chhattisgarh, you reported some fluoride veins
Yes, you're right.
after the Chhattisgarh Basin.
Right, it is there.
And it was a very good presentation because we are only analyzing the groundwater. So there will be correlation between lithology and the
Very right.
hydrogeology. Thank you.
Thank you, sir. Yes, please.
Good morning, sir. I must congratulate first
Thank
for
you.
your excellent presentation.
Thank you.
Sir, you were talking about the unconformity type uranium deposits right now, and you were especially emphasizing on that particular type of deposit. So, what are the geophysical methods that you consider to decipher the unconformities in the subsurface? Because on the surface, it is often possible to identify unconformities. But in subsurface, without drilling, what are the methods that you take?
Magnetic gives you contrast. Magnetic will give you contrast of granite and overlying sediments. And we know that in case of Chhattisgarh, your basal conglomerate has got lot of iron, if you have seen. It is a ferruginous in nature. That is hematitization or alteration of hematite into, say, hematite only, magnetite into hematite. So all those will certainly come in a form of very good picture in magnetic itself. You can delineate, beautifully delineate. Our geophysics people are there, they have delineated. But the question, you have many questions in one question. You are talking for unconformity type of mineralization. Uranium is not related to unconformity surface. It is something different. So we need to have some conductors along with unconformity. If we can prove them conductors, maybe overlying, maybe underlying, that is granite. If we can prove some conductor, we proved some conductor, we drilled it, but we could not find. We could find sulfides only. And as I referred, overlying formation, in this reticle formation, one can go and see the 10-meter thick zone of pyrite. All those will be reflected in your EM survey, electromagnetic survey. And if they are hidden, say they are hidden below Sarai Pali shale or overlying formation, you can pick up through EM survey. So that same thing we are doing, we are making models, we are testing them, and we are analyzing. If we can get good conductor, naturally it has to be associated with some mineralization. So that is the model which is pursued.
Thank you, sir.
Okay, I think now no questions, so I'll take my second duty.
Thank you, sir. So it was very crisp and thought-provoking indeed, and you summarized the uranium exploration strategies and challenges in a very crisp manner. So since so many questions came from the audience, I would like to request you all two things. First, please keep your questions limited in numbers because we will run short in time. And I would like to request you all to please put your mobile on silent mode, because whenever somebody is giving lectures and the phone rings, it creates some disturbances. So please put your phone on silent mode while the lecture is going on. Anyway, moving forward, this session we will have 6 more lectures, and Dr. D.K. Sinha would chair the session. I would like to request Ms. Mamta Paul, ma'am, to come forward and act as a reporter. And sir, with your permission, sir, the session would be chaired by you. Thank you, sir.
So now we are starting the session 4, and the first presentation out of that is Mineral Resources of Chhattisgarh, a Perspective. Dr. Pradeep K. Jain from IBM is invited for his talk. As usual, 10-minute time is already communicated, and 5 minutes is for question. But Jain sir has got advantage of background also. Yesterday's background, many things have been spoken, so that will be helpful. Please, Jain sir.
Thank you, Chairman, report chair, and good morning to all. And to begin with my talk, just I will start my talk, just last slide of the Dr. D.K. Sinha with the green. So he was telling that future is for the multi-facets discipline and all. So I want to add in that is a mineral economics. Mineral economics also has to play a very important role. Until unless, as he just given a hint, but the chief guest, Honorable Nitin Gadkari sir, were telling, not only the research, development, exploration, exploitation, and value addition. So keeping that into the mind, I had some presentation. Next, please. This is just subsequently to support my other revenue resources in the Chhattisgarh. Next, please. So as we know that the varied minerals are found in the Chhattisgarh Basin, and that is already been discussing from yesterday onwards. And a few of them are large economic deposits, and while other minerals are reported as occurrences also. So we too have a consideration for even 334 also, which is going to be subsequently becoming a 331 or 332 for the auctioning. And large deposits like coal, iron ore, limestone, bauxite, dolomite, china clay, sand, and others located in the different part of the Chhattisgarh. We are having in subsequent slide the statistics of that. And diamondiferous kimberlite identified in the Raipur district are also likely to yield a substantial quantity of the diamond near in the futures. We may see the production of the diamond from that also. Presently, it is only from the Madhya Pradesh, and which is also, I feel now that mine has been closed. And the tin cassiterite being a pegmatite containing moderate deposits are also known. Next, please. And medium to small deposit like a gold, base metal, quartzite, talc, soapstone, they all as has been narrated in the slides. And there are some occurrences of the other mineral also like a beryl, garnet, kyanite, sillimanite, rare precious metals. And few of these may be proved to be a sizable deposit in the future. Subsequent to the further exploration has to be carried out. And there is some monumental stones, color granites, marble, and others are there. Next, please. Next. Yeah, this is what published data compiled from the different sources, and this is actually based on the NMI 1 for 2015, and recently we are going to come 1 for 2020 also. And if we see that coal as on 1 for 20 reserve and remaining resources and the total resources. And if I give what is the purpose of sharing this slide? If you compare the ratio between the reserve and remaining resources, it is hardly 15 to 20%. So this is an area where thrust has to be given, converting the resources into the reserve. So for the bauxite, hardly 15 million ton. Iron ore, that is purely of the hematite, 1 billion. Iron ore magnetite, about 11 million. Limestone, I have put up the green also because this green is data as on 1 for 2020 also. So little bit there is about 10% of the enhancement of the resources of the limestone is there, both taking the reserve as well as the remaining resources. Then tin is hardly 4,000 tons, dolomite 94,000 tons, quartzite, diamond is only resources. There is no reserve. So whatever we are telling the prospects of the diamond in the Chhattisgarh, but until unless we are not going to convert these into the 111, 122 or 121, that's production may not be there. So whatever the discovery has been made, that has to be seen the light of the day when the production will start, when there is a value addition will be there for that mineral. So this can be an eye opener for us also. Whatever we are doing from last so many years, until unless it is not going to convert and make some value addition or to be utilized by the society, sometime it will remain in the books or in the some papers only. Then coming to the that's dolomite, quartzite, china clay also we have, corundum, hardly resources of the 0.89 thousand tons, fire clay, fluorite, gold occurrences also were there as resources, and graphite. Next, please. And particularly with the iron ore, if we go with the Chhattisgarh, the state is having about 22% of the reserve and remaining resources pertaining to the whole of the country. The country is having 22 billion ton of the hematite and about 11 billion ton of the magnetite. And the magnetite hardly 1% of the reserve, rest are the remaining resources. And state has a world-class iron ore deposit up to 68% of the Fe, that is Dantewada, the Bastar, Kanker, Rajnandgaon, and other districts. Over 1,387 million tons of the reserves of the hematite iron ore is available in the state, contains one of the fourth 26% total of the iron ore. And about 37 million tons of the iron ore, that is about 18%, is coming as ranked second after the Odisha in the state of the Chhattisgarh. And major two iron ore, this steel producer NMDC and the sale, they are producing about 98% of the total production of the iron ore, including the sale is making the value addition also. Beside the Jindal steel power plant and the Bhilai steel power plant, at the range of about 90% of the sponge iron pellets and plants are operated in the state by the Jindal and Bhilai steel plant. Next, please. So this is again the iron ore, particularly in the different districts: Dantewada, Bastar, Kaker, Rajnandgaon, Durg, and Kabir district. Kabirdham district. Next, please. As far as the coal is concerned, about 20% of the coal is in the as a resources in the state of the total country, and about 69 billion tons of the coal in the of the country is available in the, particularly in the basin of the this Raigad, Balrampur, Surajpur, Korea, and the Korba district. And the state ranked first in the coal production by contributing about 158 million tons in the 2021 as a production concern. And most of the coal deposits are power grade coal, and that is a NTPC, Chhattisgarh State Electricity Board, in the Korba and the Bilaspur are the major producer of the thermal coal in the state. Next, please. As far as the bauxite is concerned, about 4% of the national reserves of the bauxite is available in the Chhattisgarh, that is particularly in the Bastar, Bilaspur, Dantewada, and so forth and so on. And metal of the refractory grade bauxites occur in the Sarguja and Jaspar, Korba, and other districts. And state ranked third in the bauxite, particularly of the metallic grade, contributing about 715 million tons of the bauxite. And the state support the plant of the aluminum extracted units like a Balco in Korba, 0.2 million tons, and that is having both alumina and aluminum production in the state. Next, please. As far as the limestone is concerned, that is about 5% of the national reserve of the limestone available in the states. So majority of the cement industries are there. About 17 major cement plants of the different companies are operational, and that is having about 35 million tons of the capacity for production of the cement. Next, please. Dolomite is having about 11%, and that to be dolomite available in the state, mostly in the flax and refractory grade, and being used for the steel and iron industries. Next. As I told, the diamond, that is having about 13 lakh carat of the diamond established, that is all in the resources. And it is in term of the India, it is about 4% of the total resources of the country. Next, please. As far as the tin is concerned, the Chhattisgarh is the sole producer of the tin, and about 36% of the Indian tin ore occur in the state, which is about 30 million tons. And it is, if we calculate the metal also, that is about 15,625 tons. And tin ore occurs in the southern part of the state, that is in Dantewada, Sukma, and Bastar. And mining has been done by the Chhattisgarh State Mineral Development Corporation. Next, please. Corand is also reported in the Chhattisgarh as a precious and semi-precious, and that is hardly in the form of a resources, very meager, and lot of scope is there subsequently to explore the corundum in the state. Next, please. Gold, also as I told, the potentiality of the gold bearing rocks are available, and the placer gold is widely recovered from the different part of the state, and some estimation of the resources has also had been done, which has been reflected in the National Mineral Inventory, and it is coming as a 5.5 tons of the gold, and that is a metal content, taking the cutoff as a 1.14 gram. Next, please. The state mineral policy also has been depicted by the Chhattisgarh government in the website of the Chhattisgarh DGM. But I feel like whatever the national mineral policy is there of the 2019, still some scope is there for further improving this policy, though they are also promoting that sustainable development has to be made, encouragement for the value addition in the state has to be done, and simplification of the procedure for grant of the concession also has to be made. Because yesterday also our chief guest was telling that there is a delay for grant of the concession. So until unless we are not able to bridge the delay of the grant of the concession, sometimes the deposit cannot see the light of the day. Next, please. So this is a depiction of the production also. Earlier I have shown the reserve. So these are the statistics only purely. If you can try to compare between the 2021 and 21-22, it is more or less having a hardly less than 10% of the increasement in the production quantity of the production. As far as the value is concerned, there is a sometime because earlier there was a pre-auction and subsequently there is a post-auction. So sometimes the enhancement of the value can be seen. State minor mineral concession rule and mining lease grant. But after this 2015, there the n number of the rule has been made. And they are actually the basic platform for facilitating the auctioning of the mineral block. Not only the auctioning of the block, first time that is now, whatever the report we are making, the geological report, that has to be evaluated as per the mineral evidence rule. So until unless it is not having a 2, 3 or 1, that will not be having a go through for the auctioning. So they are the just narrating mineral evidence rule, mineral auctioning rule, and other just like a atomic mineral concession rule. So that is I think already depicted in the websites, and now it is well known to the person who are interested in the mining sector. Next, please. And the gist of the reform, but I just narrated the rule. Actually, auctioning has came in a big way for grant of all the mineral concession. Then this concept of the composite license came. Earlier it was a RP-PL-ML. Now PL-ML has came. And district mineral foundation. Yesterday also there was a talk that where there is a mineral, there is a forest. Where there is a forest, there is a tribes. So what we are going to look for them. So this is a district mineral foundation has come to take care of the person who is residing in the mining areas, particularly the tribes. Then National Mineral Exploration Trust has came. The tenure secretary, the mineral surveillance system has been developed by the IBM to check the illegal mining. Then transferability of the mining lease, 100% FDI in the mining. This is a National Mineral Exploration Policy 2016 and star rating of the mining and sustainable development. And National Mineral Exploration Policy 2019. Next, please. This is a success story which is also depicted on the Ministry of Mines website. Total the block auction, very recent data, that is as on 29th July 2020. So if you go to the Chhattisgarh, total 13 blocks has been auctioned, and there the gradually number of the years. Next, please. I will tell what are the mineral has been auctioned. So these are the blocks which has been auctioned in the Chhattisgarh. So they are the limestone, gold, and this is for ML. It is for the composite license. Last, sir. This is a bauxite, and this is a few of the block has already been put for the notice for the inviting tender also. So this is also in the pipeline, means the block auction and subsequently block which is going to be auctioned. Next. So this is a list I have put up. How many block has been put for the auctioning also. So we can conclude, just read the last point. These are the legislative reform initiated by the government of India will boost exploration and exploitation of the mineral in the state, both in the greenfield as well as the brownfield. Only now there is a challenge for us that we have to convert whatever the resources is there into the reserve, and subsequently whatever the norm has been fixed by the government, we have to come our exploration work as per their standard. Then only we can see that fruitful results in the futures. Thank you very much, sir.
Thank you, Dr. Jain. It was a nice presentation. One question in case if somebody is interested to ask any query. I think nobody is coming. So why 10% increase in the production? Because of resources or because of policy or because else?
I will just tell. Actually, if I tell about the iron ore only, we are having about 300 million ton of the projection of the iron ore, this steel in the 2030. So until unless we will not increase our production, How we are going to?
Why 10%? Why not 12%, 15%?
It is a varying. It is not an, it is varying mineral to mineral. I just put up a average only 10%.
Okay, fine. But the question is, why that percent? Because of resources or because of demand?
Because of demand. It is a demand supply game only.
Okay.
Demand
So
supply. Because
demand is not there. That's why production is not increasing. Resources are there.
I will just take 1 second. For iron ore, we have imposed the duty of the 50% for the iron ore, for the export. Immediately the production is down because we are not cost competitive. The China iron ore is more cheaper than the Indian iron ore.
I can summarize in this way that resources are there, but demand is not there. That's why Chhattisgarh is not increasing production.
Sir, we are having for iron ore 100 up to 100-year resources are available with us. Thank you, sir.
Next presentation is on integrated exploration for elimination of uranium mineralization, a case study from southeastern margin of Chhattisgarh Basin, A.R. Mukundan. Please. 10 minutes and 5 minutes is for discussion. If you want to have discussions, you have to finish it in 10 minutes. Otherwise, discussions will be reduced.
Thank you very much, sir. Good morning, everybody. Just now we heard our good presentation on the uranium exploration efforts in the entire Chhattisgarh Basin by our director. My presentation is actually a part of that presentation only. I will be presenting on the detailed exploration carried out in the eastern margin of Chhattisgarh Basin. How sequentially we have carried out exploration. Next slide, please. The Chhattisgarh Basin and its environs have been one of the prime targets of uranium exploration by AMD because of its several favorable geological factors. Uranium exploration was carried out in Chhattisgarh Basin since 1916s. However, the uranium exploration was rejuvenated in Chhattisgarh Basin following the significant discovery by Dr. D.K. Sinha in the Juba area of in the lowermost formation of Singora group. And subsequently, several exploration ventures were carried out in the this entire portion of Singora Basin was taken up in a big way by AMD for uranium exploration. As a part of the regional hydrogeochemical sampling was carried out over an area of 2,500 square kilometers, covering the eastern and southeastern part of Chhattisgarh Basin and its basement, with a sampling density of 1 sample per 5 square kilometers. Next. Next. This entire area was covered. This has given number of hydrouranium anomalies. Next. Number of hydrouranium anomalies in the basement portion of Chhattisgarh Basin. This is the Chhattisgarh basin margin of the eastern margin of Chhattisgarh Basin, and this is the basement. This basement in the water samples we analyzed up to 130 ppb of uranium was analyzed. Subsequently, follow-up sampling of these hydrouranium anomalies have given a very good hydrouranium halo of 5 square kilometer area in Vishnupalli, Jikipalli sector, and this with an just 4 to 5 kilometers below the south of this Chhattisgarh margin. The hydrouranium values up to 400 ppb was also analyzed. And next. Then this area was taken up for follow-up ground radiometric and geological surveys, and a number of uranium anomalies were located in the basement, and these anomalies were following northeast, southwest, northeast, southeast trending fracture zones within the basement granite. Next. 7 such fracture zones along northeast, southwest, northeast, southwest direction in the basement granite over an area of 20 square kilometer was in Dulapalli, Dongripalli, Paraskol, and Sonavala sector were delineated. These fracture zones with individual mineralized, these red zones are individual mineralized zones within these fracture zones. These are having up to 1 to 8 kilometers of length, with widths varying from 2 to 15 meters in width. These intense cataclastic deformation brecciation was the characteristic of this basement, and these fracture zones could be traced up to the basement, this basin margin of the Chhattisgarh Basin. Next. This is a detailed portion of this fracture zone. We can see how the splay of fractures occurring in the basement, in the fracture zones and the silicified zones and pink granites occurring in the vicinity of these fracture zones. This is a part of Dungripalli fracture zone, the blow up of this fracture zone. Next. See, these are some of the photographs of these fracture zones having sharp contact with the basement granite. This is intensely cataclysized and brecciated within the basement granite, and this is the highly ferruginized breccia within this occurring within this fracture zone. If you see these individual fracture mineralized zones up to 600 meters to 2.5 to 600 meters length and 12 meters width, we can analyze, and uranium values up to 0.56% U3O8 has been analyzed in these fracture zones. Next. If we see what is the nature of the basement is Sambalpur granite, which consists of two variants actually, pink granite and grey granite, of which the grey granite is more dominant and it covers wide areas. Pink granite is actually confined to the marginal portions of the fracture zones, and this is petrographically these granites are biotite muscovite granite. They are paraluminous, corundum normative, and strongly differentiated S-type granites, and these granites are very fertile in nature, represented by up to uranium up to 24 ppm uranium and 20 ppm of thorium, with uranium by thorium values of up to 4.4. These at least the deformation, three phases of deformation have been seen in the basement granite with east-west, northeast, southwest, and northwest, southeast, one cutting the other. The earliest one is east-west. The northeast southwest is the intermediate, and finally it is northwest southeast. So this northeast southwest is the most dominant, and our uranium mineralization has been found in this northeast southwest direction only. Next. If we see the chemistry of the host rock within the basement, within the fracture zones, it is quite evident that basic magmatism has played a role in has been in place in the extensional fractures within this granite, and subsequent cataclysmic deformation, pervasive alteration has affected the host rock. However, we can see that MgO has not been much difference, but all the other major and trace elements have been, the chemistry has been changed of the host rock. Next, the fluid inclusion studies of the host rock has indicated that moderately saline fluids with 200 to 350 degrees have corroded the granite and removed the uranium from the granite, and it has been in place in the fracture zone. Next. Petrographically also, the rock is classified as protocataclysite and highly altered basalt. It comprises subangular porphyroclasts of highly altered basic rock embedded in a finely grained ferruginous matter. The porphyroclasts are highly altered, represented by saussuretization, and subangular patches of uralite and chlorite occurs. And the major uranium minerals in the altered breccia or cataclysite is branorite, followed by uranium titanium complex and uranium adsorbed on ferruginous matter. However, in some of the boreholes, we could identify uraninite and coffinite also in the subsurface. Next. Subsequently, we carried out to know the depth persistence, whether this fracture, what is the depth persistence of this VLF and magnetic geophysical surveys also we have carried out. And VLF has clearly brought out the conductive nature of these fracture zones, and magnetic also up to has shown this continuity of this basic these fracture zones within up to fracture zones along with this breccia up to 200 meters depth. Next. Now the subsurface drilling has confirmed this fracture zones within up to a continuity up to 150 to 200 meters, both along the strike. Next, both along the dip and along also the strike. Next. This is the longitudinal section of this area, Dulapalli area, and it has been confirmed the continuity of the fracture zones. Next. Till now, I was talking about the basement portion. Now, when we come to what is happening near the unconformity contact, where we could trace these fracture zones up to the basement, the cover sediments, and it is not continuing inside the basement, knowing the concealed nature of the basement. In some of the boreholes, we could we could trace the basement. Next, only one side, sir. Next, we could trace the continuity of these fracture zones beneath the sediment also in one of the boreholes in DDM 16, which has given good mineralization also. Next. In concluding, we have carried out integrated exploration in this part of the basin, basin margin, and depth persistence of the prominent fracture zones with uranium mineralizations have been identified, and depth persistence have been of up to 200 meters have been established. What I would like to conclude is that this is actually a prototype for unconformity related uranium mineralization. We have to see the areas where these fracture zones have actually reactivated after the sedimentation. That could be probably the locales for unconformity related uranium mineralization. Thank you, sir.
Thank you, Mr. Mukundan. Now the paper is open for discussion. Questions are invited. Otherwise, yes, please.
Yes.
Mike.
A very good presentation.
Thank you.
Yesterday there was a presenter from, I think AMD retired from Ceylon. He
Yeah.
shown some faults
Yeah.
which are running, starting from the southern basement to the basin and then again in the northern basement.
That was in Indravati Basin.
Yes.
Yeah.
So my question is, have you got the same set of faults in the eastern part of the basin? If yes, then what was the control of uranium mineralization? How it controlled the uranium mineralization in the eastern part of the basin?
The actually, if we see the regional picture, this is very close to EGMB, Eastern Ghat Mobile Belt. This trend and all is very parallel to Eastern Ghat Mobile Belt, and such kind of regional faults is absent, like Indravati Basin. However, these fracture zones, it is prominently it is occurring in the Orissa part also, it's in the Madhya Pradesh part also.
Thank you. Any other? One more we can take up. Okay.
Thank you, sir.
Thank you. Thank you, Mr. Mukundan. Now, the next presentation is from Mr. Vishal V. Okay, Vishal V. Sakre. The subject is, title is Geochemical Exploration in Peninsular India, a case study from Tatapani Geothermal Field, Balrampur District, Chhattisgarh. Welcome, Dr. Sakre.
थैंक यू देखिए सिन्हा साहब, आप सभी को मेरा प्यार भरा नमस्कार। अच्छा, जेब में डाल दो ना। ठीक, thank you. So today I'm going to present the geothermal exploration in Tatapani geothermal field. Actually, it's a very long journey. Journey started from 1983 and is 22, almost 4 decades. So within 12 or 13 slides to summarize the 4 decades of work in this Tatapani geothermal field is not easy. And we have carried out since then in 4 decades all the geological surveys, exploration, geophysical surveys, modeling, mathematical modeling, and whatnot. This Tatapani geothermal field has been extensively studied by GSI. So I tried to summarize it very briefly, and all, if anyone is interested to know in depth in GSI Nagpur Central Region, you are all welcome. We can have detailed discussion. So next, please. This is the Chhattisgarh state, and in Chhattisgarh, we are having two natural hot springs, one is Jhor and one is Tatapani. Tatapani hot spring is the part of the Sonata belt, Sonata Tapi lineament belt. This Tatapani is the most promising geothermal field in peninsular India, and it's having the highest temperature and very good signatures. And you can see this Tatapani, the hot spring temperature is 88.7 degrees centigrade. So in anywhere in India, except Uga and all, it's all in tectonic belt, Himalayan belt. In peninsular India, this is the most promising field. That's why GSI is trying to build a plant there since last 4 decades. Next. So here in Tatapani geothermal field, we are getting around 6 to 7 spouts, and the temperature ranges from 63 degrees centigrade to 88.7 degrees centigrade. And this geological setup which CGC and Gondwana is there, and in collaboration with ONGC since 1983 to 1990, we have drilled around 27 boreholes. And these 27 boreholes, out of this, we are get 5 to 6 boreholes are very promising, where we get temperature more than 100 degrees centigrade, which is very ideal for the installation of a power plant. Next. You can see this is the geological map of the area, and this Tatapani, all these hot springs, this is natural hot spring, what I was telling, 88 degrees centigrade temperature. So near this hot spring, we get this TAT 23 and around the 6 boreholes, promising boreholes, because this area is extensively explored by GSI. But the most promising zone we got in this place. And here this TAT 23 now we are planning to develop as India's first geothermal power plant here. But unfortunately, due to some technical reasons, some administrative reason, we could not install till date. We are since 90s we are in the mode, but during that time what happened, the availability of coal is abundant in India, and actually India we don't have that much of resources. That's why in 90s we could not. ने NTPC के साथ ना साथ में we had some MOU, and Dr. PB Sarolkar साहब, इनके guidance में, आज वो नहीं है यहाँ पे, but he must be watching in YouTube. So 19 करवे साहब, then 2013 से 16 तक सरोलकर साहब के गाइडेंस में हमारे पादभाजी साहब थे, और मुकुंद कुमार is sitting here, he is the worker, तो they have worked in this area, और एक DGPR सबमिट किया NTPC को for power plant, very big voluminous work, which includes all these sections of the geological part, drilling, exploration, MT survey, what not, isotope studies. And then NTPC also started to install a plant there. But again, some issues, financial issues, some technical issues, because no any Indian company was coming ahead to take this project. And for the foreign countries, was very small to take up. So all of issues, तो वो project नहीं हो पाया. Then next. So I will just finish this. So now, recently, then just before COVID, we started to explore this plant, their power plant in the Tatapani. I had a lot of meetings in the MNRE for the power plant, and it has got almost up to approval stage. 3 megawatt we was planning for 100 CR. Okay, but almost at the same time this corona crop up, and because of that then this project could not have been taken up. But now recently, now corona has chapter is over, so again we have started to take up this project. This is the geochemical studies in brief. I just want to tell this: water is sodium potassium rich water is there, and this Turner diagram also you can see sodium potassium magnetic plot shows that thermal water is immature and partially equated water. And the geothermometry we did, so based on the geothermometry, we assessed the temperature of 160 to 210 degrees centigrade. Next. This isotopic studies also we are carried out, we are having this MOU with BRC, they did for us. So here you can see all these deuterium and oxygen 18 isotopes, they fall in GMW line that indicates that the origin is isotopically similar to the hot springs. Whatever hot spring goes, water means the reservoir is same. Similar reservoir is there that we got, and because of this tritium value, we got less than 2. So that shows that the water is very mature. Means this geothermal reservoir is very only one reservoir and very old reservoir, and mature water is there. Next. This is the phase diagram. You can see his that TAT 23 borehole. We have selected this borehole. Actually, few boreholes are having much more temperature also, but out of these 6 production wells, at present, because this was drilled in 1990, now almost more than 3 decades, 32 years gone. So this borehole is still in functional stage. You can make a production well here. So now we have started, we have some meeting also to develop one at 23. You can see at this depth, we encounter the temperature of 100 degrees centigrade at 250 to 300 meter depth. And just below at this 110 degrees centigrade. So you can imagine this borehole is 350 meter depth. And here we got the 10 degrees centigrade. And we have proposed 2 kilometer depth of borehole, and we are expecting better results. We are expecting at least 130 to 150 degrees centigrade if we get. So this project, very good, very nice power plant we can install here. The thing is that now actually I am also working in Ladakh. We are along with ONGC, we are developing power plant in Ladakh also. But Ladakh and there, the working condition is different. That's why in Emery, when I used to go to meeting, I used to tell them, first start with this Tatapani, because of the geographical location, easy accessibility around the year we can. Okay, sir, I will go first. Next. This is the heat flow map of the area, 1 kilometer, 2 kilometer. You can see at 1 kilometer depth, 130 degrees centigrade, 0.569 square kilometer area we are getting, and 160 degrees centigrade, 2.145 square kilometer area. This data we got based on our 26 board wells, what we did. Next. This is the reservoir configuration. So you can see at 200 meter depth, we are expecting is only the inference, the whatever data we are got, because we are not drilled up to this. So we are expecting more than 190 degrees centigrade, but this is the hypothetical figure. If we get at least 120, that is also enough for a power plant. And these are the different. The reservoir is conical. This is the schematic diagram prepared by Dr. Vrs Analysis. And here you can see the heat sources there. Of course, this basement granulates are there, CGC is there. So this heat source and this heat is stored because of these Gondwana and upper sediments and protozoic rocks. And this is the Tatapani fault. So whatever metric water we are getting is water is being circulated deeply and coming out as a Tatapani hot spring. Next. You can see in 1990 when this borehole was drilled, the photograph, this 15-meter high artesian water. Then in 2014, when we start reopen the geothermal division, the same condition, the borehole we open is 15-meter high. Now recently in 22, we have captured one photo, same condition. So you can imagine last 3 decades, no change in the pressure, no change in the water. So this is really very, and of course, Gondwana is nearby this source of water. So I think what will be next. I will one video, please. Video. I just want to show the video clip so that it's not possible to everyone to go there, so you can visualize.
मंदिर पार कर देते हैं।
पूरे पेनिनसुलर इंडिया में ये सेटअप आपको कहीं भी नहीं दिखेगा. दिस इज द आइडियल फॉर मेकिंग प्लांट. A problem is that when we are going to have a plan there for 100 CR, of course India is money, 100 CR is a big amount. So that's why what we have just suggested in a recent meeting, why don't we go for a 100 kilowatt small plant for a 1 CR or 2 CR, only 1 or 2% of that budget. Because let's start, because if, until unless we start, we don't have the confidence of the stakeholders, the policy makers. तो इसीलिए नाउ, और उसमें एक और चीज में बोला कि अभी आपने देखा होगा जब 90s में बोरहोल ड्रिल हुआ था, इट वाज अ बंजर लैंड एंड फॉरेस्ट. 14 में थोड़ा डेवलपमेंट हुआ, टेम्पल आ गया, वो आ गया, बिकॉज हॉट वाटर, शिव जी का टेम्पल, एंड नाउ इट्स अभी मेला भरता है साल में एक बार. अभी तो मेला भरता है तो टूरिस्ट आते हैं. मैं उनको ये सजेस्ट किया कि आप 1-2 करोड़ लगाओ, बोरहोल इज देयर, उसको असेंबली रिपेयर करो, उसके ऊपर 100 किलोवाट का पावर प्लांट लगाओ, एंड टूरिस्ट अट्रैक्शन, जियो टूरिस्ट. Leader was very happy to see. Yes, it's good. 100 करोड़ लगाने की जरूरत नहीं, 1-2 करोड़ में आपका प्लांट आ जाएगा, जीरो टूरिज्म आ जाएगा. People will be happy to see the miracle of the nature. So now this proposal is well received by the leader, and shortly within a year or two, we'll see one plant, small demonstration plant will be there. Next. Very briefly, I will tell the geological calculation, resource calculation we have carried out. This resource calculation, we are estimate 31 megawatt for 20 years, but we are expecting at least 10 megawatt very easily we can tap from that geothermal field from Tatapani. Next. Utilization, already I have covered all these things. Next. This is the model of so many people may not be thinking how it is possible. So here you can see in the same Tatapani sort of thing, the heat source is there. Then this water we are getting the recharge and we are getting the circulatory system. Just what we will do, we will put one injection well in a compressor plant, not now. Now we are going to have a 100 kilowatt demo plant. But when we are going to set up a 3 megawatt or 1 megawatt commercial plant, we'll just take a water from here, is a steam water, then we'll run a turbine. The coal, what we burn the coal, we generate steam, and steam runs the turbine. Here we will not burn the coal. It's a green energy, clean energy. That's why it's in demand. We'll take this 120-degree water from here, and the steam will be generated. And based on this steam, we will run the turbines, and we can make a power plant. And water is wasted because we can't throw it because of the environmental issue, which is injected inside. So again, because this is the natural source, and it's not going to diminish, because of course Mother Earth is cooling, but the rate of cooling and survival of the human being is very, we can't this. So for the man, it will survive, and this geothermal energy is a future energy, because coal have the limitation, other things are limited, solar also having a limitation, but geothermal energy has no. And Yeah, fine, sir. Thank you, sir. Just I want to say that this is a classical geothermal based system. Then we will say only few hot springs are there. So how will cater the needs of the whole India? No, this is only the peanuts. We are now going to explore enhanced geothermal EGS because we are having granites. Above granites, we are having a lot of cap rocks. A lot of potential, all Deccan Tap, Chhattisgarh Basin, Dharwad, everywhere. And we are having all the to the source rock. In future, I attended some meeting also with
Dr.
this thing.
Sakre,
Sir,
I think you can
Sir.
answer in question.
sir,
Yes, please. Please. You can continue in question. Yes, please.
sir.
Sir, in the peripheral, I am from MECL.
Right, sir.
In the peripheral area, MECL has carried out exploration for coal
Right,
and
sir.
has established some shallower as well as medium deep deposits, coal deposits.
Right, sir.
But we drilled so many borehole in the
it is, sir,
logging those.
sir,
zones.
we have started it.
Yes,
We
sir.
have started it.
We are
Right, sir.
starting, and for sir helium, see,
Sir, we'll
when
take
the,
Dr. Sakre.
sir,
Now you are touching
right,
some other
right,
subject.
right, sir, right, sir.
Thank you very
Sir.
much, and all the best for this project. The next speaker can come to dais. You can continue. You can continue. I am calling the speaker. Yeah.
Yes, sir.
Yeah.
So being an intercontinental setup, not less, more than one
Please
or
connect
two
to
square
Raju
kilometers,
Bidbai.
sir.
Raju
So-
Bidbai, if he is available.
So that's the reason this has significance.
Not available. You are very right that it is a clean green energy. It is a need of the hour, and this has got a long implications. It is not Tatapani. It goes to Bakreshwar and it goes further eastward, and lot of scopes are there. As sir is saying, many things are there, and it is a new subject. We are also developing. It is not that we can say that it is perfect. Yes, please. Okay. Since the next speaker is not available, we are giving you.
That this hot spring is actually the source of heat is tectonic related, and that is CITZ particularly. And I have marked some area where Laumontite, it is a variety of zeolite. Laumontite is reported from my samples, and that is the actually indicator for hot springs. So can we expect some hot spots from Narmada Rift zone, all along the Narmada Rift zone?
Sir, whatever this veins or these minerals we get, we do the XRD studies just to know the temperature of the reservoir. Okay, so in the same line, if we are get some good, but depends. This whatever XRD minerals we study only from the hot spring water, because in the natural system also we get the veins minerals and we just study and we'll say temperature is 500 degrees. That
Dr.
doesn't
Sakre,
true.
when we can have further discussion. It is
Right,
a
sir.
very hot subject. I can
Right, sir.
understand. Just like your hot water. Yes, sir. Yes.
Sarguja was in Dhabi, and that occurrence was actually associated with Lomontite. But there is no hot spring there. And it is located within the granite, biotite, foliated biotite granite. Besides that, you have Patna in Layar, in Sarguja, which is also having that zeolite. Then there is Rajpur on the way to Balrampur. On the way to Balrampur from Ambikapur, you find a number of veins when you cross over from the road to eastern side. The granites are
A.K. Misra
actually
can
having
come.
number of
A.K.
veins
Misra.
of Lomontite. So the area has suffered zeolitization over a larger area. It is not confined only
Sakraji.
to
Sakraji,
Satapa.
thank you.
Okay, sir. Thank you, sir.
Please, A.K. Misra, please come. Thank you, sir. Thank you very much for giving good information. It was a nice, more than paper, that topic was discussed. In fact, it requires good discussion. Now, I welcome Mr. A.K. Misra, GSI Raipur, real from Chhattisgarh.
Yes, sir.
We are from out of Chhattisgarh, so you are from real from Chhattisgarh Basin.
Thank you, sir.
Lithium mineralization in pink and gold and brown mica, paraluminous granite and granitic pegmatite, western Chota Nagpur granite gneiss, Kathgoda, Chhattisgarh. Please.
Good morning, everyone. Myself, Asit Kumar Misra, and my topic of presentation is lithium mineralization in golden brown and pink mica of paraluminous hotspot for lithium in this area. The lithium bearing mica is not lepidolite. The lithium bearing mica is here is golden brown to pink in color. It is actually not typical lilac in color. These golden brown and pink color micas constitute about approximately 3 to 5% by mode in this granite and granitic pegmatite. These yellow color marks are showing the golden brown mica, and the pink color circles are showing the pink color mica. Here in the granitic pegmatite, the mica books of golden brown to lilac color books are showing. Next. Coming to the mineralogy, these granites are mainly composed of quartz, alkali feldspar, and plagioclase feldspar. It also contains tourmaline, lithium-bearing mica, fluorite, apatite, garnet, and beryl. Beryl, however, locally reported in this study area. This photograph showing the mineralization in the form of tourmaline, lithium-bearing mica, fluorite, and apatite, and the photomicrographs showing the lithium-bearing mica and fluorite. And apatite and tourmaline are also shown in this photomicrographs. Next. The golden brown mica and pink mica, those are lithium bearing, are separated from the granite and were studied for ICP-MS and LA-ICP-MS separately. In the ICP-MS low temperature acidization method, when we analyzed the pink mica, the lithium content in it was 1812 to 1873 ppm, whereas in the golden brown mica, the lithium content was 1605 to 1613 ppm. In LAQ ICP-MS studies, the pink mica yields lithium in the range of 0.1% to 0.4%, whereas in the golden brown mica, lithium content is about 0.1%. Spot analysis of this mica, especially the pink mica, were also done. And the spot analysis shows that lithium content in the pink mica is higher in the core, whereas in the rim, comparatively lesser. In the core, the lithium content ranging from 3000 to 4000 ppm, whereas in the in the rim, it is ranging from 2000 to 3000 ppm. The variation in lithium content from the core to rim is probably due to leaching, as it is a low temperature volatile element, because we know that lithium is atomic number 3. Besides the lithium, other elements like rubidium in it ranging from 800 to 8000 ppm, cesium 15 to 500 ppm, and niobium 80 to 783 ppm, as per the spot analysis by LAQ ICP-MS. Next. Vrs analysis were bedrock sample analysis of these granites were also done. Bedrock samples yield of this homogeneous granite in the range of 25 to 2000 ppm, in which mean lithium content was reported 451 ppm, whereas in the granitic pegmatite, the lithium content was in the range of 160 to 600 ppm, while the mean lithium content was 303 ppm. The lithium content in this granite and granitic pegmatite is 15 to 20 times higher than the upper continental crust content of this lithium. As per the visual estimation of modal percent of lithium bearing pink or golden brown mica is higher in the homogeneous leucogranite in comparison to the granitic pegmatite. The lithium values of the bedrock samples corroborates the same. Next. The pink mica especially were separated from the homogeneous leucogranite and were studied for XRF and ASF studies. And the pink mica was established a correlation with some international findings in some other setups. The analytical values derived of major oxide and trace elements so that the pink mica collected from the homogeneous leucogranite of Katgora area shows close match with the rose or pink pegmatitic muscovite found in New Mexico area of USA. Next. Besides the lithium, some other RE and RM phases were also found in this homogeneous leucogranite and granitic pegmatite. Apatite are found in good amount in almost all of the granite, and besides the apatite, monazite and bismuth, silite, and other TANB phases are also found rare to very rare phases. Next. Coming to the concluding remarks, homogeneous leucogranite and its cogenetic granitic pegmatite with visible presence of tourmaline, beryl, fluorite, pink, and brown mica are suggestive of highly volatile paraluminous nature of the melt. Granitic pegmatite appears to be cogenetic fluid-rich residue of coarse-grained tourmaline-bearing homogeneous granite. Granitic pegmatite and few zoned pegmatites is exposed in this area are similar character to the LCT pegmatite. However, homogeneous granite and cogenetic granitic pegmatite are most likely source of lithium and Rm mineralization in this area. Analysis of pink and golden brown micas by ICP-MS and LAICP-MS indicate lithium contents in it. This is also supported by XRD analysis which suggests that these mica are of polylithionite variety. Polylithionite is in the series of polylithionite trilithionite series. On the basis of field observations, mineralogy, texture and chemical compositions characteristics, the origin of lithium minerals in Katgora area can be related to differentiation and fractionation of paraluminous melt, mainly produced by the generation of partial melting of the metasedimentary rocks associated with the Nagpur granite gneiss complex. That's all. Next. Thank you.
Thank you. Timely you have completed. Okay.
Yes, yes. In the large scale map area, the areal extension is around 20 kilometer, 20 square kilometer.
Have you established any subsurface continuity of this lithium bearing pegmatite?
Actually, in this year only, GSI is taking up G3 stage item, and we are planning to drill up to a depth of 40 meter, and we will check the quality of lithium, whether it is increasing in the subsurface or not. And in comparison to the golden brown mica, which is less poor in lithium content than the pink mica, and we are aiming to get pink mica of higher lithium content in the subsurface.
Yes.
All this process, Grisonization.
No, sir. Actually, it is not in the form of grazenization. It is present especially in undeformed granite. There is no grazenization reported in this area. It actually the lithium.
It can be stewed. It can be stewed even in Mandla, where we worked.
Sir.
The granite, biotite granite has
Sir.
been stewed.
Sir.
And mica has been added. That is muscovite, ordinary mica.
Sir.
But here you have lithium bearing mica.
Yes, sir.
So a grisonization can take place without fracturing.
Okay, sir.
Any boron mineral?
Yes, boron is present there.
Stewed in its own juice.
So,
the words used by earlier stalwarts.
Sir.
A rock stewed in its own juice.
Sir.
It can happen.
Yes.
Okay.
Tourmaline is also there? Tourmaline?
Yes, sir. Tourmaline is also there.
Yeah,
Then, yes,
it's an interesting topic. I
Yes.
mean, bringing lithium into the presence there.
Yes, sir.
But some question, you are calling it as a golden and this thing. Petrographically, first you should have seen what are the properties which makes it distinctly different from lepidolite per se. That is one thing. Second thing is, you did laser ablation studies.
Yes.
Did you try any stoichiometric calculation to identify what is the real mica?
Actually, on visual estimation, sir, it is.
No, visual estimation is for quantitative mineral.
Yes, sir. Yes.
See, what I am trying to ask is, stoichiometry will tell you based on the oxygen of that calculation, you can identify what type of a mica is it. Is it lepidolite or it is a poly? And your XRD data, you said it, they have called it as lithionite.
Polylithionite, yes.
What is the structural parameters which made it to be called as polylithionite?
Stoichiometry part is not yet covered. Yes.
You can try it. This is a
Yes, sir.
suggestion.
Definitely
You
will
can
do,
take
sir.
it as a suggestion.
Yes, sir.
Because it's
Thank
an
you.
interesting topic which has to be further studied.
Yes, sir.
So now it is. Thank you very much for nice information, and
thank you, sir.
A good thing is coming out. Now it's 11:40, and I have been told that tea time is 11:40 time. So we'll break for tea because tea should not wait to us.
Thank you, sir.
So we'll again assemble after 10 minutes, and then we'll start this presentation, then the session will be completed. Thank you very much.
Rare earth potentiality in Bastar Craton, a case study of Daldali Kattagurum block in Kankai district, Chhattisgarh. Next slide, please. As we all know, RE is a critical mineral, a strategic mineral, and so it is important for nation building. From past few years, GSI is focusing on RE exploration. The outline of my slide. Next slide, please. The block is located in the southern part of Chhattisgarh Basin and in the east central part of the Bastar Craton, and is entirely covered by granitoids. Next slide, please. In 2016, GSI has carried out NGCM National Geochemical Mapping in topo sheet number 64 H/11, and as the outcome of the study, RE anomalous zone has been delineated in southeastern part of the topo sheet. So targeting that area, we have taken 100 square kilometer area for reconnaissance survey for rare earth elements, and mapping has been done in detail. This is the large scale map of the area of Daldali Kattagurum block, and here we can see that the southern portion is covered by granite gneiss or migmatite gneiss, which have the enclaves of quartzite schist, BIF, and putzite quartzite. Above it is the different variants of monzogranite, and these rock types is intruded by younger intrusives of dolerites, pegmatites, and quartz vein. Next slide, please. These are some of the field photographs of variants of granite gneiss. As we can see that in thin section, we are getting the mineral assemblage of K feldspar, Pli feldspar, garnet, sillimanite, and magnetite as accessory. These are the field photographs of variants of granitoids, and there are mainly three variants in our study area: pink fine grained equigranular monzogranite, which is intruded by patches and veins of pegmatites as well as epidote veins. Then comes the equigranular monzogranite. It has the composition of quartz, K feldspar, plagioclase, and biotite. And thirdly, a porphyritic granite with a phenocryst of up to 8 centimeter in size. And at places, the percentage of phenocryst is very high and the ground mass is less there. Particularly in those areas, we are getting pegmatites, which have some surface indication of RE mineralization. Next, please. These are the field photographs of pegmatite in the area. In the southern part, in granite gneiss, we are not getting much pegmatite veins or patches. These patches are the occurrence there is mainly weathered and fragmented type, whereas in the granitoids, we are getting the veins of up to 2 meter in dimension and also in the form of patches. And in these pegmatites, we are getting allanite grains, zircons, etc. The orientation of pegmatites is mostly in north-northwest, south-southeast, and also in north-northeast and south-southeast. But the mineralized pegmatites are mostly concentrated in north-northwest and south-southeast. Next slide, please. Geochemically, the granite gneiss falls compositionally falls in granodiorite field to quartz-rich granitoid, whereas our granite sample falls in monzogranite field and also in cyanogranite field. This is the chondrite normalized RE pattern. Here we can see the samples are rich in LRE and also fractionated in LRE, and europium anomaly is negative, and HRE trend is relatively flat. Next slide, please. These are some of the field photographs of mineralization in the area. Here we can appreciate the radial cracks formed by the allanite grains in first two field photographs. These are the allanite grains from the granite. The first photograph is from the host rock, and the second allanite photograph is from the pegmatite vein. And the zircon crystal has been found in association with these allanite grains. We have also studied the zircon crystals, allanite crystals under the microscope. Here we can see both zoned and unzoned crystals in the PPL, and analyte crystal is also showing good radial cracks under PPL. Next slide, please. Next slide. These mineralization has been confirmed by XRD diffraction studies. And also the 7 EPMA studies from the area has confirmed the presence of apatite, zircon, monazite, and other RE phases of minerals. During the course of mapping, we have done systematic sampling from bedrock as well as from the stream sediments. In stream sediments, we have mainly targeted the anomalous zone which was shown in NGCM, which came out of the NGCM mapping. And then in those area, we have targeted first and second order streams. And we have collected 8 to 10 kgs of sample. We have panned it, concentrated it, and then processed it for chemical analysis. In stream sediment samples, we are getting the values of up to 30,000 ppm, where LRE is high and it is up to 30,246 ppm and HRE is low. In bedrock samples, in the granites here in Dhanora, we are getting 11,800 ppm values, and we are getting the surface evidences of RE mineralization in this area. The allanite grains which I have shown is from this area. And also here in Devdongar, there is an overflow channel of a dam, Dudhava Dam. Here we are getting a network of pegmatites which has RE mineralization in it. And here from a BRS sample, we are getting 1500 ppm RE value, and here also we are getting 1100 ppm of RE value. So this is the contour map of the area on the basis of our study. We can see the stream sediment sample contour is concentrated in the southern part, which is underlain by granite gneiss. And here in the bedrock sample, we are getting the rock type is pink fine grained granite. Next slide, please. So on the basis of our study, we have delineated 3 zones. Next, please. This is zone 1, and here we are considering it as a secondary occurrence of placer type. Here the pan sediments and samples, as I have said, is giving the values of up to 31,000 ppm. Second, please. Next. Next. And this is zone 2 and zone 3. These zone 2 and zone 3 is occurring as a primary occurrence, and here also we are getting the signatures as I've said earlier. So next, please. On the basis of next. So summarizing my work, we can say that the field evidences, petrographic studies, and chemical data, Daldali Kattagarum block holds a potential for RE occurrence, and further detailed study can be done there. Thank you. Thank you, sir.
Lanite is the mineral.
Yes, sir. Sir, lanite is there in last slide, please. Sir, in where we are getting BRS, so here in this area, quantity. Okay, sir, in this area, in the veins, we are getting in almost in every vein there is allanite crystals. And the last slide which I have shown, that is the largest crystal in our area, and that is up to 7 centimeter in length and 3 centimeter in width. So in this area, we are getting surface. Yeah.
Just a minute. Then only
this is
lanite veins is a common thing.
So this is actually the very first stage study, and this is a very recent study. So
the same way you can total. Getting lanite is not a common.
Yes, sir.
But whether lanite is going to be a RE mineral, economic mineral.
So we are doing further studies for that. Yes, sir.
Thank you.
Thank you so much.
Oh, with this last paper, We are concluding the session. Thank you for giving this opportunity.
Thank you, sir, for chairing the session. And I want to again thank all the participants who presented their papers beautifully and in a very short span of time. So with that, we'll conclude the first session of second day of National Seminar on Chhattisgarh Basin and its environs. I would like to request Sri Arjuna Panda, Regional Director, AMDCR, and convener of this seminar, to please come forward and felicitate Dr. D.K. Sinha, who has chaired this session. Sir, would you please? And I would also like to request Ms. Devika from Nagpur University to come forward. Thank you, sir. With this, we conclude our first session, and now I'd like to request Mr. Pritam Karmakar to come forward and start session 5, that is second session of today. Thank you.
Good morning, one and all. Now we are heading towards our session 5. It will be based on geophysics and geochemistry of rocks of Chhattisgarh Basin and its basement. May I request Sri B. Sarvanan, Additional Director, Operation 1, AMD Hyderabad, to kindly own the stage for his keynote address on advancements in exploration techniques in AMD for uranium and other minerals in India. Please, sir.
Thank you, Karmakar. Good afternoon to everyone. My presentation will be on advancements in uranium exploration techniques for uranium and other atomic minerals in India. First of all, I would like to thank the organizers of this seminar for giving me an opportunity to present this AMD's capabilities on certain exploration techniques, particularly airborne geophysics and ground geophysics, as well as drilling. AMD has grown from strength to strength over the years. Since 1949, it was established under the Department of Atomic Energy. In 1949, 29 July, Atomic Minerals Division was originated as a rare mineral unit of DAE. It was earlier part of GSI, and later on in 1975, the headquarters was shifted to Hyderabad from New Delhi. And later on, Atomic Minerals Division, it became Atomic Minerals Directorate for Exploration and Research. So AMD basically, next please, is a premier geoscientific organization in our country. It has grown from few geologists to presently we have around about 600 scientific personnel with strength of 2,500 total. AMD is mandated with exploration and evaluation of atomic minerals, which include uranium, thorium, niobium, tantalum, lithium, beryllium, and rare earths. And not only that, we do exploration as well as research and development also. AMD has been on developing different exploration techniques as well, and also in the fabrication of different equipment for the survey of atomic minerals. Next, please. AMD's major activity is in field actually. Our activity, field activities include uranium investigations, rare earth and rare metal investigation, beach sand, another major work AMD does in the beach sand and offshore investigations. Uranium exploration we do by helibone. Presently it is helibone geophysical surveys. Earlier it was fixed wing airborne geophysical surveys. Now presently we changed over to helibone because we have to fly in a low altitude. And also we have developed integrated multidisciplinary field operations like geological survey, ground radiometric survey, ground geophysical survey, all these field operations are conducted, and we integrate the data and we try to identify the targets and take the exploration further. Next. Apart from field investigation, I mentioned we have laboratory capabilities, mineralogy, petrology, geochemistry, geochronology, analytical chemistry for characterization, and of course we have physical assay of radioactive materials. That is one of the strengths of AMD. And of course we have another mineral beneficiation for the recovery of different elements, particularly uranium, rare earths, niobium, tantalum. Apart from that, AMD also does mining plan approval for atomic minerals, particularly for atomic minerals, and as well as geotechnical investigations for DAE establishments like nuclear reactor and other facilities. As I told, we offer professional analytical services. Also, R&D projects with BRNS, Board of Research in Nuclear Sciences, and we offer studentship program and public awareness programs, and we have a training school, BARC training school of AMD campus. We train the trainee officers for 1 year before they are inducted as scientific officers. Next, please. First, we'll come to the helibone survey. AMD commenced its airborne surveys in 1955, right after the creation of AMD. It started, and that time the Domini aircraft, which was used in World War II, it was used as a platform, airborne platform, and AMD is one of the pioneering agency in airborne survey, and in that we used indigenously designed fabricated high sensitivity airborne gamma ray spectrometer with a large volume of sodium iodide crystal, along with the magnetometer. And later on, after 1970s, we developed our own high resolution spectrometers. Further later, in 1990s, with the development and deployment of global positioning system, GPS, our capability still, we could deploy GPS for further refined and fine data of airborne data were collected, and we normally deploy airborne gamma ray spectrometer, magnetometer. Presently, we have even inducted EM detectors. We deploy versatile time domain electromagnetic system. It was an advanced helibone gamma ray spectrometer, CCM magnetometer, and also we have gravimeter for airborne surveys. So I would like to tell that AMD is one of the pioneering in airborne survey, and we till date we have completed about 12 lakh line kilometers of airborne survey in our country. We have mostly covered the parts of Rajasthan, NDFB, Aravalli Mobile Belt, Gwalior Basin, Chhattisgarh Basin, Bhima, Kaladgi, Kadapa, Singhbum Sea Zone, and parts of Tamil Nadu. These areas we have covered with the objective of identifying targets for uranium exploration. Next, please. This is one of the pictures you can see here. This is the electromagnetic detector which is being flown. You can see from the helicopter, it is off way. You can see a magnetometer. Further down, we have a loop. It is a transmitter as well as receiver loop. You can see inside inside ring is receiver, outside is the transmitter. This is our electromagnetic system.
शेयरिंग बंद हो गई
Here the serpentinized peridotite, which is having the polymetallic mineralization like uranium, chromium, nickel, molybdenum. Yeah. You can see the boral section here. This is a predated body. Here you can see the mineralization is dipping towards south, and you can see any mineralization is marked as red bands. So we are getting a very continuous uranium ore band, and we have explored about 1,000 meters along the strike, and along dip also about 1 kilometers, and we have almost established a small deposit. It is located near Choramdi, and it will be mined maybe very shortly. We hope that it will be mined. Next. Yeah, this is 3D ore body model, 3D model of the Mudala ore body. You can see, as I told earlier, we deployed a different software. Also, we use data mine. By using the data mine, we have prepared this 3D ore body model, wherein we can plan our boreholes, and we can plan. Ore reserve estimation, all those things we do. Next. Yeah, further, we are planning to upgrade our instrumentation again. We are having some R&D projects with BRC, Baba Atomic Research Center, also with IGCAR Pulpakam, wherein we are trying to develop a squid-based magnetometer as receiver in the airborne electromagnetic systems. So this is one of the very significant development we are envisaging for the future. Next, please. Next, when we come to ground geophysics, these are the various instruments we use. Like we have acquired CG5 gravimeter, CG6, all those systems we have. We have GeoVista multi-paralogging system for boreholes. Next. By using this ground geophysics, we are deploying it in many of our exploration areas, where we use it for planning the boreholes, particularly planning the boreholes. We use this ground geophysics. One success story I would like to bring to your notice is that microgravity survey in Marlagalla sector of Karnataka. Here, the pegmatites are intruding into the Nagamangala schist belt. So the schist belt is basically amphibolites. They are basic rocks, and within that we have got this pegmatite intrusion. And here, as lithium was discussed in our earlier paper, lithium occurs in this spodumene. Yeah, pegmatite is a host rock. So we deployed this microgravity survey to delineate the pegmatite zones. Of course, we are knowing that it is there, but to use it for planning the boreholes, the microgravity survey was conducted, and we have delineated the. Next, please. This is a microgravity map. We have delineated the pegmatite bodies. This is all soil covered area. Here we are drilling here in this western part where exposures are there. So when we conducted microgravity surveys further east, we got some low gravity signatures, which was interpreted as pegmatite bodies. So here when we drilled, we got the pegmatite as well as the spodumene mineralization. So this is one of the case study, and we can say success story for this type of survey. Next, please. Next is our one of another strength of AMD, I can say, is drilling campaign. Wherever we do drilling in AMD started in 1951, soon after its creation. And when the AMD has contracted an outsourcing to the associated drilling company, and we drilled in Jadugoda, Kaneloka, all those areas. Later on, we AMD started acquiring our own drilling machines. Presently, we have about 33 drilling machines, that is 17 hydrostatic machines, that is latest state-of-art technology, and 16 mechanical rigs. So this is what we have. And till date, AMD has drilled about 25 lakh meters of drilling has been done in all over the country. It is 2,568 kilometers. Next, please. Recently, AMD has adopted a different approach to increase the productivity of drilling. So we can see we have started acquiring hydrostatic rigs. Earlier we had these mechanical rigs and all limitations are there. So earlier it was 3 meters per day was our average drilling per machine per day. Now it has gone up to 12 meters per day per rig. So still we are trying to improve on this. Our approach has been earlier each rig will be deployed at remote places and it will be drilling. There will not be any support, limited support for the drilling crew and all. Now we have changed and we are putting a cluster of 3 or more drilling rigs in one area, so they'll be having supporting each other in different aspects. So this is one thing, and accommodation for drilling crew. These are all these infrastructure things have improved. Next. This is another aspect we have improved on that. Increase the working hours of the drilling rig. Earlier it was exactly the office hours like 8 to 4. Now we are deploying, our crews are working right from morning 6 o'clock to evening 6, sometimes much later also. So this is how we have tried to improve the working hours as well as the productivity. So we are inducting these state-of-art rigs and improvement in drilling technique. And also another thing what we have adopted is outsourcing the support services for drilling. This is one of the major changes we have brought in. Next. These are the few rigs pictures. This is one of the old rig, Calyx rig. It was in 1950s. It was deployed in Singhbum shear zone. These are presently hydrostatic rig we are using. Next, please. You can see our drilling productivity we have shown right from 1951. Here you can see we have drilled 1951 to 1960. In 10 years time, we have drilled only 54,000 meters of drilling. But presently you can see in 2011 to 2021, we have drilled 13 lakh kilometers. Sorry, 13 lakh meters. So you can see after 2000, we have improved a lot. We have inducted these hydrostatic rigs and we adopted that other measures to increase the productivity. So we have been successful here, and AMD presently has become a benchmark among the other exploration agencies in terms of drilling, quantum of drilling. We envisage to take up about 5 million meters, 50 lakh meters of drilling in next 15 years. This is one of the major challenge we have created for ourselves. Next. These are the, already I told, we have a very strong instrumentation group where we develop our own instrument and we have a very good backup for any maintenance and other upkeep of the instruments. We have airborne gamma ray spectrometry, ground gamma ray spectrometry, borehole geophysics, and laboratory and mine assay system. Even for mine also we give the support like bulk uranium analyzer, online analyzer, and the mine entries where the ore is brought out, there itself it will be assayed for uranium. Those type of equipments we have developed. Next, please. These are the other some of the one drill scanner we have. It is under development stage. It is not at the imaging part we have completed. We are trying to put in the radiometric part. We want to assay as the core moves. So the core is kept here and it moves like this over the detector. This is a gamma ray detector, and still it is under the development. So we have thermal logging system developed by our own team, borehole fluid sampler, then DPS based spectral logging system, borehole trajectory logging system. This is for the to find out the deviation drift of the borehole. So this is also developed by our own team. Next, please. Yes, here I want to emphasize the productive areas for uranium resource augmentation. These are the few areas where AMD is putting our efforts, like NDFB in Rajasthan, where Rohil mine is likely to come up soon, and we are exploring all the adjoining areas like Jahaj, Ladikabas, Giradek, Adani, like that. And Singhbum Sea Zone, because this is one of our earliest deposit, Jaduguda. And also we are continuing the exploration of the extension areas of the all these uranium deposits. Then Bhima Basin, of course, is one of the good grade deposits, uranium deposits of our country. And Tumalapalli, we have a mine already in place where AMD has established deposit more than 2 lakh tons of uranium in this group of deposit. So our objective in Singhbum Sea Zone has been to explore the areas which is adjacent to the existing mines and mills, so that the equipment of the mine and mill can be utilized for extended time. We can enhance the lead time of the utilizing existing infrastructure facility of the UCIL. Next. AMD also is involved in RE exploration in India. Apart from the beach sand resources, we have also working in other hard rock areas of carbonatite complexes of our country, like Ambadongar, Sung Valley, Mikirils, Sevatur. Ambodangar, we are actively working on that. Apart from that, in Rajasthan, Sivana ring complex, here also we are actively engaged in exploration. Next. These are the beach sand investigation area where we explore monazite, rutile, ilmenite, sillimanite, garnet, leucoxene, zircon, all these minerals. Of course, we have about 12 million tons of beach sand minerals, out of which about 1.2 million is monazite. Next. This conclusion, AMD has been evolving the exploration techniques being adopted, and we have been improving on the instrumentation part and as well as the interpretation of airborne geophysical data, and also our drilling approach for the drilling equipment and drilling technology. And we have been successful, and till date AMD has proved about 360,000 tons of uranium. Next. Thank you. Thank you for patient hearing.
Thank you, sir. May I request Sri Sharvanan to kindly chair the session, and may I request also Sri M.D. Satyanarayana to serve as reporter. May I request sirs to kindly conduct the session.
As one of the tools for investigation, uranium exploration. Because I can give an example. We have been working in Mogra area in Maharashtra state, in Gondia district. The earlier concept was quite different. When I studied the rocks under the microscope, I found that the entire column of sediments there was hereditized. I was ridiculed for saying all this, stating this, giving report. But when some boreholes were drilled, we found apophyses of granite, not exposed on the surface, but we encountered them in the boreholes. This was all because of microscopic studies. So this is also an exploration tool which should be included in approach towards solving many problems. The concepts completely change.
Sir, like to mention here, sir, your suggestion is really good, and we have already adopted, sir. Actually, what I presented is about AMD's exploration in field areas. Now we have developed our own laboratory. Yeah. Yes, sir. Yes, sir. Those things we are doing, sir. And there will be a presentation, sir, on laboratories techniques adopted by AMD.
And viewing it under the microscope, both are very, very important.
Yeah. Thank you, sir. Thank you. Thank you for suggestion. Now we'll start with the session 5, which is on geophysics and geochemistry of rocks of Chhattisgarh Basin and its basement. First paper is titled as Basinal and Crustal Configuration of Chhattisgarh Basin, Central India, Insights from Gravity and Magnetics. Dr. S. Srinivas, GSI, Hyderabad. You have 10 minutes for presentation, 5 minutes for a discussion. Please stick to the timing. Yeah?
Respected senior dignitaries from various organizations, ladies and gentlemen. Today I would like to give the basinal and crustal configuration of Chhattisgarh Basin, Central India, based on insights from gravity and magnetic surveys. Next slide. We have taken two profiles, two geotransects cutting across the Chhattisgarh region, one in east-west direction and the second one in north-south direction, from Sakoli up to Tappa, Raipur and Sohela, and from Jagdalpur, Dhamtari up to Bilaspur. So this gravity and magnetic data we have acquired with 1 kilometer station interval, and the regional geology is adapted from the quadrangle sheets of GSI, Raipur, Mahasamund, Kondagaon and Dhamtari. This is the Chhattisgarh Basin Geological Map. Next, please. This is the background information as already we have discussed for the last one day. Only thing I wanted to tell here is a deep borehole near Durg indicate granite basement at a depth of 800 meters. This is one thing. And the second one is the Jabalpu earthquake. This Jabalpu earthquake occurred in 1997 May. And prior to this, when Latur earthquake occurred in 1993 September 30, Department of Science and Technology has established a broadband network throughout the country. And there was a station at Bilaspur, which has calculated the thickness of upper crust as 14 kilometers and the lower crust or the mantle, upper moho, around 40 kilometers. This is the crustal structure of Bilaspur. So these two factors and thickness of lithostratigraph succession based on various others like Datta, Murthy, and this Das et al., they have given around 2.7 kilometers. This background information we have taken for modeling the gravity and magnetic data. Next slide, please. This is the aerodynamic image of the area. There are two strong east-west trending lineaments are there, magnetic lineaments, in the southern part of Raipur. Similarly, this Indravati basin up to this Raipur side, there are two northwest-southeast trending anomalies are also there here. The rest of the basin is showing some more or less a low anomaly. These low anomalies indicate that the thickness of sediments is more in Hiri sub-basin, northern part, as well as the Baldwat Sub Basin. And the southern part of the basin is slightly, the basement is at a shallow depth. The Sakolis and the Sonakan Greenstone belt, they are reflected in the form of moderate anomalies. So this is aerodynamic image, sir. Next. Next, please. Next. So this is the gravity profile and this is the magnetic profile. You can see that from Rajnandgaon, near Tappa, this Rajnandgaon up to Tumgaon, this particular Chhattisgarh basin is in the form of a gravity high of about 30 milligals. Over a length of entire basin, you can say otherwise 150 kilometers of the hilly sub-basin. And the Sonakan Greenstone belt is reflected in the form of a gravity high again. And the Baldwat Sub-basin is also reflected in the form of a gravity high. The Sakolis and the this Dongargarh supergroup, they are reflected with some high zones corresponding to the acid and basic volcanics. Otherwise, it is a broad low. We can see that from this gravity profile and magnetic profile, there is a prominent gravity high as well as magnetic high. In both the profiles, there is one-to-one correlation is there. From Sakoli up to Sohela, crossing across the Chhattisgarh Basin. So we have divided the entire profile transect into 4 parts. This is Sakoli belt and Sona, this Dongargarh supergroup, hilly sub-basin, the Sonakan Greenstone belt, again Chhattisgarh Basin. We have modeled the entire transect. We have modeled both magnetic and gravity, and what could be the possible cause of this gravity high that we wanted to look. Next. This is the north-south profile data. Here, this is the Indravati basin, followed by this Kondagam granular terrain, and followed by this from here. This is the hilly sub-basin of Chhattisgarh Basin, and in both the profiles, we have Raipur is the common point. You can see number of bipolar anomalies are recorded over this. These bipolar anomalies indicate within Kondagam granulate, they are the BMQ and BIF bands, whereas within the Chhattisgarh Basin, these bipolar anomalies, they indicate the basic intrusives into the basement. Next. Next. For east-west transect, we have attempted a low-pass filter in which high frequencies were removed. This particular blue line indicate the deep-seated feature of about 10 to 12 kilometers. So again, this gravity high is standing over Chhattisgarh Basin. Similarly, magnetic high also is standing. Next, please. Now, the northern transect also. Here, our Kondagam granular terrain, we are getting a gravity high. Again, in the case of Chhattisgarh Basin, this gravity high is there. But in Raipur, around Nandaghat and Simga and Bilaspur, there is a prominent low is there. That may be indicating the thickness of sediments is more around Nandaghat and Bilaspur. One thing you can see here, in both gravity and magnetic profiles, there is a good correlation. That is the beauty of central India, not these profiles. I'm not talking about these profiles. My observation is that whatever geophysical work you do in Chhattisgarh region, you please do in east-west direction, because most of the belts are north-south oriented, and the response will be there. 1-to-1 correlation will be there between gravity and magnetics. Next, please. So these four segments we have taken. We give some magnetic susceptibility contrast we have given. Whatever quadrangle map geology is there, those bodies we have taken and the modeling we have carried out. These are the basic volcanics and these are the acid volcanics. These acid volcanics are extending up to 3 to 5 kilometers, whereas the basic volcanics they are extending up to 8 to 10 kilometers. And the susceptibility for this basic volcanics is around 600, whereas for acid volcanics it is around 100 to 200 only. This is the first segment. Second segment, next. Next, please. This is the Raipur, Rajnandgaon, Raipur, Tumgaon section of our hilly sub-basin. Here you can see this is the basin configuration, this yellow one. Raipur to Rajnandgaon, it is slightly shallow, whereas from Raipur towards Sonakan Greenstone belt, that side it is slightly deeper. It comes around 3 kilometers this side, and this side it is coming around 2 kilometers only. And here near Durg, that particular thickness we have fixed. That 800 meters basement thickness we have fixed for this modeling. And to explain this magnetic highs, we have to put some basic bodies at a depth of extending up to 10 to 12 kilometers. So based on this model, we can say that the central part of the Chhattisgarh Basin is underlying by basic volcanics, whereas the peripheries are coming with acid volcanics. Next, please. So this is the Sonakan Greenstone belt. These greenstone belts, they are extending up to 3 to 4 kilometers, whereas the basic bodies are extending up to 8 kilometers. Next, please. This is the Baldwat Sub Basin. Here, the Singora group, these things are there. And the basin thickness is very shallow here, 400 to 600 meters only. Next, please. This is the, similarly for northern transect, Indravati Basin, it is covering around 2.5 kilometers. Next. This is the Kondagaon granulate terrain. These bipolar anomalies are interpreted in the form of BMQ, BIF, and dike-like bodies. So these are the depths extending. Next. Next. So this is the over this Kiri sub-basin coming from Damtari up to Bilaspur. This Damtari here you can see the basin thickness is more. And this particular break is also a major fault at a deeper level, not at shallow level. Now next. This is the east-west transect from Sakoli up to Sohela. This is of about 400 kilometers. You can see that from Rajnandgaon up to this Tumgaon, this is the Chhattisgarh Basin configuration. Whereas these red color, these are the basic volcanics, and these are the biscuit color, these are the acid volcanics. So based on this, you can say whether we can connect like this, I don't know. But the Chhattisgarh Basin is underlying with basic bodies in the central part, and the periphery are acid volcanics. And whatever detritus to the basin are developed, they are from here, this side it is from Sakolis and Dongargarh supergroup, and this side it is from Sonakan Greenstone belt. And these basic bodies are extending under the basin also. Next, please. Similarly, for northern transect also, northern transect, if we take lot of basic bodies are there, these are the things. Next. After this, what we did is we have modeled the gravity profile also for the 400 kilometers, taking density as the key parameter, and we have calculated the thickness of the Sonakan Greenstone belt. It is up to 2 kilometers, and the schistose rocks are extending 1500 meters like this. The upper crust is coming around 13 to 16 kilometers. With gravity high, where we have observed our Chhattisgarh Basin, it is 13 kilometers, and the Sakoli and the Sonakan Greenstone belt, they are giving around 14 to 16 kilometers. And the Moho is at a depth of around 38.5 kilometers, and the Chhattisgarh Basin gravity high, we are attributing to 2 kilometers Moho upward. Next. So this is the model. This is the basic configuration. These are the schistose rocks or the basic volcanics associated with the Dongargarh supergroup. This is the Sonakan Greenstone belt. This is the upper crust. These are the undulations in the upper crust, and this particular gravity high, you can see that there is a shallow crustal thickness, upper crustal thickness, and Moho level also, it is slightly 37 kilometers, whereas at end it is around 39 to 40 kilometers. Why I am telling these models here, Durg, here we have fixed our this one borehole position. we calculated the thickness around Raipur, it is coming around 800 meters. Next slide, please. Next. In this one also here near Raipur, we have fixed the thickness is coming around 800 meters. From both the profiles, the thickness around Raipur is coming around 800 meters only. And there is one ridge-like feature we have noticed below Raipur. On either side of this Raipur, the thickness is more. Similarly, this Nandaghat Bilaspur section also, there is a high thickness of sediments is higher. These are the basic bodies of BMQ, BIF bands of Kondagam granular terrain. Again, here also this Mohawk warping is there to explain the gravity high. Normally, suppose if Chhattisgarh Basin sediments are not underlying by any high density material, you should have got a response like this. This is our Chhattisgarh Basin, hilly sub-basin border, northern part. But what we are getting is we are getting a very prominent high anomaly of about 20 to 30 milligals, which is running for a distance of about 150 kilometers. Such a prominent gravity high anomaly cannot be explained with the help of Chhattisgarh sediments. So to explain these things, last slide, sir. To explain these things, we have to put this high density material, which I have shown in the case of magnetics, then followed by the upper crust. And because of Jabalpu earthquake, this is a normal two-layered crust. And whatever heterogeneity is there may be extending up to 8 to 10 kilometers. After that, it may be a simple two-layered crust only. Next. This is summary, sir. Next slide.
Yeah. You have taken a very good transit east, west, and north, south. My question will be, what is the outcome for diamond related exploration if we see your north, south, or east, west, if possible? That is one thing. And what about Trans Chhattisgarh lineament? Have you delineated on your profile? It is parallel to your east-west profile, and it is a very 500 kilometer. It is there in your this one.
That aromatic image, sir. Bottommost two passing. First slide, first. Go back, go back.
It is a very important feature of Chhattisgarh Basin.
Yes, yes, sir. Back. That aromatic image. Yes. So these are figures.
Section, if you can show me.
So this is the section, sir, actually. These particular magnetic high anomalies, these are the two lineaments.
This should be cut by your north-south transit.
But so, east-west also falling.
What speciality you are getting? Because it is a unique feature of Chhattisgarh Basin, basement rather. So have you picked up that thing in your...
That gravity profile, the 30 milligals gravity high is there, sir. In magnetic also that high is there, which is passing along this only. This transect only.
No, east-west, can you...
No, you just back.
East-west profile.
No, I will.
If you
I will show you.
Pinpoint
that. Back. Our back. So this one, sir. These transects, those lineaments are falling here, sir. This is our transect. So that's why I am telling that 30 to 40 milligals, whatever gravity high we are getting.
No. You not get special. It is a east-west, so your north-south transit should cut it. So what evidence are you getting? That is the question.
That BMQ, BIF bands?
No, it is not BMQ.
No.
The ultramafic.
No, maybe. I'm accepting basic volcanics we have classified. You please show.
It is not basalt, it is ultramafic.
Basic volcanics I told.
Okay, we'll see.
No, that is based on our quadrangle sheet maps only.
So it is not. It may not be dolerite, right?
No. BMQ, BIF, dolerite dikes.
But you have written dolerite dike. That's why.
That Kondagam transect we have taken from the quadrangle sheets, the geological bodies, and those bodies only interpreted, modeled. But that response is there, sir. Just you, two more slides.
Could you answer?
Just bottommost, please. Next. This one, sir. Sir, whatever you are telling that this Kondagaon, this up to here, Dhamtari, these bipolar anomalies, all these are cutting that north-south transect only this one. These all are cutting across that east-west body. East-west, whatever lineament is there, that lineament is like this. Pyramid map is low altitude combined map of entire area.
No. What is the flight height and what is the line spacing?
Line spacing will be 2 to 2.5 kilometers.
It is analysis map. It must be 2 kilometer height and 5 kilometer line spacing. So you cannot get the Chhattisgarh element which is 500 meter width in this map. So that is only 500 meters. This
500 kilometers.
No, it is spread is 500 kilometer, but width of this lineament is 500 meter.
Okay.
So this is a very regional scale map which is giving only the deeper part.
Which is giving?
It is only the deeper part of signaling it is giving, because it is 2 kilometer height and 5 kilometer line spacing. So it is very high, low resolution.
It's not a low altitude one.
So your all the models, which is modeling, you have done it with the gravity map and that. So there is no calculated values of this.
Exactly matching, almost matching.
Yeah, exactly matching. If you give it,
Yeah.
becomes more reliable. If
Yeah.
you give the calculated and as well as observed one. So it is only showing the calculated.
It only confuses more. It was calculated, taken care.
Okay. Any question? Any more question? Yeah. Yes, sir.
It's a nice interpretation, and by this way, we find that the thickness of the sediments around Durg, Bhilai, and Raipur is the least as in comparison to the
Northern.
basin, northern part and other. So far, we are working only in the northeastern part and then Singora Basin, wherever the things are exposed. As our Dr. Sinha said that he discussed about that borehole in the where we got the mineralization along the unconformity was drilled by sail. The question to, it's just suggestion to chairman also, that we can try for the drilling few boreholes around Durg, Bhilai and Raipur, as the thickness is less and we can, it is not more than 800 meters. So we can just try few boreholes.
Already Bhilai steel plant has gone up to basement. That is 810 meters or something.
Only one borehole
One
they
borehole.
drilled. One borehole they
Long
drilled
time
and
back.
GSI drilled one borehole or two boreholes.
Long time back, around 1990s.
Oh, yeah. I know about that borehole. That has given even 0.2% value in that. Though the average is 0.27 or so.
Same borehole, sir.
Oh, same borehole, sir. So one borehole in that stadium.
Yeah.
We have got record. It was logged by physics unit. Thank you.
Thank you, sir.
Thank you, sir.
Your suggestion. Thank you, Dr. Srinivas, for your very nice presentation. Thank you.
Thank you, sir.
very much. Next presentation will come from AMD, that is Satish, Mr. Satish. Title of the paper is A Pair of Magnetic Lineaments Across Chhattisgarh Basin and Adjoining Basement Rocks, representing a pre-Proterozoic fossilized megafracture zone at the basement of the Chhattisgarh Basin. Yeah, Mr. Satish.
Good morning, everyone. I am Satish from Central Region AMD Nagpur. Today, I am going to deliver my talk on a pair of magnetic lineaments across the Chhattisgarh Basin and its adjoining basement rocks, representing a mega fossilized fracture zone. Next. Adjoining basement rocks and southern Chhattisgarh basin parts are traversed by a mega regional lineament. This lineament was first reported by Sri K.B. Anantaraman in 1984. This lineament is characterized by two magnetic low lineaments, and some places it's got merging into single one. And he posted this east-west lineament over the gravity contour map of 5 milligal. But we did some ground gravity surveys along the surveyed profiles. There we got only 0.4 milligal anomaly variations only. And there is no geological expression has been observed over the surface. Next. As they earlier described, there is no collaboration between the this east-west magnetic lineament and Boger gravity anomaly. There is no east-west trend of gravity anomaly in it. Next. This is the studied block of Sri Anand Raman. So what we have done, first we tentatively digitized the location of the lineament and we placed on the geological map. Next. From this lineament, first we have re-verified the lineament, and we planned for the extension toward the western direction with a line interval of 10 kilometers. And we have carried out 13 magnetic profiles and 3 gravity profiles. Next. From these ground profiles, we can clearly observe the 2 magnetic low lineaments. In western side, there are 2 magnetic low lineaments, and eastern side, especially at the margins of the southwestern southwestern Chhattisgarh Basin, it's got merged into the single one. Next. We plan to extend this lineament towards the east direction also, but because of the limited time frame, we couldn't do that. So we had to take the aid of available geophysical data sets of north-south profiles of aeromagnetic data from GSI, which is high altitude data of 2 kilometers flight elevation, and low altitude data of AMD with 120 meters elevation. By collaborating all the next slide. By collaborating all the data, we brought it onto a single platform. These are the blocks of compiled data. From these blocks also, we can see the magnetic low lineaments which are traversing from eastern side Sambalpur granite basements to the southeastern Chhattisgarh Basin part. Next. These are the magnetic flow lineaments, and these lineaments are showing amplitude variations. These amplitude variations are corresponding to the sediment deposition over the basements. That means where the depositions are high, there we are getting the low altitude. That confirms that this lineament is confined to the basement and it's following the basement topography. So this is, we can say it as pre-proterozoic age. Next. These are the characteristics of the magnetic lineament. This magnetic low is the amplitude of -500 to -1500 nanotesla, and the anomaly width is ranging from 500 meters to 1500 meters, and the southern anomalies are smaller in amplitude compared to the northern one. And the gravity profiles also carried out along the survey lines. There at some places only gravity anomalies are following the magnetic anomalies, and at all the locations gravity is not collaborating with the magnetic. So we vomited out the gravity values, and we only all the interpretation is carried out by using magnetic anomalies only. Next. By using the conventional one-dimensional Fourier transform, we have calculated the causative source depth. Next. From the profile one, which is falling over geologically over the Kairagat Basin, depths are estimated around 400 meter, and southwestern Chhattisgarh Basin, we have carried out the we have estimated the depth around 335 meters, and next. And over the granitoid basement, Sambalpur granites, we have estimated the depth as very shallow, is around 55 meters only. Next. And the plausible geological models has been developed and shown here from the models. The nature of this lineament fracture zone is vertical to subvertical, and this lineament is mega fossilized. Next. From the all the depth estimations, we try to configure out the basement topography by which values got from the one-dimensional FFT and conventional profile analysis. From this depth basement topography, over the Sakoli group of rocks to DKI, depths are varying from 100 meters to 200 meters. Wherever the southern Chhattisgarh Basin, it's ranging from 300 meters to 600 meters. And over the granitoid basements, west to the Shingora Proto Basin is 100 to 200 meters. And east of the Shingora Proto Basin, depths over the basement granitoid is 30 to 75 meters. And over the Shingora Proto Basin, it is ranging from 100 meters to 220 meters. Next. Okay, by further ground checking, we have taken out the topography data and we have chosen out the low elevated land area. So there we went there and we have observed two high magnetic Bisley Rayleigh ridges, which are perfectly aligning in the east-west trends of the magnetic lineaments. But unfortunately, the area is soil covered. We couldn't get any ground validity. Next. These are the east-westing ridges south to the Chhattisgarh area, which are aligning with the trends of the east-west magnetic lineaments. Next. In addition to this, we have loaded the quadvine locations from the Bukos data, which is 1 lakh scale, and a few quadvine locations near the basement of the granitites and Shingora Basin are aligning with the east-west magnetic lineaments. In the same sense, we have observed a few more quadvine locations parallel to the east-west direction. It's paying the interest to show the check the existence of this work towards the east of this granite basements and eastern Ghat mobile belts. From the next. From all the cumulative work, Sri Anantaraman estimated the lineament stretch about 100 kilometers. By using our ground geophysical surveys, we have extended to around 230 kilometers like that. But after the compilation of all the data, we have estimated the lineament strength over about 450 kilometers. And one more thing is this can be mega fossilized fracture zone, and it is traversing beyond the Chhattisgarh Basin boundaries. So we can call it as transversal crater magnetic lineament. Next. Thank you.
Mr. Satish. Thank you. Now I'll admit questions. We have 5 minutes now. We can have a few questions.
You have you integrated your geophysical data with the already established geological data of Chhattisgarh Basin?
Yeah, in Shingora Proto Basin, there have been some drill hole data, borehole data nearby Chupali area and Shishpal Hill area. there they have encountered the granite basement is around 220 meters like that.
With the surface geological data?
That was compiled data, so we couldn't get any time to do the ground checking in the eastern part of the Chhattisgarh Basin. We confined our area within the limited time framework within the western portion of the Chhattisgarh Basin only.
Why my question is, see, you have established the existence of a pre-proterozoic east northeast west southwest trending a fracture zone,
East-west,
which is actually parallel to the CITZ. So if you see the Chhattisgarh Basin, there are two major regional scale crustal discontinuities trending northwest southeast direction. One is Mahanadi Rift in the east, and there is another Pranita Godavari Rift towards the west. So you have not encountered any northwest southeast trending pre-proterozoic crustal discontinuities through this study?
No, because we didn't cross that northwest southeast lineaments.
Because these lineaments provides the initiation of opening up the Chhattisgarh Basin, what workers have established through geological studies. That's why I am questioning.
But our compilation of all the data is west of the lineaments what you are mentioning.
Okay, thank you.
Thank you.
Considering this is a basically basement feature. In basement we are getting, it is nothing to do with Chhattisgarh. It is not at all. No. It is very limited. It is a width you see, and the Chhattisgarh area you see. How you can think of this is a very limited width, say 30 kilometer wide, 450 kilometer length. Lineament in the basement prior to Chhattisgarh. Age you don't know. It could be 3, it could 2.5, 2. We don't know. So, but it has been filled by the basic material, which is giving magnetic linears. And this is a very, very important feature, not at all reactivated, that you can observe it through the basins. It is hidden by the basin, capped by the basins. And wherever the basements are exposed, say Bijli rhyolite or Sambalpur granite, they are giving some indication in the form of ferruginization. So it is a very important feature which he is describing.
And this lineament is not reactivated and parallel to this lineament in northern direction. Several east-west magnetic lineaments are also reported, and those are characterized by the high magnetic anomalies. That indicates that they are activated or intrusion of basic material into that. But this is not reactivated, so it is megafossilized.
Cannot be correlated with your east-west Tansier or CITZ, etc. It is a basic material filled, sealed lineament. They are not like that. They are shear zones. They are having different connotations. It is a different thing genetically.
Oh, yeah. Take one more question. Yes.
The basic material, because it is a low susceptibility, what is said. Those fracture zones which is giving anomaly, they are producing magnetic low only. So they are low susceptibility body. Maybe fracture filling, something like this. It is not basic, sir. That's that we have no to say. Sir, basic, if it is basic and if it is a magnetic source, then it will produce bipolar magnetic anomaly, not low only, sir. It is maybe a quartz vein or fracture filling like this. Yes, sir. Yes, sir. Yes. Even when it is good. Yes, sir. It's a fracture film material. Yes, sir. It is low magnetic, sir.
Low magnetic, sir.
More questions, if there is any, we're gonna take. Okay, thank you. Thank you, Satish. No more questions. Thank you for your nice presentation, nice work. We'll go to the next presentation by Dolomite Jalandhar. His topic of presentation is application of IP resistivity and magnetic investigations in identification of fractures, fault zones. A case study from the Environs of Nagarda, Manikpur areas, Korba and Jangir, Chamba district, Chhattisgarh.
Thank you, sir.
Dolomite Jalandhar, you have 10 minutes.
Yes. Good afternoon to all. My name is Dolomite Jalandhar, Exploration Geophysics Group, Central Region, Nagpur. I'm going to discuss about application of IP resistivity in magnetic investigations in identification of fracture fault zones. I took a case study from Nagarda and Manikpur areas, Chhattisgarh Basin. Next. This is the geological map of the study area. My present study area mainly falls in the northern margins of Chhattisgarh Basin, and here is the detailed geological map, and this red block is the study block. If we see the geology in the study area, the northwestern portion is mainly basement granitites. In the southern portion, mainly it is sediments of Chandrapur and Raipur groups, and there is another basement which is exposed in the central portion. And apart from this, there are so many structurally disturbed zones which is reported by AMD. So we consider these fractured zones as a targets for the subsurface exploration, so that we conducted a geophysical surveys comprising magnetic and IP resistivity in this area based on these structural features. Next. And this is the survey layout map, and here we can see how closely we have took the readings, and line spacing is very small. It is the 100 meters, section width 15 meters, and somewhere over the fracture zones we took even 5 meters also when we are getting in graph deflections in the graph during the survey. So in initial of study, in the southern portion we took the traverses with a spacing of 200 meters to know how the geophysical signatures are prevailing. After that, we change the direction to north 50 degrees and we cover one entire area with the northeast southwest. Again here we took the north south due to undulated topography. This is the valley and this is the escarpment, so that here we took in a 2 phases. Next. And this is the TMI map, and after all processing techniques, analytical signal, RTP and vertical derivatives, we have demarcated structural features, and we superimposed those features in the TMI map. And if we see in the northwestern portion, there is a several northwest southeast trending bipolar natured features we can see. This is in basement. These are the basement fractures emplaced with the basic intrusions, and some basics are giving high susceptibilities and some basics are giving low susceptibility within this. And in northeast portion, here we can see high magnetic signatures, and here and signature these both are same litho units, but here the litho unit is faired in giving high magnetic, and here the same litho unit is giving high magnetic. So something is there in the formation below the earth, below these formations. Basically, it's a quartz arenite. And apart from this, in a basement where we have seen a central portion, there is one curvilinear magnetic intrusion in basement, which is limited exposure in over the surface, and subsurface is further continuing under the soil cover. And the major fault zone, which is 2 parallel fault zone which are trending in northwest southeast, eastern portion and western portion at the contact of basement and sediments. Next. Now we went to for southern portion for IP to carry out IP resistivity surveys. Here we can see 2 parallel northwest southeast low magnetic signatures. We planned to cover these magnetic linears with a one line with a long traverses, which is 2 lines are 2.5 kilometers and one is the 3.4. It's a long section. So we have done IP resistivity step by step. To get the deeper information with one electrode spacing is very difficult. Why? Because after 2 or 3 4 channel we don't get amplitudes. So for that we increased the electrode spacing. First we took the A is equal to 100 meters, we went for 1, 2, 3, 4, A is equal to 200 for 2, 3, 4, and A is equal to 300 meters. So by this we got around 400 meters depth of it's a deeper depth information from the IP resistor. In the same manner we have done for IP line 2 and IP 4. Yeah, we adapted a method is a dipole array. We used a high powered transmitter. Next. This is the inverted section of IP resistivity of line 1. Here we can see, and it's a clear cut block model for the low contrast material and high resistivity material and low resistivity material. The western portion is the low resistivity material, which is the sediments basically, and the center is the basement granite, and we can see a clear cut fault zones with a discontinuous in the resistivities, vertical fault zone in the western portion as well as in the eastern portion. But unfortunately, we didn't get any chargeability zones over this section, over these fault zones. Next. And this is, we also correlated our resistivity section with the high resistivity. We have seen alterations also in core samples, and where we marked the fault zones. Next. This is another line which is 200 meters southeast to first line, and this is also same in length. And the same scenario also appearing in these sections. But here basement is somewhat disturbed. We can see some fractures in the central portion also, and the same low resistive values are continuing in the western portion and eastern portion. Eastern portion, it is crossing around 300 meters. Still, it is continuing. And here also same situation, no chargeability is associated with this zone. Next. And for this borehole also, we superimposed geological sections over this borehole, projected borehole, and this is also well correlating with the geology data. Next. This is the other line. This is the further southeast to line 1 and line 2, which is 500 meters away from the line. We took around 3.4 kilometers to cross. We further move into sediments, whether this is another any fall zones are there in sediments. So, but we didn't get any further. The same situation is appearing here, but here the central portion is the sediments. Sediments are giving low resistivity and below the basements, and this is the quartz arenite. This is quartz arenite, and beside that there is a break in resistivity. It's a fall zone, and again this is the fall zone parallel to this one. And eastern, it is around. This is also fall zone in the eastern portion, and this is continuing above the 300 meters. And there is another fall zone in the sediments. No chargeabilities are associated with this one. Next, and this is the geological section superimposed in the resistivity, and this is also well agreeing with the resistivity sections. Next. And this is the 3D view for stacked sections of inverted resistivity depth sections. Here we can see how the eastern fault and western faults appearing clearly in 3 sections, and there is another fault which is parallelly running to the western fault zone, which is there is no evidences for this over the surface. Why? Because there is a soil cover, but in resistivity these fault zones also clearly appearing in the resistivity sections. Next. And these are the conclusions. And magnetic clearly denoted northwest southeast trending fractures in the basement, Sajapanic Ardhikara basin sectors, also in Manipur areas, basic intrusions. And the major fault zone, eastern and western fault zones are falling in 20 to 25 nanotesla range in the magnetic. And the low resistivity zones are falling in 50 to 150 meters ohm resistivity, which are very clearly giving a good contrast with the surrounding. And we have done a 2D inverted 2D inversion for the resistivity sections. From this, we can say the continuation of the sediment thickness is beyond the 400 meters, and a parallel fracture zone within the sediments also have been identified apart from the main one. And relatively, we have seen a relatively high resistivity in the lower horizon due to arenation component in the sediments, and intense silicification. This is around 5,000 ohm meters. We have done for resistivity core samples also for the borehole core samples by using SCIPM. So continuation of fault zone is beyond the 400 meters. We have seen in the first section also. And integrated interpretation of magnetic and individual polarization. Surface geological data is guided in planning the borehole to target the fracture zones in that area. And subsurface lithologies and fracture extension as well as agreement with the inferences drawn from the magnetic and hyperresistivity. Next. Thank you. This is done.
Your presentation before.
Yeah, thank you,
So we have time for few questions. Questions, I think we can. Okay, thank you.
Thanks.
Thank you. And now, okay, there is one more paper listed, but I was told by the organizer that it will not be presented here. So with this, we come to a conclusion of this 5th session. I thank all the presenters who stick to the time, 10 minutes. And I also thank audiences for the lively discussion. Thank you very much.
Thank you, sir, for conducting such a brainstorming session. Now, may I request Shri Arjun Panda, the convener of the seminar, to kindly felicitate Sri Sharavanan for chairing the beautiful session. Thank you, sir. Now may I call upon for the lunch time. After the lunch, we will be shortly resuming over here at 2 o'clock. May I request everybody to kindly join the lunch at the adjoining premises.
Mama.
this session would be about water and soil resources of Chhattisgarh Basin. And in this session, we have with us Dr. Praveen K. Naik, Director, CGWB Raipur. He would deliver a keynote address, and after the keynote address, he would also chair the session. So now I would request Sir Naik to come and deliver his lecture.
So good afternoon, everybody. Myself, Dr. Prabir Kumar Naik. I am Regional Director, Central Groundwater Board, Ministry of Jal Shakti. I joined in April 4th, 2022. So I will present regarding chemical quality. We have discussed so much about hard rock, the lineaments, fractures, anomalies. So we'll little bit shift our topic to groundwater or soft edge compared to the hard rock. Back. My topic is groundwater quality issues in Maniari cell of Chhattisgarh Basin and its mitigation. Regarding geology, we have discussed so much in detail. So regarding that, I will not discuss. Next. This is the Maniari cell, and this is the youngest formation of Chhattisgarh Basin. It was deposited during the basin closing phase, and many gypsum minerals are there. This is the purple cell and dolomite mainly. Next, this is my study area. During 2014-15, we took a project, and this is the geology expert. This is the Maniari cell, then the dolomite, then the Tarenga cell, then the Chandi limestone. Next. These are the exposure. I am showing some different figures. So many good figures are also shown, I think, but this is different. This is the Maniari cell exposed in the study area in a cross section. This is the solution cavities present in Tarenga cell. These are the solution cavities. And generally in cell or clay, our porosity is high, but transmissivity is low. So we get less discharge. From groundwater point of view, we are more concerned about the fractures, lineaments. You discussed fractures, lineaments from the point of view of mineralization. But if you will get the fluoride deposit, then the groundwater is contaminated. And all of us know that if it is more than 1.5 milligram per liter, it is good for nothing. And the local people are the loser. We just drilled a hole in Jharkhand district pond. And the one well, it was 1.5 milligram per liter. Another well, it is 1.64 milligram per liter. So geology or hydrological point of view, we got the fluoride, but actually the people, that is good for nothing. These are the solution cavities, and these are the gypsum mineralization, and with interaction with water, it is dissolved. Next. Then the aquifer can be divided into two zones. When I will tell about shallow aquifer, it is the dog wells, depth is less than 20 meter. And when I talk about the deeper aquifer, it is the bore wells. And the depth of bore well generally varies from 80 to 200 meter. Our depth of exploration is 200 meter. Next. And this was the depth to water level. This is phreatic aquifer, means dog well. And this is also dog well. This is in May, May 16, 2016. In May, we call it as pre-monsoon, and in November, we call it as post-monsoon. So in pre and post, we measure the water level, and when we will deduct November minus this pre-monsoon minus post-monsoon, we get the fluctuation of water level. Next. This is the water level fluctuation map. Next. Yeah, these were most of the areas, the water level fluctuation is less than 2 meter, but in some areas, this part, it ranges from 10 to 12 meter. Next. And this is the deeper aquifer. We call aquifer 2, that is the bore wells. And here, it varies from 11 to more than 35 meter, because in the Maniari cell, because of the solution cavities, it acts as limestone caverns, and some places we have got very good discharge. We measure it in liter per second, 12 liter per second. It is a very good discharge, and people are exploiting it for
agriculture purpose. They are in borewell water, they are cultivating rice and sugarcane in the month of November also. So there is high exploitation. Next. And there is a typical, I don't know about other parts of India, there people are filling these ponds from the borewell. Some back 20-25 years during Ajit Jogi's time, some practice started. That was a drought year, Indira Gandhi Ganga Gaon Yojana. So they are filling the borewell water in pond. And now also that is a practice, and I have done field work for 2 months, 2 years. And they are just arguing, you don't know anything, if you will not fill the pond, then how the domestic animals will eat, so many things they are telling. But this is the deeper aquifer water cell, and everybody knows the rate of recharge in cell is very low, so we are mining the groundwater. And once the wells go dry, then they will complain the government is not doing anything, state, then it will go as parliamentary question, ultimately it will be back to state government and organization like Central Groundwater Board. So this is also main awareness program that has to be made to the people. Next. Next. And in Maniari cell, here just actually this slide came earlier. RO plant installed in the study area in both borewells and dog wells. The EC goes up to 3000 microsiemens per centimeter. So if it is up to 1000 or 1500 EC, it is suitable for drinking water. After that, it is not suitable. So government has installed RO plant to reduce the EC. And this, when water comes for a certain period in the morning 2 hours and the evening 2 hours, and people collect this drinking water. Here also there is scarcity of drinking water in summer season. Generally our salinity hazard in coastal areas. But this we call it as hard rock salinity, like in Rajasthan, Gujarat. But here it is common in these areas also. Next. Then this chemical analysis of groundwater frequency plot of EC, that it goes up to 3000 to 3500, only one sample. But major it falls in 1000 to 1500. And in this 1500 to 2000, here RO plant has to be installed. Next. It shows the pie diagram. Here, this is the 1500 to 2000. And around 30% water sample falls in the category. Next. This is the chemical analysis of deeper aquifer. Next. And most of the here calcium sulfate type of water from gypsum, that is sulfate is leached out to the groundwater and gives calcium sulfate type of water. We are also getting some mixed sulfate, then the magnesium sulfate type of water. Majority is the mixed bicarbonate type of. Why in granitic terrain, when it is not contaminated, it is the calcium bicarbonate water that is in concurrence with the meteoric water. Next. Then chemical analysis of this is the Wilcox diagram. This shows low, medium, high, very high, and in which category it falls. Next. US salinity, most of us know it shows the quality of groundwater for irrigation purpose. So for irrigation, almost it is suitable, but for drinking, because of the high IC, it creates problem. Next. This shows the chemical analysis of groundwater, in which category it falls. I think mostly it is for research purpose and not the common. Those who are working in geochemistry or hydrochemistry, that is the calcium sulfate, magnesium sulfate, then the US salinity diagram, then the Wilcox diagram to study the genesis of water, from which rock the minerals are leached out. Next. And that was about my talk. Because my lecture was later converted to the keynote address, I am a little bit showing about the Chhattisgarh Basin. And here also we have the shallow aquifer and the deeper aquifer. This shows the plottings of the dogwell data. We collect water from in pre-monsoon time, we collect water from dog wells throughout Chhattisgarh, and CGW collects water from whole India, around 20,000. We call National Hydrograph Station, that is their NHS, National Hydrograph Stations are there, and we collect and we have plotted. This is, and this Hasinas are also there. Earlier, 10 years back, we are not analyzing uranium. Now we have started analyzing uranium, this is the uranium, where it is more than 0.03 milligram per liter above the permissible limit. So it falls in also in Maniari cell, and here these are the places where it is above permissible limit that I have plotted. Some places lead is there, then iron. Iron is very common in granitic terrain. That is a common occurrence, and that is 0.3 milligram per liter, but it won't create health hazards. But this uranium, fluoride, and lead, these create the health hazards. But nowadays, from drinking water point of view, most of the people don't drink the dog well water. I established around 80 wells, 8-10 wells are used for drinking, but majority of the wells are not used for drinking water. Most of the people are using either borewell water or your hand pump water, which is more than 60 meter. If it is borewell energized, then maybe also 200 meter. Next. This one is the deeper aquifer, this Maniari cell, and here we are getting this, where above the permissible limit we are getting the sulfate, then the fluoride, then the iron, and some places uranium. So presently we are well aware of what are the fluorosis problem, your dental fluorosis, then skeletal fluorosis, so many problems. Regarding arsenic also we know in Rajanandgaon area, but what is the health hazards of uranium, we have not able to say. Gradually we will know that with time what are the health hazards of uranium. Next. This formation wise I have described: electrical Maniari formation, Hiri formation, Taranga, Chandi limestone. What are the most places that EC is above the range? And in Chandrapur group, lead and iron at some places it is reported. Nitrate, that may not be geogenic, that is because of the domestic waste and your domestic animals, also urine and other things, nitrate comes, and also it comes from the fertilizer. But other things what I discussed, uranium, then fluoride, these are the geogenic. In the geological presentation, all are presented. Next. And this one is the shallow aquifer. Earlier that was the deeper aquifer. Here also lead and iron and fluoride here. Punderdahi and Charmuria we are getting fluoride. Next. The results are that I have told in phreatic water, both deeper and shallow aquifer, it varies from 220 to 3220. So it is a point source and varies from place to place. That it is not like that salinity total area is infested. Next. Then I was discussing with my friends from GSI also. I think if uranium or some fluoride is reported, we should report to the district and state administration so that they can do the mitigation measures. If we will only do the research and just prepare a report, the problem will not be solved. If any geogenic contamination is there, ultimately the people are the affected, and we should the data should reach the people. In Delhi also, before this Raipur, I was in Ministry of Jal Shakti, so many our ministers and other people used to ask what is the utility to the people. You are spending government money and preparing a report, what is the benefit of the people? So that should be our concern. So if EMD is also getting, they should report to some government organizations here uranium is reported, so people health will not be a problem. Next. So thank you. This is about my presentation. I think till today we do not have, I think, so we have collaboration with the GSI, Geological Survey of India, other, I think AMD, I want, sir also can say, Sinha sir also can, till today we do not have any AMD, because AMD that they are doing very specialized work and we think they are little bit closed.
No,
not,
but,
data is not shared with other organizations.
Your determination of uranium, besides that, you can also detect radon.
Radon. Radon actually detected in some Karnataka, I think, in granitic terrain. There was a seminar in Karnataka.
That is all right. But in your area, you can detect radon.
Radon.
Besides that, you can also detect helium.
Radon, helium. That analysis we have to do.
Helium
with it.
is required for atomic energy purposes, being a inert gas, light inert gas.
Yes.
So that is required for welding in power projects and all those research projects. So you can do that. In collaboration, you can report if you find something, you can report to it to AMD.
Yeah.
What should be fluoride content in water, drinking water?
That what? Oh, permissible limit. That is 1.5 milligram per liter. And fluoride very commonly we are getting from Precambrian up to recent. In alluvium also we are getting fluoride. So, and it is creating health hazards. How much? Maximum we have got that is a permissible limit is 0.3 up to 3 milligram per liter. That is in Bemetra district in one location. That is microgram. So if ppb. That I was saying if it is converted, I think permissible limit is 0.03 milligram per liter. If it is that is converted. No, 0.03 I think. And then we express all mainly in milligram per liter. And above that permissible limit I have plotted only. Otherwise it is clumsy 1000 data, 1200 data. We hope that there should not be any problem to the people, because uranium, once you hard uranium, that is, it creates a gated hazards. React to the board. And this is also good platform for that collaborative studies and get the different techniques.
Sir, one comment actually. As you have suggested that if the uranium is crossing the permissible limit, then what you have said is very right, that until and unless remedial measures are taken, probably reports are not very useful. But another important point is that if you make it public that uranium is beyond permissible limit, unfortunately, there are a lot of apprehensions about uranium in public perception. So there will be public panic. Now, if the uranium turns out to be a little more or whatever it is beyond the permissible limit, then until and unless there is an agency which has been identified to take the remedial measure, it will not be wise to announce it publicly, because if some agency announces it publicly, on the one hand you are creating public panic, and then some of the people with educated people with little knowledge on uranium will exaggerate the situation. And on the other hand, agency has not been identified which takes the remedial measure, like installation of even RO, then somebody has to take it as a mandate.
Actually, you are right, sir. Actually, media wants news. Always they want to highlight, so that's the problem. And you are talking about agency, only state government is doing that RO plant, not central government agency doing the remedial measures. Your state government, then district collector, ultimately your PhD. In Orissa, one department is there, RWSS, Rural Water Supply and Sanitation. So they are doing the remedial works. We are for R&D, but for people's, they have district level and block level office also. Thank you, everybody.
Thank you very much, sir, for giving a analytical view on groundwater perspective. So with this keynote session, keynote address, we'll start our session. In this session, we have a total of 4 lectures lined up. I would request Sri Pravir Kumar Nayak to chair the session along with Mr. Jatishkar Hajarika to be the reporter. Sir, so the mic is yours. Thank you, sir.
So in this session, we have 4 papers. First one is by my colleagues, Ashok Kumar Biswal. That topic is groundwater perspective and analytical view with reference to Chhattisgarh Basin. So I'll request Sri Biswal to stick to the time as time is important.
Good afternoon. So now I will discuss about the groundwater perspective and analytical view with reference to Chhattisgarh Basin. The main author is Priyanka V. Sonborse and co-authored by me and Prachi Gupta, all from Central Groundwater North Central Chhattisgarh region, Raipur. So this is a typical Chhattisgarh Basin map, which starts from Singara Proto-Basin group of formation, followed by the Hiri Subbasin, and Singara group is and Bardar Basin is on the Bardar Basin. The typical feature of this basin is that each formation starts from limestone at the bottom and followed by shell at the top. Since we are discussing yesterday about the geological features, and the anchor formation is Maneri shell. Next. And these Purana rocks that depend the large spread of Mesodo Neo-Proterozoic under which the Chhattisgarh supergroup comes under. And this is very little tectonic deformation has taken place within this formation, which results in the very poor formation of secondary porosity, for which the groundwater perspective seems to be very low. Next. And this Chhattisgarh supergroup, this is a crescent Chhattisgarh Basin or the Central Indian Cotton into a small Baldwat Sub Basin in the east and Man-Hiri Basin in the west. Next. The stratigraphy of this Chhattisgarh Basin, which I discussed since yesterday. Next. The Hiri Basin, the group is Chandrapur group, the oldest formation. Next. Followed by Raipur group of Charmuria formation, Gondedi formation. Next. Then Chandi formation. Chandi formation is the area-wise the largest formation, which covers more than 7,000 square kilometer. Next. And these are all about the geology. Next. Next. The typical fence diagram of different formation in Chhattisgarh Basin. Next. Now come to aquifer characteristics. CGWA drilled more than 500 bore wells in Chhattisgarh Basin. On the basis of which we have deciphered the aquifer characteristics formation wise. Here formation Saradi. This is of limestone aquifer, that Hiri limestone, Saradi limestone, Chandi limestone, Pandaria, and Charmian limestone. On number of wells drilled, maximum depth, casing, zone, and discharge less than 1, 1 to 3, and 3 to 5, and 5 to 10, more than 10 LPS, and then transmissivity. Next. These are the result of exploratory wells in shell aquifer. This is Manyari shell, Tarenga shell, Gondedi shell, Eraigar shell, and Bamandi shell. Next. So on the basis of this analysis, we can say that the heat formation, the discharge range is 3 to 13 LPS, and groundwater restricted within the secondary porosity. And transmissivity is 51 to 100 meters per day, very low transmissivity. Then Saradi, similarly, Saradi formation yield varies from 5 to 16 LPS. However, the Potta, exceptionally, it gives a high discharge of 20 LPS. And in Chandi formation, the Chandi is a good formation because of the development of cavernous feature, and development of cavernous feature down to 90 to 120 meter depth. Within this depth, the cavernous features are found. So these wells drilled in Chandi formation gives a little bit better discharge, up to maximum up to 15 LPS. So transmissibility similarly is, varies from 1 to 440 meters square per day. And wells drilled in Jangir Champa district have yielded more than water in compared to the Chandi formation in other areas. SPD wells drilled in Rajiv Gandhi National Groundwater Training Research Institute. At that time, it was at Vidhan Sabha, earlier Vidhan Sabha, Raipur, Chhattisgarh government. That yielded 16 LPS water from a very shallow cavern within 35 meter below ground level. That is, the depth of well is 25 meter, and yield is 16 LPS. Next. Pondaria formation, similarly, Pondaria formation is also a good formation from groundwater point of view, giving yield 7 to 14 LPS, and transmit is up to 145 meters square per day. But due to the collapsible nature of and high groundwater potential of the formation, drilling of deep well is very difficult. It is very collapsible formation. Is the Pondaria formation. Similarly, Charmuria formation. Is also a very medium type of formation from groundwater point of view, 5 to 10 LPS discharge, and transmissibility also 2 to 440 meter square per day. And explorative well drilled at Paragaon in Raipur district, drilled up to 130 meter below ground level, has yielded 14 LPS. A high yield well have been found at that Paragaon in Raipur district, that yielded 40 LPS water from drawdown of 14 meter. Next. Manari formation is the best formation from groundwater point of view. Yield is 7 to 17 LPS, and the maximum discharge within 200 meter well. All the wells are drilled within 200 meter depth, and transmissibility 100 to 600 meter square per day. And studies carried out by CGWB reveal that because of gypsum vents does not occur at any particular depth of direction, high sulfate areas cannot be predicted. However, a detailed study is required to carry out the delineate the high sulfate areas in Manari formation. Similarly, Toranga formation, the yield is 2 to 40 LPS. 40 LPS is exceptional high yield. Explorative wells drilled at Bisrampur and Rohar and Simangapalo, Raipur district down to 120 and 76 meter depth. That yielded 40 and 24 LPS water, and transmissibility in Taranga formation ranges from 10 meter square per day to 20 meters square per day. Then Gundari formation cell, Gundari cell is very poor from groundwater point of view. However, exceptionally, some wells have yielded yield up to 5 LPS. Due to impervious nature of formation, recharge of rainwater in this terrain is negligible, and most of the rainwater drains away in the form of surface runoff. Next. Similarly, Raigad cell is also discharge is very low. However, exceptionally, some wells give a very good discharge up to 22 LPS, and Mamandi formation not well developed from groundwater point of view. Next. So overall, we can say that limestone shale and sandstone aquifers represented by Charmuria, Chandi, and Hiri limestone grouped under on consolidated sedimentary aquifer found the best aquifer in Chhattisgarh state as well as in Chhattisgarh Basin. And however, some unconsolidated porous aquifers represented by alluvium and laterite are present. These are represented by alluvium laterites, and yield up to alluvium. We get the yield up to 19 LPS, that is 1600 meter cube per day, and laterites have yielded up to 3 LPS, that's to 60 meter cube per day. Next. Now come to groundwater regime of Chhattisgarh Basin. This is the pre-monsoon and post-monsoon map of phreatic aquifer, that is within the weather zone aquifer, and pre-monsoon is not so much important for us, but the post-monsoon water level map is important for us. We will find that 5 to 10 meter depth, 5 to 10 meter zones are found mostly in Pandaria and in Moniari cell area. Next. This is of Dipor Equivar. This is the water level map of Dipor Equivar for pre-monsoon and post-monsoon map. In post-monsoon, we will find that more than 10 BGL, below ground level, water level are found in most of the area, especially in northern parts, that is Moniari cell, and also in Chandi limestone area and Chandrapur sandstone area. Next. So in general, the depth of water level ranges up to 10 MBGL in approximately 84.8% of the observation wells in the state in basin, and deepest water level ranging in 10 to 20 meter below ground water level only in 15% of the area observation wells. Similarly, post-monsoon, so far as post-monsoon water level is concerned, that ranges up to 10 meter below ground level in approximately 98% of the observation wells. And so far as water level fluctuation is concerned, that is the difference between post-monsoon and pre-monsoon water level. The water level in November 2020 compared with May of 2020, about 100% of the monitor wells, they exhibit rise in water level, and 10% of the monitor wells exhibit rise in within the range of 0 to 2 meter fluctuation, and 64% of the wells give a rise up to 2 to 6, and remaining 30% of the observation wells show a rise of more than 6 meter. Right? So generally it's shown as a pie diagram figure. So mostly 85% wells in pre-monsoon area, they are within 10 meter, and 15% more than 10 meter. Similarly, in post-monsoon, 99% of the wells show the water level within 10 meter, and 15% more than 10 meter. That 15% area is area of concern for us. So during summer season and paddy season, due to high rate of extraction, the groundwater level goes down. However, in monsoon season, the water level comes up. Next. So far as quality is concerned, a tabular list in three forms for phreatic aquifer, for shallow aquifer, and for deeper aquifer. Next. So from this table, we will find that the principal aquifers are in Chhattisgarh Sub Basin are sandstone, shale, and limestone. So major cations calcium, magnesium, sodium, potassium, and major ions bicarbonate, chloride, and sulfate. Next. So the order of principal cations is bicarbonate more than sulfate and more than chloride, or sometimes bicarbonate is more than chloride and more than sulfate. However, bicarbonate is the major cation, and average EC is 600, around 600. However, in some areas it goes beyond 2000 micrograms per cement. Next. So these are the villages where high sulfate are found. Next. So these are the EC map for phreatic aquifer and for deeper aquifers. The pink lines are within 1100. However, the orange lines, that total lines, that is 1600 or more EC micrograms per second. So those areas, the groundwater is little bit polluted. Next. Yes, sir. These are the fluoride, high fluoride content areas. Next. Next. These are some pie diagrams are an attempt has been made for chemical analysis for same formation for same rock type for different formation. That is this pie diagram for Moniari cell, and for Gundeti cell, for Taranga cell. Next. 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 So however, it is found that the groundwater in Chhattisgarh mostly bicarbonate type, and major quality is high sulfate, high fluoride, high iron, and high concentration of nitrate. Next. Next. So now CGWB has made assessed the groundwater estimation reserve in 2017, on the basis of which total in Chhattisgarh we have 34 test blocks, out of which 27 are semi-critical and 9 are critical. And out of these 36 blocks, water state blocks in Chhattisgarh, 8 blocks and 19, that is 27 blocks fall in Chhattisgarh Sub Basin. That is 9 are critical, that is yellow marks, and 80 are critical and 19 are semi-critical, that is blue. Next. So the increase in groundwater utilization in the last decade for agricultural activity through adoption of borewells has increased the groundwater depth more than 7.7. This is the main reason behind the water state blocks. Next. These are the resource part of the Chhattisgarh Basin, that is the blockwise. Next. Next. 90% blocks, the groundwater resource, the stage of groundwater extraction is more than 50%. So next. So this is August in the water level map of August. Now, if compare the water level map of August with the groundwater that is categorization map, this is phreatic where the mostly area are within 6 meter. So there is no problem because phreatic zone water is groundwater from phreatic zone is not generally extracted as compared to deeper aquifer. Next. So if we in August, that is rainy season. So the generally water level suddenly goes up, but in the areas, especially in the northern parts, that is the Manari cells, you will find even in August also the water level are within are below 6 meter, below 6 meter. So if compare it with the ground catastrophe unit of Chhattisgarh Basin, then we will find that maximum blocks within that area they come under critical semi-critical zone. So those areas should be given attention immediately by constructing artificial recharge structures. Next. So these are the common issues within this basin. In groundwater, intensive groundwater development, growing urban complexes, the industrial establishment and areas of intensive mining activity also, quality issue. Next. These are the recommendations to be addressed for these issues, that is promotion and adoption of rainwater harvesting, artificial recharge, and also the spacing criteria between borewells, particularly in Chandi formation and Manari cell, covering deeper water levels should be regulated because we don't follow any spacing criteria between those wells. So there is limited groundwater exploitation, unlimited downflow of the water level. And should be regulated to keep control on the depletion of groundwater level by constructing more number of purpose-built piezometers. And also the groundwater potential of Gundeti cell and Charmuria formation, that the Charmuria limestone are presently actually underutilized. So the potential aquifer existing between 150 to 200 meter depth has not been tapped so far. So especially designed wells can produce sustainable discharge for irrigation within these two formations, and conjunctive use of water resources like creation of more ponds may be given importance. Next. So participation of community, provision of mandatory installation of rainwater harvesting structure, restoration of village ponds, tanks, etc., using abandoned dog wells for artificial recharge, and the most important is the formation of a strong database in collaboration with the state government in a single platform is necessary for the monitoring of water levels, and accordingly we can formulate the to restrict the water level extraction and improve the condition of the that is semi-critical and critical block to safe block. Thank you. Next.
It was a very elaborate presentation. I think we can take one or two questions if it is there.
Then, number one question: do you sample all well around? Number one question. Second, do you sample at least periodically, say within 10 days or 1 week, something like that?
No, actually.
And number three questions: do you sample pre-monsoon and post-monsoon?
No.
If yes, then answer.
No. We only collect samples in the month of April, the May, that is pre-monsoon, because in post-monsoon then it get diluted, and yearly only once we get sample and it get analyzed every year. Yes, sir. Always, Samo?
Around that point, if you are getting X location, say nearby you.
No, we have some permanent natural NHS test station.
That's what I said. If yes, then answer. You are all answers are no. Only once you sample. That was the answer. I don't expect much more. So that data is not correct.
Correct.
I am interpreting in this way. So whenever you are reporting, as Chandra Saab was saying, you should report data which is factual data. Otherwise, it is going to create panic. If it is heavy metal, let it be uranium, let it be chromium, let it be nickel.
No, if we get some heavy metals contamination, then what we do, we will divide that area grid-wise, and then we will collect, and a special study is taken, and then finally we discuss about the area. Actually, what is the
grid then? That was the question number one. That was the question number one. Now you answer.
No,
what is the grid?
Yes.
Thank you, Mr. Biswal. Our next speaker is Deepak Bez, Pandit Ravi Shankar Shukla University. Assessment of role of lithology and topography on distributions of soil nutrient in Maniari Basin using geospatial approach. So please try to stick to the time.
Good afternoon to all. Myself Deepak Bez, PhD research scholar, Geography Department, Raipur, Ravi Shankar Shukla University. My topic is assessment the role of lithology and topography on the distribution of soil properties as well as the nutrition and of Maniari Basin with a geospatial approach. Nowadays, soil quality is very important due to excessive use of fertilizer. So, next slide. Areas of tectonic activities are characterized by complex landscapes consisting of soils and with heterogeneous physiochemical properties. The spatial variability of nutrients with closely related to the topography as well as the lithology. Next. Study area. The study area falling under the district of Kabir-Dham, Mungeli and Bilaspur, Chhattisgarh state, and it is the part of Chhattisgarh Basin as well as the Mahanadi basins. Next. And the study area cover 3700 square kilometers. Jenny 1941 elaborate formulas S equals to F ClORPT. Here P equals to the parent materials as well as the T equals to topography. So topography and parent materials is very important role to forming the soils. Next. Data and methodology, where the data lithology map has been collected from Geological Survey of India and Cartodam and satellite image also collected from USGS and Bhuvan geoportal. And satellite image Sentinel-2 10 meter resolution has been collected, and the Cartodam 30 meter resolution has been collected. Next. And this is the methodology where the basin delineation with the help of ArcGIS platform. Next. This is the Maniari Basin which delineated with the help of digital elevation model as well as the satellite image. Next. Relationship between the parent material and soil are not well understood and generally only reported in qualitative form. So the relationship of the lithology classes has been recorded 13 classes, but we have account 4 classes due to not elaborate broadly. Next. This is the lithology map where 13 classes has been reported, and the 4 class which we account, that one first unclassified cell limestone, second is granite gneiss and basal flow, that is the northern part of the study area, and unclassified metamorphosis in the hilly area of the study area. Next. This is the topography where 4 classes were categorized: hilly area, lower plateau plain, and upper plateau. Next. This is the soil sample. 50 soil sample has been collected with the basis of lithology as well as the topography. And now the lithological group which influence the weathering. First, the granite, which was coarse and crystalline rock. So that's why there is fairly slow in weathering and influence, and very slow in niches also. And the basalt, there is rapidly chemical and physical process. And now the metamorphosis, this is very hard rocks. So that's why the weathering response is very slow, and shells and limestone, and that is very high physical and chemical weathering has been reported. Next. Soil sample and analysis in lab and ground field photograph sums, where pH and EC, electric conductivity, organic carbon, nitrogen, phosphorus, potassium, and iron, sulfur, manganese, carbon has been analyzed. Next. This is the soil sample data which has been analyzed according to the lithological groups. Next. This is also the data. Next. This is very huge data. So the data has been categorized with the range unclassified shale limestone, which shows in topography plain area 32 to 75 depth, and the average depth is 51 centimeter. And here we can see the nitrogen deficiency in granite and gneiss, as well as the unclassified metamorphosis, and deficiency in copper in basalt, also the deficiency in potassium in basalt 180.6, the average data kilogram per hectares, and also some high enriches potassium in unclassified shale limestone, as well as the granite gneiss and unclassified metamorphosis 334.3, and the optimum soil nutrient which has been necessary for plant growth, that is the Baldwat table has been seen. Next. The depth unclassified shale limestone, which is in plain area, the depth of the soil is very high due to plain area, and the basalt, in the basalt the depth of the soil is very low, and electric conductivity the high in granite and niches, as well as the pH in high in unclassified shale limestone, as well as the basalt, and organic carbon in high in unclassified shale limestone, which is found in a plain area, and the nutrient as well as very high in potassium in the unclassified metamorphosis, and low in basalt. Next. And the soil texture, which has been reported that clay loam soil has been found in unclassified shale over unclassified shale limestone, and the sandy clay loam and sandy clay loam has been found in the soil over the basalt, as well as the granite and gneiss, and unclassified metamorphosis where the sandy loam soil has been reported. Next. This is the interpolation map of soil nutrition, where it has been seen that the nitrogen status is very high, very low, and as well as the potassium status is very high. Next. So the unclassified shale limestone is one of the least under soil due to their complexities. To categorize them, and this soil is known as Bhati soil, and local name is Kanhar, and shale limestone, granite and gneiss, this is the local name is Dorsa or Alfisal, the pH of the soil is very low, and this is the soil is poor in nitrogen, magnesium, organic carbon, and rich in potassium. The soil made over the unclassified metamorphosis. And this is also known as dorsa in local language, and this is they are poor in nitrogen as well as rich in potassium. The soil made over the basalt is shallow block soil. This soil, known as matasi in locally, contain much higher nutrition, and they are poor in potassium. Next, this is the nutritional index, and in all about the study area, we can found the nitrogen in very low nutrition status, and as well as the manganese and copper and phosphorus is very high in amount. So to balance, it should be recommended that the nitrogen fertilizer used 125% of the normal dose and 75% of the normal dose in copper, manganese, and phosphorus. Otherwise, the crop selection has been crop suitable selection has been according to the nutritional distribution, nutrient distribution. Next, the result indicate the nitrogen phosphorus deficiency predominantly occur in the shallow soil developed in the granite and gneiss, and high potassium in found in the sedimentary rocks over the Monieri Basin. So in this area, we finally it has been found that the nitrogen nutrients is very low, and the potassium and copper as well as the manganese is very high. And it should be recommended that the organic fertilizer as well as the fertilizer which has been implemented in this way to balance the soil. Thank you.
10 minutes. We can now discuss few questions we can take. Ask you one thing, how this study is good, how it will be useful for agriculture purpose and to the farmers?
Sir, we should know the soil over the lithology, so we should pre-measure the nutrients on the soil. So we should inform the farmers as well as the advertise, and it should be recommended.
That is the objective of your study. So your findings, how it will be useful to the farmers?
Sir, we should inform कि फार्मर्स को ये बताया जा सकता है कि इसमें इस तरह से खाद यूज किया जाए कि पोटासियम और नाइट्रोजन जो कमी है उसमें ये बढ़ाया जाए.
It's okay. Anybody else?
Yes, sir.
Degree in science or humanities?
No, humanities.
MA का.
MA.
नहीं है, नीचे से तो नहीं, ऊपर से तो नहीं है.
नहीं, क्रॉप से तो नहीं.
भाई आप ऐसी क्रॉप लगाएं जो ज्यादा नाइट्रोजन खींचती हो तो डेफिशिएंसी हो जाएगी, वो भी देखना पड़ेगा. आपने नीचे से कह दिया, हम कह रहे ऊपर से देखिएगा.
ओके सर. थैंक यू सर.
Thank you.
दलान लगाएंगे तो ज्यादा लगेगा ना नाइट्रोजन.
So our next author Baburam Mandal, he will not be presenting the paper. The next presenter is R.K. Trivedi, Dr. Hari Singh Gaur, Vishwavidyalaya Sagar.
Good afternoon. Myself, R.K. Trivedi. I am presenting the work of one of my students. Basically, he was working on the mineralization around Deori, Pakni area of Surajpur district. When he was discussing the problem with his friend, he finds that his friend in the chemistry department has some equipment which can measure the uranium very easily, particularly in the groundwater sample. So he sampled the area and he finds some results which was shocking, because in some of the samples he got very high concentration of uranium. though the general tolerable limit of uranium, that is 30 ppb, but he got some extraordinary values. So we are presenting this work just for the information that in the area where there is mineralization of uranium, particularly in Sarguja area, the AMD is working and they got number of deposits in that area. So that is the introductory remark about the area. The Devri Pakni area is a part of Sarguja shear zone. Almost the study area of that student is something around 35 minutes by 1 degree, covering in Survey of India topo sheet number 64 M by 2. In that area, uranium occurrence is reported by number of workers, particularly from AMD. They have established some of the deposits west to this study area. They also showed that there is structural and lithological control, particularly on the mineralization. The samples from Devri Pakni area showing radioactivity, which is counted by scintillometer, number is so and so. The radioactivity in the sample showing 4 to 8 times higher from the normal background values. That is not with the water sample, it is from the rock samples. During his study, he collected some 45 samples of water and analyzed those samples. Next, this is the location. Next, as far as the geology is concerned, the area having the rocks from Precambrian to Phanerozoic, and particularly the Gondwanas and Deccan Trap forming inlier covering the Precambrian rocks. The area has large number of metamorphic, igneous as well as sedimentary rocks, includes pink gneisses, gray gneisses, including some pegmatite veins, quartzite, micaschist, migmatites, Gondwana sandstone and Deccan basalt. The rocks of shear zone has been subjected to multi-phase deformation, that is 3-phase deformation as reported by the workers in that area. These rocks are highly metamorphosed also, and probably this shearing and metamorphism, they are providing the secondary porosity and permeability for the movement of water and provides more interaction with the mineral and water. Next. This is the stratigraphic succession. Next. Probably the uranium mineralization, I don't want to say much more because all you have worked in that area, you have seen that area probably inch by inch, I can say. Next. This is the geological map. Okay, next. Sample collection and analysis. 45 water samples were collected from different locations of the study area during the summer. That is the pre-monsoon water sample. Okay, and we are not able to collect the post-monsoon. Probably this time we will do that also, and we'll see what is the difference between the pre and post-monsoon concentration. Samples were collected in clean plastic bottles with the acidifying those samples with 0.2 ml of nitric acid to minimize the loss. The current study, we use the lead-based uranium analyzer, LED fluorimeter, LF2. With this, the data we get, next, these are the sample locations with the geological map. The yellow points are indicating the sample location. Next, these are the analysis where we got the concentration of uranium as ppb level within the samples. Next, these are the two samples where the concentration is much more above the permissible limit. Next, we have plotted this on the map, and these are those areas where we are getting higher concentration, particularly in the northeastern part of the study area. Next. So, our main concern is that this sort of information we can share on the platform where we are discussing most of the mineralization, particularly the uranium mineralization in that part of the area. And our suggestion that the exploring agency could also see whether if the mineralization is there, whether it is contaminating the groundwater. If so, then it will restrict either by sealing those wells or with the help of state government, they can seal those wells, particularly bore wells, where they are getting the abnormal concentration of uranium. Thank you.
Thank you. You have finished before time. Now we can have sufficient time for discussion if you want, anybody wants to ask.
Okay, thank you.
Regarding uranium, lot of discussion has already made. So, including myself, 4 papers were presented in this session. Within stipulated time, we finished this session. So, because there was no one presenter is not presented, so we'll be having sufficient time for panel discussion.
Thank you, sir. On behalf of the seminar committee, I would like to extend my thanks, sincere thanks to you for chairing the session so well. Now, I would request Sri Arjun Panda, convener and director, regional director, AMD Central Region Nagpur, to felicitate Dr. Nayak with a certificate for chairing the session. Thank you, sir.
Okay.
Thank you, sir. Now, since we have finished this session before our stipulated time of tea, so we will not take the break right now. We will take the break only after the keynote address by Dr. T.S. Sunil Kumar, Additional Director, Research and Development, Atomic Minerals Directorate. So, sir will chair the next session as well. But before that, I request sir to kindly present his lecture, and then we'll head for a tea. Thank you.
Thank you, Pradhan. Good evening, one and all. We are coming to the last session, just before the panel discussion, respected seniors, my colleagues, and participants in the seminar. And this today, the last 2 days, we have been listening about the various geological activities in the Chhattisgarh Basin, and also the mineral exploration aspects. And this session essentially will be on the analytical techniques and the advancements in the analytical techniques which will be utilized for the mineral exploration per se, and specifically for strategic and critical minerals. To start with, actually we all know that minerals industry, the beginning of the seminar, Honorable Minister also was mentioning, minerals industry has got 4 major components. One is exploration to locate the mineral deposits. Then obviously the mining comes, then the mineral processing, so that your material of interest can be extracted profitably. And last but not the least, the most important aspect is sustaining the mining activity with giving equal importance to the environmental aspects. The thread behind all these 4 major aspects is mineralogy, compositional characterization through mineral chemistry, and the chemical analysis, the analysis of the elements which constitute the ore and the rock. The constituent elements analysis could be through the mineralogy, which Hansoti Sab today morning was mentioning, and also could be through chemical analysis or elemental analysis. Next slide, please. See, this to start with, I will be because I represent AMD, and I will be concentrating on the mineral exploration. We all know that different stages of exploration, there are different names people will be talking about, and the scale of exploration and the details collected, especially to start with the field areas, is mentioned here. First step definitely be it exploratory, reconnoitry survey, or be it geophysical, geological, or geochemical. It will be essentially to locate the anomaly. Next, click. Here, the mineralogy and composition characterization essentially will be to identify the rock and the mineralogy of the ore, the constituent minerals which will make the rock, and the minerals which will be carrying the metals. And associated analysis will be the metal of your interest and the pathfinder elements. And let it be hydrogeochemical sample or soil sample, the pathfinder elements and the indicator minerals, possibly for the kimberlites, where people are looking for the indicator minerals. There, more than the elemental analysis, they'll be going for the indicator minerals. Their analysis comes into the picture. Next comes the ore body configuration, or in the evaluation stage. Here, the multi-metallic analysis becomes all the more important, because present day the concept about optimal utilization of the mined product looks for utilization of co and byproducts. So the multi-metallic analysis of the ore attains significance, particularly at depth and laterally as well as in depth. And the characterization, detailed the characterization of ore through the ore petrography becomes important. Evaluation stage, which is the ore body evaluation, and the exploration mining, followed by the process mineralogical development. Next click. Here also the multi-metallic analysis and mineralogy of the ore rock, the quantitative mineralogy, and also the process samples has to be studied. And next click. Here you will know that all these kinds of studies will come into the picture. Next slide, please. So broadly, next one. Here, what happens is we can see that there are 3 major components coming into the picture. One is the characterization of the rock or the host rock or the ore per se, then the mineralogical characterization, and followed by the geochemical characterization. There I have put isotopic characterization also into the picture. Coming to the host rock characterization, petrography, that is the link between the analyst and the geologist. Actually, the geologist turns into petrologist. That becomes the beginning part of the studies, because unless you understand the rock through the petrography, through the ore fabric and textures, further studies will not yield the desired results. And when it comes to the mineral characterization, also it is a continuation of the petrography. Here the importance is given for the ore petrography, that is the reflected light microscopy, where, and along with the another aspect which comes into the picture is the quantitative mineralogy. Quantitative mineralogy, there are conventional techniques which has got its own limitation, but it has got its own benefits also. and the liberation analysis, the size at which the ore can be, I mean, the combination will give you the optimum liberation of the mineral so that it can be recovered or extracted economically. And X-ray diffraction studies will support it. Those details we will see. And the compositional characterization, last 3 decades, electron probe analysis is the main workhorse for the compositional characterization of the individual minerals, which will be followed later on. And morphological studies by the SCM, that also comes into the picture, which we will be discussing in detail. And geochemical characterization, there are, it could be that whole rock analysis, trace elements and rare earths, and isotopic analysis through the mass spectrometry, both radiogenic and stable isotopes, not only for the age determination, but also as a geochemical tool can be utilized. Here in the case of particularly critical minerals, specifically for uranium, the metallogenic epochs become important to identify as an exploration tool, because unless you know about the age at which the formation forms or the mineralizing event has happened, it can be used as a geochemical guide or a geochronological guide to select the select the exploration area. So these geochronological studies also become important. Next. So to start with petrography, as I said, I represent AMD. Most of the techniques we have got, I will be going in the form that conventionally what has been practiced and which has been advanced, and what is the further advancements we are planning. So I will be, in the course of the presentation, I will be talking about what are the facilities AMD is having. We have got 7 regional centers and 2 sectional offices along with the headquarters. We have got all the places has got fully equipped with the state-of-the-art research, polarizing research microscopes, which has got the capabilities to carry out both transmitted light and reflected microscopy. And when I said this becomes a stepping stone for the further studies, because textural and studies and the ore fabric will decide the paragenetic sequence and what is the next course of action for selecting the further analysis, whether it is required or proceed ahead. And this ore petrographic studies, one of the most important aspect required is quantitative properties to be measured in the case of ore, that is reflectivity and microindentation hardness. These are the 2 properties which has to be measured. And when it comes to the indicator minerals or the exploration for placer deposits, there the naturally liberated material has to be studied. There the role of a stereo microscope comes into the picture. This facility also we have got. And further advancement of this study is the microthermometric studies through the fluid inclusion to identify the fluid inclusion and characterize them so that you know the fluid rock interaction, and also will know about the type of mineralizing fluids which has been involved with the program. This thing. And to start with, when we all started with as a mineralogist, we started in the period of film-based microphotography, and then photomicrographs. And now what has happened is, it is a digital era. It has given an advantage. You can take n number of photos, and obviously it has opened an area where you can go for image analysis also. That there are certain advantages of going for image analysis, particularly for metallographers. But optical mineralogy, it is a mixed properties or interference of properties are there. So throughout we may not be able to utilize the image analysis for this purpose. And as I said, the quantitative mineralogy and liberation analysis also becomes part of the petrographic study. This petrographic study, there is a constraint, because going for the magnification, you might get a hollow magnification, but higher the magnification at a particular resolution, you may not get the desired optical magnification to identify the fine-grained minerals or to study the metamic minerals or clay minerals. That is where the XRD comes into the picture. Next slide, please. And before that, I will tell you how the ore fabric, just to give an example, I have kept the graphic intergroup between arsenopyrite, pyrite, galena, and tetrahedrite, and coming here a cassiterite with the 2 modes of occurrence. One within as of smaller gains within the chalcopyrite, and which is of course it has got 2 different bimodal distribution, which makes a liberation in a different category, and also this particular association, because an oxide mineral being associated with a sulfide, so that physical properties get changed, and so the process mineralogy, the beneficiation technique may be something different for this assemblage. And this is an atoll structure where chalcopyrite is engulfed by chalcocite and covellite. This surface property of covering the chalcopyrite by chalcocite and covellite, completely the flotation behavior gets changed. And coming to uraninate, we are getting two types of uraninate here. Here there is a subrounded detrital uraninate with a immediately precipitated uraninate here, and here a bigger grain with a corroded margin. Corroded margin where the uraninate has migrated. This is texturally being observed. It is observation. But when I say this is two generation, I have to characterize based on the compositional nature or by further analysis. That is where the constraint comes as far as the microscopy is concerned. Another aspect is there was a long crystal of 2 laths of ilmenite. The brown color is there. This is uraninate. The proximity of uraninate with ilmenite has made this area completely to get converted into uranium-titanium complex. The uranium migrated here, the titanium complex has formed, and texturally and through the one supplementary technique called autoradiographic technique using cellulose nitrate, we know that this area has got uranium. But to further compositionally characterize, we need better resolution, in situ type of analysis. That is most important in this case of a zircon, which is shown here, which has got a rounded core, which definitely indicate a sedimentary or sedimentary origin with a growth zones, and with the euhydrality on the outside, you are getting completely zoned grain. Today morning Hansodi sir mentioned, and yesterday Professor Partho also has been using. So this texture definitely shows you are able to see, but pinpointing the age and pinpointing the geological events, getting the records, you require further in situ analysis. These are the places where we go for other advancement of analytical techniques. Next. This is what I said, when it comes to the metamic minerals or clay minerals or fine-grained minerals, particularly the rare earths, where the intergrowth of fine-grained needles are there, we go for the X-ray diffraction studies. This X-ray diffraction studies is used for all these minerals, not only for that, it is used for the order disorder studies and feldspars, triclinicity. Unit cell parameters play a greater role in this kind of studies, and crystal structure studies. To represent it, I have given a columbite tantalite XRD pattern. That analytical results we are not presenting. I am only presenting the capabilities of AMD as far as the work is concerned. Next slide, please. And coming to the whole rock analysis, because further advancement I will be coming. Because we are analyzing a whole lot of analysis in a rock sample is being done. More than around 65 to 70 elements are getting analyzed. One click, please. The uranium, thorium being from AMD, before us it is the fuel elements, which is routinely analyzed. Next one. And other prescribed substances like zirconium, hafnium, niobium, tantalum, lithium, beryllium, and so on and so forth. And next one. And elements of other atomic minerals, because Jain Saab is here, he knows about the atomic minerals, this thing. We have to look for certain minerals like titanium, yttrium, all the rare earth elements, which is closely associated with all the atomic minerals. Because the minerals are there, these things comes into the picture. Next. And the byproducts and co-products. No metallurgy goes as a single entity. It will have associated metallurgy which has to be seen. Along with that, so many pathfinder elements also come into the picture. All these elements are being analyzed by the different analytical techniques in chemistry laboratory, and as a tool, some physical parameters are used for analysis. Next. See, when it comes to the geochemical analysis, normally earlier, to start with the AMD's history, we started with the whole rock analysis by the conventional chemistry. But I started with here the presentation with XRFS, because this can give a higher throughput through a rapid analysis. So exploration as a first level of screening, you can go, and particularly on the rocks and ores where the matrix is quite well known, you can go for a wavelength dispersive X-ray fluorescence technique or energy dispersive X-ray fluorescence techniques. And I have listed the major oxides which can be studied by this technique, along with the trace elements which are selected in nature. And only condition is that metrics of the sample should be quite known, which you can always make come to know either by using certified reference materials and with a well robust analytical application development, and along with certain internal standards by getting a multiple comparative analysis from different laboratories. So we have got the WDXRFS at headquarters at Hyderabad, Bangalore, Nagpur. This central region, Nagpur has got one and Jaipur has got one. Energy dispersion X-ray fluorescence is located at headquarters Hyderabad. Next, coming to the analytical chemistry laboratory, which is the major another workhorse, because this WDXRF is used as a tool to reduce, to considerably reduce the workload in the chemistry laboratory. It has got all the conventional facilities by volumetry and gravimetry for major in mg levels, and spectrophotometry, spectroscopic techniques. These are the major things which the laboratory is nowadays using, like AAS, atomic absorption spectroscopy, inductively coupled plasma atomic emission spectroscopy, inductively coupled plasma mass spectrometry, which will come again. And for the uranium, we use the pellet fluorimetry, and now the advancement has come into the LED fluorimetry, particularly for the water samples, which we will be mentioning again. Fluorimetry is used for the uranium. This takes a major lot of the bulk of the analysis required by the exploration teams of AMD in different parts of the country. Next slide, please. As I said, this actually again becomes the first part of an exploration here, a physical parameter, because uranium being many other elements like GSA, base metals and all, you have to essentially depend upon the chemical analysis. Here the physical property can be translated to identify the elemental concentration or get an assessment of element, because the natural radioactivity, as you all know, comes from uranium, thorium and potassium. We have got certain techniques, and to start with though it is used as a borehole gamma ray logging to get the equivalent U3O8 values, which is also an elemental concentration which you are taking it, and shielded probe logging is used as an exploration technique, and radon survey, which today morning also you have heard, radon survey is also used as a tool where also you are measuring the property is utilized to estimate the one element which is present there, and radiometric core assay. And coming to the laboratory, we, as I said, gross gamma counting is used for equivalent U3O8 estimation, and gamma ray spectrometry with different PC based and DSB based are used nowadays for the uranium, thorium, radium and potassium estimation. Here and another advancement which definitely lasted 10, 15 years, we have been, geochemists have been utilizing, is the getting a very high quality rare earth element data through the instrumental neutron activation analysis, which requires a irradiation of the sample in a reactor, which AMD has got the facility followed through in collaboration with BRC. Here we can get the rare earth element analysis in a very good nature, and all these trace elements like scandium, chromium, rubidium, and all these elements can be analyzed by instrumental neutron activation analysis. One limitation which we are having is higher radioactive samples we may not be able to take it into the reactor for the obvious reasons. But now our physics group is doing certain experiments with IGCAR in a Kalpakam mini reactor, so that certain experimental stage, it is in a developmental stage, probably we will be able to take up some of the active radioactive samples also for neutron activation analysis. Next slide. See, the present day, I said, now what is the further requirement? Further requirement comes in this majorly it is controlled by these three words. One is polymineralic nature of the most of the, as long as the ore is polymineralic, probably the microscopic study followed by chemical analysis will be more than sufficient. But nature has got another phenomena called, which I showed in the case of copper mineralization. Minerals of the same metal occurring in more than one mineral form, that is polymineralic form. Say, for example, chalcopyrite, chalcocite, covellite, cuprite, malachite. Titanium occurring 2 or 3 different forms, as ilmenite, rutile, and leucoxene. In such kind of things, these two studies alone may not be sufficient. And another thing is polymetallic. Same mineral will have more than one metal which is economically important. For example, monazite is the classic example, which has got around 0.1% uranium, 9 to 10% of thorium, but most importantly, it has got close to 50% of the rare earths, particularly light rare earths. Another thing is columbite tantalite, which has got, if the tantalum content goes, it is a tantalite end member, it attains a different significance. Third aspect is, because of the fine size, some of the metal values will be lost. It may be difficult to recover. So, for example, here the chlorite and biotite flakes are intertwined. There are small spots with pleochroic halos. This pleochroic halos, the center portion, because I have carried out the petrography, I know that over petrography under the reflected light, they show the fine specks of uranite. But when it becomes submicroscopic size, I may not be able to characterize them. Then another aspect comes, in this way, many cases, nickel, cobalt and uranium, particularly in the Singhbum shear zone, are in the unrecoverable form. Next one. And another thing is these isomorphous series and substitutions. Isomorphous series, I gave the example of columbite and tantalite. Thank you. And ferberite and hubenerite, because it is a wolframite. Whether it also changes the mineral characteristics, which will control the mineral beneficiation. And substitution, because we are talking about cobalt and nickel. Most of the pyrite is cobaltiferous pyrite is there, nickeliferous pyrite is there. Kalyadi copper mine, the copper plant tailings has got a considerable amount of nickel, because when you talk about critical minerals, these things become more important, but microscopy will not identify it. If you do the chemical analysis, you will get the nickel content in the rock. You may not know in what form it occurs. Lithium analysis today morning we were hearing that it is there, but we do not know what exactly is the nature of its occurrence. Next one. That is where the compositional characterization, mineralogy along with the mineral chemistry becomes important. Next one. That is where the role of electron microprobe analysis comes into the picture. Because we have got an electron microscope, EPMA at Hyderabad, Kamaka SX100 model microscope, which has got X-ray, that simultaneous X-ray analysis and BSE imaging is possible. It has got 3 vertical and 1 inclined spectrometer, wavelength dispersive spectrometer. So it has. See here, it has got the ability to do the micro domain level analysis, where the Pronto reactions, all those things can be analyzed, and you can carry out the BSE image and X-ray elemental scans. Next slide, please. Can show you what is the distribution of different elements. See, the first one shows the coffinate, uranite, pyrite assemblage. Here the zircon comes. Zircon again comes, you have got the BSE image shows the zonation, and we are able to see the zirconium distribution. When it comes to silica distribution, you are able to make the differences. But again, one restriction comes, EPMA will be able to give you only the elemental concentration, not the isotopic concentration. That is where another step comes, the LAICP MS comes into the picture. Next. Another extension, another part of EPMA is scanning electron microscopy. This is all the more important in the case of placer minerals and indicator minerals, or wherever sedimentological studies are involved, wherever you require a morphological studies. In a SEM with an EDS, energy dispersive spectrophotometry, will give you another added advantage of not only carrying on the textural and morphological studies, you can get a composition also, because it is like an EDXRF, energy dispersive spectrum, you can get it. This SEM coupled with a EDS, particularly it should be a field emission SEM coupled with an EDS with a suitable software and a larger mineral database, can be utilized as a quantitative mineralogical estimation, which is called QEMS, which is when commercial names, people call it as some company call them as automated mineralogy analyzer, some call it as QEMScan, Zeiss India calls it as MinScan. It has got a wider application in beach sand mineral exploration, rare earth explorations, and also in the kimberlites, wherever the quantitative mineralogy of the indicator minerals are required, because indicator minerals, mere identification will tell you that presence of that mineral, let it be magnesium spinel or chrome spinel, but its distribution, to show an anomaly, you require quantitative estimation in the soil samples. Conventional point grounding under the microscope is very time consuming, many times error will be much higher. Here, with a robust database, you will be able to do that job. But capable petrologist is required to select the samples for this kind of studies. Next one. And the geochronology study, which I mentioned, we have got the thermal ionization mass spectrometer, which I can use the RBSR and SMND, uranium lead and lead as the geochronometers. We have generated wider dates here, and we have got a very clean, ultra clean laboratory for separation, elemental separation of rubidium, strontium, samarium, neodymium, uranium, and lead. Again, the constraint which comes here is either we have to very carefully handpick the minerals to do the studies, or you can get the dates generated on the rock samples only. Handpicking is a time consuming and the petrologist has to do a diligent separation so that perfectly rounded, unbroken grains have to be picked. You will not be able to do the in situ analysis. That is the one constraint which will come here. Next one is the IRMS, stable isotope laboratory. We have got a instrumental ratio mass spectrometer with 3 different analyzers for the carbon, oxygen, sulfur, and oxygen again for in silicates and oxides. This has got, we have got our avenue has been enhanced further because all these stable isotopes will give very important clues about the nature of the fluids which is responsible for the metallurgy. That can also be utilized as a tool to extend in the contiguous areas. Next one. In the physics laboratory, along with the analysis, we have got another isotope ratio which we are using it for particularly the water chemistry. As a tool for exploration, we can use the uranium 234 and 238, for which we use the alpha spectrometry, because in the closed system with the higher half-life of uranium 234, the ratio of U234 and 238 will be close to 1 if it is secular equilibrium. The variation will give clues about the events which has led to the formation, and it can be used as a means to define what is the accumulation, what is the nature of the accumulation in the uranium groundwater, whether local or extensive, or whether stable or dispersing. This also adds one more dimension to the hydrogeochemical surveys in the exploration. Next one. This advancement of chemical science, I said, we have been using certain up to AAS and ICP AES. Now the addition has come in the chemistry laboratory is the ion chromatography for the water samples, where we have got the capabilities to do the different anions and cations. The pellet fluorimetry has been now taken over by the LED fluorimetry, particularly for the water samples. Graphite furnace AAS, which increases the capability for even ppb level of determination. Similarly, hydrate generation AAS is very useful for arsenic, selenium, mercury, etc. And next is the AAS and as well as ICP-MS, high resolution AAS, continuum source AAS and higher resolution ICP-MS will help you to carry out PPB, further lower detection limits and also have a better throughput. And MS will give an opportunity to carry out your isotopic analysis also. This HR ICP-MS with a laser ablation pointer gives another added advantage. Next one. This is the typical detection limits here. I will not go into the details. Next one. LACP-MS, it has got both quadrupole and high resolution. You can do the same ICP-MS with the laser ablation. You can use it for the in situ analysis. Here I have given a classic example of again on zircon. In sub 5 micron level beam focusing, you can get rare earth pattern, trace elemental signatures, and also the dating, some isotopic data, which will give all the both isotopic and compositional data on in situ individual levels. Submicroscopic levels can be taken up. This data becomes all the more important. So far, AMD could not get it, but AMD is we are in the process of procuring one along with another one SEM, which will be having a quantitative estimation like an SEM with a mineralogy software will also be procured. But we have started efforts to utilize the other facilities available in India, and the experiments and the further work is in the progress. So shortly we will be generating the data. Another advancement of this LAICP-MS is secondary ion mass spectrometry. Next slide, please. Next slide, please. Secondary ion mass spectrometry, it is widely used. We have got a couple of them in India. Particularly important for the geological sciences is called shrimp, secondary high resolution ion microprobe, which is nothing but a SIMS with a finely focused primary ion beam. Recently, everybody in Chambua area, a date of older date has come. It is basically essentially based on the zircon analysis. You can go for the submicroscopic isotopic analysis and submicroscopic inclusions and zonations. Earth and space evolution you can study, it is being highly utilized, the shrimp technique is being used, and monazite, zircon and titanite have been widely selected because of the robust nature of the minerals, which will keep as a record. Complete history is being recorded and is available as the texture in one of the grain which has been from one sample from this region, it has been taken, it gives to that. I am coming to the concluding stage. Next. So what I said is, this comprehensive assessment of physical and chemical and mineralogical particular characteristics is all the more important in all stages of minerals industry. Here, this role of an analyst starts from the field. Next slide, please. He starts from the field geologist, he starts with the hammer lens and that observation. That is the observation which will lead to the selection of the sample. And if an analytical scientist or specialist scientist who are all going to work with all these equipments with highly sophisticated equipment, the interlink between the field geologist and the analytical scientist is going to be the petrologist who will make the microscopic observations. Without that specific microscopic observations, even if you get a LASEPM or EPMA data, it will remain as a data. Main reason is the resolution is much higher. You will miss all the ore fabric and textural parameters which you can get only through the petrographic studies. Thank you.
Any questions from the audience? Thank you, sir. Now we'll head towards the tea time. It's actually finally the tea time now. So after tea, we'll have a 15 minutes break for tea now. After the tea, we'll have our final session. And then there would be a panel discussion followed by distribution of certificate to all the participants who have delivered their lecture now. So we'll assemble at 4 p.m. now. Thank you.
fluid, it can replace the fluid. So for that, pH should not be very high, and we have to use some complexing agent which can complex this iron or aluminium. Otherwise, it forms complex with fluid, so we will not get free fluid for the measurement. Next, please. So here main method is just take the sample and fuse with alkali and extract with water, then neutralize with.
Mandal, you're going to the topic, but finish it in 2 minutes.
Okay,
You're
okay.
almost complete the time.
Neutralize with citric acid and then pH adjustment, and then we use 1:1 the TSAB and the solution we measure there. Next, please. And where you have used the different type of flux, we have used NaOH, sodium carbonate, say peroxide and mixed phosphate, and we have next, please. Next. Here we have seen that all are except the phosphate flux, all are giving very similar result, and that is good. But there are in case of carbonate, it takes lot of time. It forms a sticky mass. To get that mass into the solution, it takes lot of time. That is the problem. Otherwise, NaOH and peroxide both are giving very good result. Or in case of phosphate flux, it is not possible. It is not around 60% fluid is coming. Next, please. So here, see, we have taken two CRM. Here in other there's sodium hydroxide, peroxide, carbonate. It is coming almost similar to reported value. That's 2.08 and 1.89. And but in case of phosphate, it is coming very, very less. Next. So these are different sample we have used there. Actually, analyze that is that fluoride vein, and it is bromo heavies. Here fluoride concentration is around 30%, 31%, 34%. Different sample we have received from Singora Basin, mainly Bargarh district of Odisha and Mahasamundra district of Chhattisgarh. Next, please. The analysis of feldspathic arenite, their concentration of fluoride is like that. And next, please. These are the other sample that we have analyzed. We have got around say some sub percentage level of here. Next. Here other basic type of sample, there we have got less than 0.1% fluid concentration. Next. The actually accuracy of the method we have established by using this CRM, where we've got very good recovery, so method is accurate, and RSD also around 3 to 5%. Only problem is if I want to go down to the next level, see less than 100 more, lower than 100 ppm, then problem comes the RSD. RSD will increase more than 10. So that we have that's why we have given less than this. And we have analyzed different sample as I have already discussed, and range are that fluid vein where bromo separated bromo heavies, they are giving around 30%. Others are this. So these estimation, whatever result we have getting, they are supported AMD's exploration program, and these are the analysis of different around say 150 sample. But for it is a preliminary result. For exhaustive study, we have to use more number of sample and more varieties of sample to establish it is this method for the further. Next. Thank you.
Okay, Mandal. Any question? Thank you. Thank you, Mandal. There is no question. Thank you. Next paper is on the WDXRF technique for determination of yttrium, lanthanum, cerium, neodymium, samarium, niobium, thorium, and uranium by V. Madakurban. He is also from Nagpur, Central Region of AMD.
Good evening, sir. I am V. Madakurban, working in XRF Laboratory, AMD Central Region, Nagpur. Actually, my topic is determination of yttrium, lanthanum, cerium, praseodymium, neodymium, samarium, niobium, thorium, uranium from polymineral concentrate of Siri River using WDXRF technique. Actually, here XRF is a technique. It's a simple, fast, and accurate analysis which can given which will give very quick feedback to the geologists in order to identify the rocks and minerals. But there is a challenge in XRF. because XRF, it is a comparative technique. It requires suitable matrix standard. If you don't have matrix standard for the XRF analysis, the analysis nowhere in the picture. In the sample, there is actually reference standard. It is available, international reference standard available for rock sample, such as granite, basic rock, soil, shale, like that. But whereas if it comes to rock to minerals, just minerals are mineral concentrate, there will not be any standards. We have to prepare standard our own. In this case, the polymineral concentrate consisting of more than 2-3 matrices, especially for it contains genotype, monazite, and some amount of columbite. For this, actually, if international standard reference material is not available, we can go for preparing standard by using synthetic spec pure chemicals, which is available over the laboratory. In 2018, under the guidance of Dr. T.S. Sunil Kumar, we have prepared around 8 standards for determination of niobium, tantalum, and tin. Where in that one, we have tin is the best. Tin contains around 60 to 90%. The columbite tantalum FeM1 Nb2O5, it was traces. So for analyzing niobium, tantalum, and niobium, tantalum in the tin concentrate, we have prepared the synthetic standard by taking tin as a base. Then we have mixed stoichiometric quantity of niobium, tantalum, iron, and manganese. Then we have spiked and we got the standard and we have analyzed. We have published in the data. But in that, next slide. In this case, because the polymineral concentrate containing more than 1 matrix, more than 2 matrix, in the matrix there is no base. Both genotype and monazite has a base. It's very difficult to prepare standard by using synthetically. So what we thought, there is one more method. We can use sample as it is for a standard. So in this, my object is for preparation of standard, development of new analytical method, then analysis of sample, then validation. The next slide. This is a recovery flow sheet for Sri River sample, raw sand. First it will go for sizing using 10 mesh, then plus 10 mesh will be rejected, then minus 10 mesh will go for wet tabling, table concentrate, and table tailings. Here table concentrate consisting of genotype, monazite, as well as some amount of columbite. It is a percentage level, whereas in the tailing rejected, it is a ppm level. We have taken table concentrate and the tailings, we have mixed together, and we prepared some 9 standards. So next slide. And already, as I already told, the reference material, the 3 type of reference materials are available. One is international rock reference material. Next, synthetic standard. If it is, we know the matrix of particular mineral concentrate. But in the standard addition method, it is using silicate rock itself. The dividing separate aliquot as table concentrate. Here we have taken the table concentrate and table tailing. That this will be used for identical matrix for standard as well as the sample. There will not be any problem. We can analyze very easily. Next, the preparation of standard, as I told you, total 9 standard we have prepared by mixing table concentrate and tailings. The next, this actually we have used the powder pelletization method. The sample preparation, both standard and samples, representative powders of 1 gram weighed using digital balance, then spread uniformly over 20 gram boric acid a bed in a sample dial, then pelletized using semi-automatic pelletizer with a pressure of 20,000 kg per centimeter. Result obtained the 41 and the dia of the pellet 41 mm. Next. Instrumentation. Actually, wavelength dispersive X-ray fluorescence spectrometry in Nagpur, it is we used model number ARL performance X 4.2 kilowatt. It is Thermo Fisher Scientific from Switzerland. The instrument consisting of almost 5 crystals, 2 detectors. There is one gas flow proportional counter and scintillation counter. Gas flow proportional counter for major oxide and scintillation counter for traces element. Then this is the instrument parameter we are used for determination of the different element: lithium, lanthanum, cerium, praseodymium, neodymium, samarium, niobium, thorium, and uranium. Next. This is a calibration curve. The individual calibration curve has been established using correct net peak intensity against the concentration of each element. Total 9 element calibration curve has been established. This is a 5. Then next, next slide. This is a 4, another 4. We got good calibration curve. We can analyze very easily in the particular area of the samples. Next. precision, any method we have to do for precision and accuracy. Here we have taken, since there is no international reference material, whatever standard we have prepared, from that we have chosen 3 standard. The 3 standard has been, each standard has prepared, analyzed 6 times. Then we have calculated precision and accuracy. This is the first standard, contains yttrium 3.99% and remaining element like this. Next. Standard number 2, that is yttrium 2.29. Then low concentration on standard we have taken. Next slide. 0.5, yttrium 0.2. All we got the errors within the limit. Within the limit, it is not within the 5% only. Only certain element, since RE and low concentration, it has given little high, but this, all the elements it comes within the perimeter, within the limit. Next. Detection limit also we have calculated all the elements by using the above equation. LOD equal to 3 by m square root of IB by TB. Then the detection of the element yttrium was 0.01, lanthanum was 0.014, and cerium 0.025, and praseodymium 0.085. Like that, all the element we have used. Next. Validation, any method we have to validate. But here again we don't have any reference standard, international reference standard. Same, 3 unknown sample. 3 unknown sample has been collected from the Sri River area. It has been analyzed. Whatever you have prepared the application, that same analysis has been compared with the well-known technique of ICPOES. That whatever you got the result, it has been good agreement with the ICPOES result. Next. Next. This is my conclusion. It's simple. Due to non-availability of certified reference material, taken the own sample and prepared 9 synthetics the reference material, and we have analyzed using the WDXRF technique, and it has been compared with ICPOES. It has come good result. Thank you very much.
Thank you, Karpan, for timely commission.
Yes.
This is open for discussion.
Sir.
But you have given value of only NB, not TA.
Very low, very less.
Whatever it, there must be some tantalum in that one.
Yes, sir. It is 0.05% and we analyze.
Any other question? Yeah, Karpan, but one small question. What was the sample 2? There was some variation, no? Sample 2. You tested, you showed the results for 2 samples. Sample 2,
yes, sir.
There was particularly some.
Actually, yttrium value ranges, sir, different kind
There the ICPOES analysis in your WDXRF, slightly higher variation was seen. And what about your PR line? Was it okay? It was. The intercept was slightly.
And there is also the concentration was very less. That's why we are unable.
PR line is slightly up.
Okay.
Thank you.
Thank you, sir.
Next is on INA technique by Y. Srinivas from AMD Hyderabad. It is on the application of INA for RE, gold and trace element analysis in geological samples. A case study from Bandaritola, Nittamotala area.
Good afternoon, everybody. I am Y. Srinivas from Physics Lab, AMD Hyderabad. My topic of presentation is application of instrumental neutron activation analysis in determination of RE, gold and trace elements in low concentration in geological samples. A case study from Bandaritola, Nittamotala, Rajasthan district, Chhattisgarh, India. So far you have heard about destructive techniques. Now I will come to non-destructive technique. This is a nuclear analytical technique with high sensitivity, selectivity, isotopic specific technique, and free from chemical blanks. Simplicity. Directly geologists, they give sample to us. We crush the sample to -200 mesh and prepare with synthetic standards, send it to reactor, and where we get analyzed. Next slide, please. George D. Hevesy is the father of neutron activation analysis, who is introduced neutron activation analysis in 1936. He is a Nobel laureate. He is a discoverer of hafnium also. Next slide, please. Why NA is required? Because sensitivity of some of the techniques that what we discussed, AAS, ICPS, of course, we are competitors, and WXRF, DCR, they are poor compared to INA technique. That is why, particularly in RE, we go to PPB to PPM level. Sometimes even very low level, like gold, we go to 10 ppb level, and this is the element, some PG elements. Next slide, please. See, with the neutron, because irradiation with neutron in reactor will give, because neutron has got Coulombic barrier is 0 for neutron, so it can interact with most of the elements in the periodic table. So we can analyze most of the elements in the period. About 2/3 of elements in the periodic table can be analyzed by neutron activation analysis. Like charge particle activation, proton about 18, like alpha particle, photons, a few. Next slide, please. The principles of activation analysis is stable isotope. When it is bombarded with neutron, it forms a compound nucleus. And by artificial, because we are stable sample is being transmuted, artificial radioactivity we are generating. Like this, suppose neutron bombarded with stable sodium will give sodium 24, magnesium rotor, the delayed gamma, that gamma which you are coming, that is being measured in the laboratory. Next slide. See this how, this is a pictorial depiction. Projectile is neutron, target is sodium 23, sodium 24 is the excited compound nucleus. Because of beta decay, that what is induced activity is there, we are measuring by hyperpure germanium detector. Next slide, please. See, target will be, see, we have different neutron sources. Neutron sources like isotopic sources, calcium 252, different alpha N sources, plutonium, beryllium, radium, beryllium, lambda-cium, beryllium, and neutron generators which depend on DT reaction, but their fluxes are little low. Now we are going to research reactor where the pool of bunch of neutrons are there, when the flux is very high. Like Cyrus earlier we used to do 10 power 11 and Apsara 10 power 12, Cyrus 10 power 13. Now we are irradiating sample in Dhruva reactor where the flux component is very high, 10 power 14. So they are irradiated in tray rod, and after irradiating, the samples are brought to Hyderabad. By flight we will come and we will rush to the airport and collect the sample, and in intermediate to long lived isotopes we are measuring in Hyderabad. Sitting in Hyderabad, analyzing about 30 to 40 elements in Hyderabad. Next slide, please. The famous activity generated by this equation is activity generated n sigma pi 1 minus e power lambda ti, e power lambda td, where n is the number of atoms present in the sample, sigma is the cross section, pi is the neutron flux in the reactor, 1 minus e power lambda ti, time of irradiation, is the saturation factor, e power lambda td is the time delay factor. These things are taken into account. This is the absolute method of analysis. Okay, next slide, please. The simultaneous measurement of both gamma ray intensities for several gamma emitters. Single irradiation will give about 30 to 40 elements in the sample. Judiciously, you have to select the sample, which are based on half-lives. Some are hours, some are minutes, which we will not be able to do. Some are days, some are years, like that. All those things we can measure. Come on, I will come to that. Next slide, please. See, in this case, we have taken the Dongri Kotri belt identified as one of the multi-elemental, multi-metal provinces of central India. Occurrence of gold is not known earlier. Bandaritola, Netamtola areas where sheared activated basement contacts of acidic and basic rocks with hydrothermal sulfide mineralization in Nandan group of Dongri Kotri belt rift zones in Sinha et al. Next slide, please. These samples were given to us by the geological team. Since the gold is precious metal, the analytical procedures are very important, and INA technique is the best method. And NA comparison to the conventional fire assay, which is very costly also, this gold which comes to very low level of detection, 10 ppb, we can utilize by this technique very nicely. So that is why this technique is adopted. Because with the advent of high resolution gamma ray spectrometry using hyperpure germanium detector, so we have done this analysis. Next slide, please. Random representative surface graph samples over ultra basic number 5, n is equal 5, and quartz porphyry in Raleigh, n is equal 7, along the sheared contacts in Bandaritola and Netamtola areas, rather than research were studied by this technique. Next slide, please. This is a geological map. Next slide, please. These samples are collected from this. Next slide, please. So 5 representative samples from each geological unit, rhyolites and rhyolites with sulfide samples, and cryptocrystalline nature of rock samples with smoky quartz. These samples are taken where we have got very good results of gold. Next slide, please. This is a block diagram, irradiation at 2 reactor. I have already described the preparation of sample and the decay. We have to give some cooling time because radioactively sample will be very hot. Next slide, please. The collector samples are granted, I have already told, and these samples along with synthetic standards and are irradiated simultaneously. Simultaneous measurement of both the standards as well as samples, where all the parameters will be nullified, like geometry, matrix effects, all those things are nullified by taking this and reacted, and 2-3 days cooling time irradiation is done. And particularly, we have checked with the samples with international CRMs like G2, USGS standard, GA-CRPG France standard, ORPT is a rhyolite supplied UK, and G98 gold ore from Australia is taken for comparison. Okay, next. This is a sample preparation. Simple sample. Only we require 10 milligram of sample for 10 power 14 neutron flux. Whereas in Kamini, right now we are working in Kamini, we have, because the flux is 10 power 12, we are using about 100 milligram sample. Next slide, please. This is a sample container. We put the sample in the hole and we will put it on the detector. Next slide, please. The elemental constellation was done by INA relative standard method. Relative standard method, one of the 99% of world laboratories are using this method, where the standards as well as samples are simultaneously irradiated. It is assumed that neutron flux and cross sections, irradiation times, and all other variables associated with the count are identical for both standard as well as sample. The concentration mass of the element will be estimated this equation, where the count rate is standard and sample. This is the thing. Next slide, please. Gamma ray spectrum of different samples and were analyzed by HPG detector, where the resolution plays very important role, because since suppose you are doing with one element, you can do with sodium iodide detector, but since it is the multi-elemental analysis, you require a high resolution detector. So we have a p-type PG hyperview germanium detector, where the resolution is about 1.74 keV at 1332 keV of cobalt, and the volume of detector is 140 cc's. Is a relative efficiency about 30%. So we applied operating voltage of 3000 volts. This is a semiconductor detector, and the WinTMCA software was used for the spectrometric purpose. And this is the complex spectrum which we are analyzing. Every phase manner we estimate. Immediately sodium, potassium, The average gold we got is 688 ppb. Next slide, please. This mine. So this riots are gold. Yeah, yeah. Thank you.
There is one important observation in the presentation of the analyst.
Yes, sir.
Whatever maps they have shown, they have the reference of the mapper was there. And whatever technique was, the reference of the technique was there, which is a really very good thing, sir. It's ethics in the presentation. So, which otherwise in many things it was missing. So, for that, I really appreciate you all, sir.
Thank you.
Thank you. Thank you, Srinivas. I think we are concluding the program. There were 4 presentations. I thank the organizers for giving Kulkarni and me the chance to organize this session. Thank you.
Thank you, Dr. Sunil Kumar, Sri Kulkarni, and all the presenters for enriching the session with knowledge. May I request Sri Arjuna Panda, the convener of the seminar and Regional Director AMD Central Region, to kindly felicitate Dr. T.S. Sunil Kumar for chairing the session. To commemorate the feelings, the joy we have gathered during the seminar, let us capture it right now. So a photographic session will be happening now. A small time is required for the stage arrangement, which will be followed by the panel discussions hosted by my colleague Sri Pratyay Pradhan. वो दोनों टेबल आ आगे ले आओ और आगे वो वाली फ्रंट
We'll like to request all of you to come on stage. It's time for a group photograph. So please come on stage. Sir, sir. Sir, सामने। ए, इधर आ जाओ। इधर आओ। चलो। ये बेस्ट है। नहीं ये सामने का ये रखना है। नहीं इसको हटा देते हैं लोग पीछे है। एक आधा आ जाएगा। रजत तुम सामने आ जाओ भाई। दिख रहा है
छोटे लोग मंच गिरा के हम हैं चल ठीक आ रहे हैं ना चुप जा रहे हैं अरे हमारे सामने रजत आ रहा है ऐसे करना पड़ेगा हाँ सर
Sir, everybody please come on stage. We'll arrange accordingly. So everybody please come on stage and stand accordingly so that your face is at least a bit visible. Okay. I think almost all of us are standing. Pritam okay. So I guess everybody has taken their position. Thank you.
बैठने के लिए बोल
वेंकटेश सर बैठ जाइए आप लोगों को बैठने के लिए बोला जा रहा है हाँ हाँ बैठ जाओ बैठ जाओ घुटने में घुटने टिका
चेयर में खड़े तो हो रहे हैं, गिरना मत। हैंडल
पीछे वाले रो में चले जाओ। हाँ, हाइट तो उतना ही है। अरे भाई एक रो पीछे
मारने का नहीं, वो बंदा मारने के लिए ढोल लगा।
Thank you all.
ये रियल है।
Greetings to one and all again. We are almost at the end of 7 sessions over a span of 2 days of articulate, fruitful, and brainstorming technical discussion about Chhattisgarh Basin and its environment. As indicated at the very beginning of the seminar, it was a sincere effort of all the 3 organizers, namely Atomic Minerals Directorate, RTMN University Nagpur, and Geological Survey of India, to adopt a sustainable model for more efficient channelization of theoretical knowledge into real-time exploration. So indeed, this seminar provided a platform for amalgamation of thoughts and coordination between exploration geoscientists, research scholars, academicians, and students. Now, for discussions on the accomplishments of this seminar and to identify further scope of work, I would request some eminent scientists present over here to come over dais and have a session so that it will enrich us to conclude the seminar in a more efficient way. So may I request Dr. D.K. Sinha, Director, AMD, Sri Sarvanan, Additional Director, Operation 1, AMD, Dr. Sunil Kumar, Additional Director, R&D, AMD, Sri Sesharai, Director, Geology, Geological Survey of India, Nagpur, Sesharai, sir. Sorry, sir. Dr. Prabeer Kumar Naik, Director, CGWB Raipur, Dr. K.R. Randive, Professor and HOD, Geology Department, RTM, Nagpur University, and Sri Dongre, Director, DGM, Raipur, to come on stage and have a discussion. I'd also like to request Dr. D.K. Sinha, sir, to chair this panel discussion session and conduct the panel discussion.
So, good evening. And finally, we are landing to the last session of seminar. This is the usual way of having a panel discussion in which we deliberate the issues what we have seen during 2 days seminar. Usually at the end, we are full of knowledge, full of our thoughts, and that comes here in a form of proceedings which will be out based on 2 days deliberations. Very important session. This, in fact, the cream of whole seminar will be packed in this deliberations of say 45 minutes or 1 hour, and we'll be having the feedback session as well. Many students are participating, professors are participating, and professional geologists are here. What they have felt about this seminar, what they want further in future from the professional institute like Geological Survey of India, AMD, industry side, and from academic side, all those things are going to be a part of this 45-minute discussion. The usual way of such type of panel discussion starts with the impression of chair of the sessions. They give their impression. So I'll start one by one from the chair of the session, those who have already headed that, and what is their feeling after hearing the presentation. And then I'll be requesting a few more participants to give their opinion, and then anybody whosoever is interested to speak on or rather comment on this type of seminar for future purpose, for making us more efficient way to handle such type of seminars will also be there. So this is in my mind, and I'm starting with one by one the panelists who are sitting here. The panelists are well known, already it is announced, so I'm not going to take time to get into it. When they are going to speak, they will be just telling about their name and affiliations, and accordingly. So I'll start from my left side. Nayak Saab is sitting, because water is a must. So it should not start with, everything should start with water. Yeah.
Good evening, everybody. I think I'll not take much time to introduce myself. Myself, Dr. Pravir Kumar Naik. I am Regional Director, Central Groundwater, Raipur. I think Dr. Pandai is also Regional Director here in AMD. So I thank Sinha Saab to give me opportunity to chair a session. And it is a very, I have attended so many seminars, workshops. I think I have learned maximum in this seminar because it was a closed topic regarding Chhattisgarh Basin and its environment. So mainly people from Nagpur, Chhattisgarh, then Bangalore and Hyderabad, they were involved. Otherwise, many seminars we attend and there are so many topics, but it was a focused and closed topic. I think so many things we can learn, and a proceeding, the topics were very useful. I think a proceedings must be published. So it will be very useful for, yeah. And it will be that time also I told, it was if we work closely between EMD, then Geological Survey of India and Central Groundwater Board, then it will be more useful, I think. We can deal with the different aspects of rock, then the fractures, and we are concerned about the groundwater. Government is more concerned about the mineral resources, but ultimately people use the groundwater. And just I am just debating little bit. In Noapada district of Odisha, there is lot of fluoride problem, and the Noapada district is highly affected with fluoride. That is the your boundary between your Bastar Craton and Eastern Ghat mobile belt, and in that fault zone, we can say there is heavy mineralization. So the geology and hydrogeology is directly related. I in also CGW I tell hydrogeology is geology plus hydrogeology. So first we should know the geology, then only hydrogeology comes. So there should be a coordination between these departments. I also invite the students, they can take MTech thesis, and we have lot of data of Chhattisgarh Basin. So that will be helpful for them, and it will be helpful for us for data generation. And we discussed that there is so many problems in Chhattisgarh Basin in groundwater, fluoride, then uranium and other things are coming, like sir suggested regarding with uranium, you should analyze radon. So we will try to include those things. And Sinha Saab also told actually earlier pattern, every pre-monsoon in the month of May, we are collecting same water sample from the wells. So just from this year, there is a proposal that if there is anomalies like uranium, we'll collect water from the surrounding areas that is affected areas. One, also cyclically. That is also in just July 20, we have regional director meeting at Faridabad, our headquarters. There they suggested that if some problem is there, you can collect 4 times, otherwise pre-monsoon and post-monsoon. And when there is no change, then just 1 time is sufficient. So I'll also suggest to our chairman and that Ministry of Jal Shakti, before becoming director here, I was in Ministry of Jal Shakti, and that our policy and the mandate can be also changed, and which will be useful for the people. Thank you.
As he said, and the derivation ultimately has resulted that we should collect more water, and then we should specify whether it is really there or not. That type of, this is a contribution from this seminar, I can say. Of course, your ministry has to take the care, but it has emerged from this fall only within the discussions of delegates and participants. Thank you for this session. I'll request Sesasai Saab to give his comment.
Thank you, sir. Good evening, everybody. This was a 2-day seminar on Chhattisgarh Basin. All of you know it's one of the largest sedimentary basins in central India. So there were about 7 sessions, technical sessions, and 36 presentations were there, very nicely conducted, including 7 keynotes. And the good point is whoever was not available, they also presented online from their respective places. So the topics right from geology, geochemistry, geophysics, mineralization, mineral exploration, everything was covered in a very nice manner, sir. So during the course of presentations, what I have seen is, of course, geologists, they have presented their observations on the rocks, lithology, mineralization. There were some very good presentations on geophysics also. One of the presentation we saw that the whole Chhattisgarh Basin is underlined by a gravity high and a magnetic high, which actually we discussed, perhaps maybe because of a concealed ultramafic body. Such type of new thoughts, because one of the purpose of the seminar is to get new thoughts also. When somebody is presenting, some people who interested in that field, so they see the slides and they get new thoughts, and that they'll apply the new thoughts for further exploration, either for academic or for economic aspects also. So that way, some of the presentations were very good, sir. And particularly what I saw, because I was new to this type of things, so most of the atomic minerals what they have presented, mostly they were confined within the fracture zones. And some of the presentations were on the basement also, the basement, some of the fossilized fractures as well as the reactivated fractures. So this is how it has gone, sir. And of course, some of the presentations dealt with industrial and fertilizer minerals, precious minerals, phosphorite, glauconite. So wide range of things were covered. And apart from that, the groundwater, the soil, everything, including the analytical techniques were also discussed. So I was right, 2 days I was here. So what I saw, sir, maybe because this uranium, thorium, zirconium, all these strategic and critical elements, they are very important, and everybody are doing their role in this, sir. So maybe further works, integrated works in the field of geology and geophysics, mainly, sir, geology and geophysics, wherever the sediment cover is shallow in Chhattisgarh Basin. We have seen in the geophysics presentation, in some places, the sediment cover is very shallow, and the basement is protected, sir. Since that sediment is almost mesoproterozoic, the basement is protected and means it is not eroded. So such areas wherever, because people can find out some new zones where intense fracturing is there, and maybe you can relate the mineralization, uranium mineralization within the fractures which are concealed below. So this type of integration works also, because I have seen some of the presentation, even some of them were even capturing the slides also. So interesting they were, sir. That is my suggestion for you, sir. So, and I congratulate all the presenters and all who were present here. It was a very successful seminar, sir. Thank you very much, sir.
The message is very clear. 2 points are emerging from his discussion. One is that integration in the data, that is geologists, geophysics, and we should go for shallow basin environment where we can puncture and we can look for mineralization. It could be anything. Mineralization doesn't come alone. That is one thing. And second thing, the platform given by such type of seminar where 2 departments or 3 departments are seeing with the eyes of one department. So naturally new data generates. The geophysical data, what we have discussed today, probably might not have discussed like this. And the message was very clear from Science Hub that it should be discussed like this in such type of forum. Thank you, sir. And then now I'll request, since from academic side, RTM, head of the department, geology, Randive Saab is available, and I request him to give his comment and panel related suggestion.
Thank you, sir. This has been a terrific journey for us. We have been working very closely with AMD and GSI, and now that this moment has come, not that we were waiting for this moment, but for the culmination of this moment in this manner, I can see that the gathering is full, the hall is occupied. At the very stage of inception of this, when the AMD has approached us with this idea that we will have a seminar confined to Chhattisgarh Basin, we had our own apprehensions that how something like Chhattisgarh Basin, where not much work has been done, can be a topic of seminar for 2 days deliberations. But again, it was to this person, हमारे बड़े भाई साहब, he is our senior. When I was student, that time he has already completed his PhD. So it was his idea, not this time, but even earlier he has made a complete seminar out of Kotri Dongargarh lineament. Before that, many people were not even much aware of that Kotri Dongargarh belt, but now everyone talks about that belt, how mineralized, how fertile that belt is. And the same thing, exactly same thing has happened with Chhattisgarh Basin, and now onwards people will know more about this basin. Of course, we were also not much knowing about this basin, but now after the deliberations of the 2 days, we came to know how much potential it has. So I request you all to join hands for Dr. D.K. Sinha Sahab. He is the person behind it. It is his idea, is his will and wish, and it is because of his single-handed will. Of course, we were all there as a support system, but idea was his and his conviction that there can be a seminar of this type and it can be successful to this extent. Sir, while I was listening to several presentations here, I came to several ideas, came to know several ideas from the people which propounded it. The most interesting part of this is that uranium is a completely different system. If we see the gold, silver, and other base metals, they form the part of different systems. The area which is most fertile, which emerges to the presentation of Sinha Sahab and others, that the basement and the sedimentary cover, the zone between these two is very interesting zone. It is one of the most fertile kind of zone where a lot of different type of mineralizations do occur. For uranium also, we have a system which is migmatic, completely a mantle related SA element type of system we have. And at the same time, we have much shallower system also. Similarly, the other minerals which occur in different systems, some of them needs the magmatic inputs, whereas other are completely hydrothermal. So if we try to integrate the things, we come across a completely different picture, and in which the geological systems also work in unison. At one level they operate and produce a kind of mineralization, but the same processes, when come to the shallower depth, they operate in a different manner. So such type of studies also we can take up in future. Now that the gate is open, we can see the things more clearly thanks to this seminar. So thank you very much.
Thank you, Professor Randeve. And this is his affection, what he said in first part. And second part, you are right that this type of discussions are very, very essential, where we know after the deliberation, at least academia is aware that what type of mineralization, how uranium behaves, and even Geological Survey of India probably, many may be knowing, but many may not be knowing that when you are searching for other metals, uranium is also in your journey. So similar way, mineralization is similar. That's what is my message. I always say it is not a different metal. It is the same metal in same environment, in same process, same metallogeny. It also comes. So you may also find you, but that time you just tell us that you have find. We'll take care of that. You should not take care because it is radioactive. Thank you, Professor Randive. Now I'll request my colleague Sri Sarvanan to give his comment as a chair of the session.
Thank you, sir. These 2 days deliberations were really lively, and I could come to know about the Chhattisgarh Basin and its environs. The elders who are in the first row, the elders really very active, and they took part in almost all the presentations in discussing the various points. This is really one thing I could see, and I mean, I wonder how at this age also they are here and they are guiding the young generation in the geology and exploration. This 2 day seminar has been very nicely organized. I congratulate the organizers for that in all aspects. When we come to the technical sessions, almost all topics of geology has been covered. right from geology, structure, mineral resources, geothermal potential, hydrogeological aspects, and of course the Chhattisgarh Basin as such, it is having potential for many of the economic minerals like diamond, iron, so on. So particularly when we look into the exploration part, the geophysical surveys that play a very important role, where the session I chaired was on geophysical surveys. 3 papers were presented. They had lot of information, particularly the first one where Mr. Srinivas from GSI, he presented on the basinal and crustal configuration of Chhattisgarh Basin. It's really very, very informative. I think this data will be very, very helpful in planning the exploration of many of the exploratory organization. They can plan their exploration where they want to drill for particular mineral. There's 2 more papers were there from AMD. They also had a lot of information. I think we should use this data in uranium exploration, particularly the unconformity type of uranium mineralization. There is a scope in Chhattisgarh Basin. This is one aspect I wanted to. As far as the objectives of this seminar is concerned, I feel it is fulfilled with igniting the thinking process among everyone who has attended this 2-day seminar, and now all will start thinking, and they will definitely put their mind and for the further developing the concepts and applying it in the exploration part. With these words, I thank once again our director, Dr. D.K. Sinha, for taking a lead in organizing this seminar, and all my colleagues who has been instrumental in bringing this seminar to this level. Thank you very much, sir. Thank you.
Thank you, Sarun Sab. Sarun Sab has clearly given the verdict that geophysics has very good data, and when we are analyzing the Chhattisgarh Basin, we cannot ignore the subsurface component of the Chhattisgarh Basin. And in this symposium, that the 2 papers what have been presented have given us insight to the basement. Probably that has ignited. You are rightly pointing out that the thought process has initiated, and in next seminar or symposium where we are again going to assemble such type of information would be useful for the exploration point of view. Thank you. Now again, I'll request Dr. T. Sunil Kumar to give his comment on his session.
Thank you, Sinha sir. Overall, this seminar has got a unique character because now mostly when the geological seminars will be on theme-based, when it comes, it will be covering multiple of geological domains, may not be exclusively for a particular basin. This has become a seminar on a particular basin, and because of that, many aspects which pertains to that basin, starting from hydrogeochemistry and also the water quality, because hydrogeochemistry as a tool comes into the picture, but in this seminar, as water quality and groundwater information also has come into the picture. And right from starting the basin evolution, geological modeling, and to the exploration, the mineral wealth, exploration tools which are used for the finding out the mineral wealth, that has been covered, and including the mineral inventory and mineral economics from has been covered in this seminar. That is the beauty of this particular seminar, which tried to all encompassing aspects related to geology and mineral wealth of Chhattisgarh. Mineral wealth includes water also has been covered. And specifically, there were very, very interesting papers on, particularly on the geophysics, as has been told, particularly on Trans-Chattis lineament also it has been mentioned. And uranium exploration different aspects has been very conclusively expressed, and 2 different places it has been mentioned. Overall, if you see another paper with the stratigraphic riddles, that paper, that presentation and continued discussion also has given several insights into what is the basement thickness and the geological aspects of the total basement thickness also. Coming to the session which I was chairing, that session had 4 papers on analytical techniques. 3 of them were basically on the chemistry. Chemistry in the sense 2 were on the analytical chemistry on bauxite and laterite analysis on ions, and second paper was on ion selective technique for the fluoride analysis. Again, it was specifically for the ores and samples from Chhattisgarh Basin. And there was also another paper on WDXRF technique for making certain new standards so that the placer mineral deposits can be analyzed in a proper way. The neutron activation technique also has, as applied to the samples in this area, has been mentioned, specifically presented. Probably this particular session missed a papers exclusively on petrography or ore mineralogy, but definitely that has been covered by 2 geologists, and the 2 other sessions, Mugundan and Bedia, has covered the ore petrographic pattern in the other sessions. So that part was covered as a holistic geological seminar. Overall, definitely this is a success, and the credit goes to the organizers under the leadership of Dr. D.K. Sinha sir. I congratulate one and all, and thank all the organizers for giving us this chance. Thank you.
Thank you, Dr. Sunil Kumar. And he has expressed the satisfaction for this conduct. Analytical techniques are the must for any exposition program or for any academic output. And that session was very well balanced. Almost we have touched everything. Nothing is left out of that session. The latest technique, INA technique, and the techniques on XRF, many things are included in that. So the session was conducted well, and the matter what was discussed was also of excellent nature. Now we have with us DGM Chhattisgarh, the participant Mr. Dongre, and he has silently observed our deliberations. And I think he is the right person to comment upon unbiased way that what he has seen and what is in his mind, what he has seen in 2 days.
Yes.
We would like to hear from you, sir.
Good evening to everyone. I am very much thankful to Sinha Saab, who has organized this program in his own leadership, and many of the presenters present their papers and covered all points which are concerned to the Chhattisgarh Basin and its environment. So we are the exploration geologists. What is the opportunities and what are the potentials in Chhattisgarh Basin with respect to the exploration of the variety of minerals? So we are very much thankful. This seminar was very knowledge gaining, and most of the people were presented their papers, case studies, not only in respect of KCR, diamond bearing projects, where we can proceed forward for the exploration. Madam Devalkar has also presented his paper. It was very interesting. And today's Srinivas Saab, he has also presented the very good information where the ultramafic body can be expected beneath the Chhattisgarh Basin. So I am very much thankful to the organizer who has given this opportunity to gain the knowledge. Particularly, Mr. Sinha sir said that I was observing each and everything very silently. So it's my motive to get acquainted all these process what actually doing by the variety of organization, not only in the respect of the mineral exploration, Mr. Nayak has also given his valuable support to this seminar in respect of geological hazards. So I am again thankful to all. Thank you. Thank you very much.
Thank you, Dongre Sahab. In fact, this panel has got two ends. Both ends are from Chhattisgarh. And you are the real beneficiary of this symposium. Ultimately, whatever has been discussed, it is going to be property of Chhattisgarh state. so this is the symposium where you have networking and the knowledge of networking. Many things have emerged. Everything cannot be discussed right now because of time, paucity of time. But certainly, the symposium has given a very good background where we can have discussions further, we can collaborate, we can develop further, and we can contribute ultimate things what is required to the societal benefit. So this is from panel, and now I'll do one more duty as a part of chair. I have to speak, so I'll take that duty first. Then I'll invite the people, and I'll call Professor Trivedi also here. So he should also be getting ready. Before that, I will speak on behalf of the chair first. I was part of the session 4. Many good things were there. Dr. Pradeep Jain gave an overview of Chhattisgarh mineralization and related legislation, policies, 13 policy of Chhattisgarh, 19 then latest policy of 19 policy of mineral development. All those things are required. So it was a different perspective, but that is required ultimately. Policies has to be known to us, by which policy we are going to handle the mineral resources. And he said that 10% production is there. The question is, if you remember, that means resources are there, production is as per demand. If demand is more, our Chhattisgarh state is ready to provide the resources from the Chhattisgarh. And Mukundan has given a good exploration base for uranium exploration, and that is being used in our program. The best part, the hot part, or the hot water part was from Sakhare, and it has created a lot of hot discussions. Probably the time could have been given more than the presentation was on discussion part. And this gives the real essence of any symposium. When the presenter is facing number of questions and batting against number of items, explaining, and then chairman has to ultimately say, no, sir, now your time is over. Question time is also over. So this type of discussions are the spirit of any symposium. That was the, I can say, that was the best part of this symposium, what we have seen in hot water regime. We say hydrothermal, but he sees geothermal. That is the only difference. So lot of aspirations are there. Country is looking for geothermal energy, and we will be very happy to get the news that Tatapani has got 3 megawatt thermal power plant. Then Misraji has given a lithium mineralization related golden brown mica. It is a very good find, and it should be investigated. Lot of things are there. Golden brown mica has to be understood. What are the metallogeny and the rock? What he was showing, hyalophanous granite, if I'm not wrong, and some kilometer. It has to be seen in broader perspective. If this golden brown mica is available, say in 20 square kilometer, then we have got a lithium deposit, and lithium deposit ultimately can provide many things. So it needs research. The idea is well taken. We'll also look forward. We are also looking for lithium with reference to lithium isotopes. Our mandate is also there for lithium isotope. We look for Li6. So that is also a very good part of discussion. And then, yeah, after that, I had an opportunity not to take another paper, so it was completed. So this is from my session, what I chaired. Now we are going to second part. We have to get the feedback. Why I referred to Professor Trivedi, because Professor Trivedi came from Sagar University and he is, I think, contemporary to Nagpur University. Nagpur University and Sagar University originated on the same day, the same year, probably 1946. So I'll invite Professor Trivedi, and Professor Trivedi has given another opportunity for the delegates who are participating, that probably he is going to invite for Vindhyan Basin seminar on similar concept. So Dr. Trivedi, please.
Thank you, Dr. Sinha, for giving me this opportunity to talk in front of this gathering. The first thing which I liked, particularly in this 2 days deliberation, that the younger generation got proper time and they got a proper boost from this Precambrian bench. All the youngsters, they participated and they were listened by all the persons very well. Probably I am seeing this for the first time where the youngster got this much of importance within a seminar. May possible that their finding, their observations are not that mature, which we are observing the things in our way. Secondly, being a professional organizations like AMD and GSI, the academic organizations like us, universities, they doesn't have that much of infrastructure as far as the analytical part is concerned. So I must suggest here that there must be some collaboration, particularly with the research. These organizations, certainly they help, particularly in analyzing the things, material, because university doesn't have such well-equipped labs in their premises. So my suggestion with these organizations that they must give some thought on this line, that the collaborative research. Suppose any of a student who is working in any university, he may be provided a co-guide from your organization. And I must thank the organizer, Mr. Arjun Panda, and organizing secretary P.K. Gupta and his team, right from the top to the bottom, who has made all these things. So thank you very much. A seed is sown by Dr. D.K. Sinha in my mind that I will work on the same line what he did for this, particularly Chhattisgarh Basin. We have another sedimentary basin right from Chittorgarh to Sasaram and from Agra to Hoshangabad, the Vindhyan Basin. Okay, and apart from that, we have the Trans-Aravali Vindhyans. So with the mind and the line set by this team, we are planning to hold a seminar, particularly in the month of November on Vindhyan. And as far as the initial topic is concerned, the paleo environment and economic potential of Vindhyan. So all you are invited to participate in the similar manner at Sagar also.
So this is again one recommendation from Professor Trivedi I take in that way. And if seminar gives some direction, I think that seminar is going in right direction. The concluding session is going to right direction. Professor Trivedi has given very good points that collaboration is a must. Academia and industry, they should go hand in hand, and probably now in new era, we are having that type of collaboration. Even Government of India is also supporting that industry can go to academia, academia can come to industry, and the ultimate benefit has to be given to younger generation, that is students and research scholars. So we are practicing it, and in Geological Survey of India and in AMD, we are following that type of environment because it's a geology is a field subject. So we are taking care. Thank you for Professor Tavedi. Now I will take opportunity to invite our young friends. We in last seminar what we conducted in AMD Hyderabad in the month of April, there one deliberation, one point emerged that whenever you conduct a seminar, you invite universities and students and you sponsor. That was the recommendation made in that seminar. And luckily in that seminar, some 50 students and research scholars and professors were participating. And this recommendation was from Professor O.P. Verma, the doyen personality. Everybody knows that he is the 98 years and this year he got the Mineral Award also. So when he saw some 50 people sitting and young people, and he was very happy and he said that you should keep this recommendation from my side. I said, so we are keeping that, and it was published in the Geological Society of India in the volume of May 2022 in the summary of seminar. So in the second leg, this seminar came and we followed. So we have some young friends from the university. They are research scholars, they are students, MSc students, along with their teacher also. They have traveled from Visakhapatnam, from Ranchi, from many places. We invited some 15 universities, but only a few could come because of many requirement at this moment, since session is also starting. So first I'll take the opportunity to call RTMNU participant Swapnil Desmukh. Swapnil can come and just say some thoughts, whatever is, feel free, whatever is there in your mind. Hindi, English, Marathi, anything is free for you.
Good evening, everyone. My name is Swapnil Deshmukh from Nagpur University, Research Scholar. Sir, I would like to thank you for conducting this seminar. And this seminar enriched our young minds with very good knowledge. And I'm sure the series should be kept in going because this will impact our knowledge. This will enrich our research methodology so that we will do a good research and we will be a good researcher in the next few years. Thank you, sir.
Thank you, Swapnil. And since you are local, so you were not sponsored, but you can contact Professor Trivedi. He has to sponsor you for his Vindhyan seminar. Contact right now. He has to sponsor you so that you can go to Sagar. So that is the spirit which make younger participants to come to us. Now, next we have from Ranchi University, some students are there. I'll call Mr. Amit. Amit can come and say whatever is in your mind. Hindi, English. Sorry, you faculty member, eh? You are professor. Okay, please. Sorry. You look like a student.
Good evening, everyone. Actually, this is first time like I'm attending national seminar, and this seminar was very interesting to me because this Chhattisgarh Basin, I never thought it has so much economic potential and it has so much interesting geology, and I learned a lot and I got so many ideas, and I'm working on over economics, so I got ideas about different because of its mineral potential, limestone and pyrite and uranium, of course, and other iron ores. So it was very interesting. And I'm representing Ranchi University, and I'm also doing PhD. So I'm doing two works at the same time, and this whole seminar was very nice, and I learned a lot, and I'm planning to contact all the great minds to collaborate and learn and to proceed further in my career. Thank you very much.
Thank you, Mr. Amit, for giving your opinion. Now we have a student from RS University, and we have Miss Aditi Sinha. She can come and say a few words.
Good evening, everyone. Myself Aditi Sinha, and I'm from Pandit Ravi Shankar University, Raipur. I'm a student of Masters in Geology, and being a geology student, I found this seminar of extreme knowledgeable topic to be discussed on Chhattisgarh Basin, and I find myself extremely grateful for this opportunity to attend this seminar in front of with all the huge and recognized dignitaries present here. I was amazed and fascinated to see the so much of research works and exploration work that has been done in the Chhattisgarh Basin by various people and with the combined efforts of various departments, institutions, and organizations. This seminar will act as a stepping stone for the upcoming research scholars and the budding geologist. So overall, it was a great learning experience, and I thank you, everyone.
Thank you, Ms. Aditi. Then I have students from Andhra University. May I request Hari Krishna to please come and Andhra University. Almost from all parts we have.
Good evening, one and all. I am Hari Krishna Sanapalla from Andhra University. I am a research scholar. I'm going to submit my thesis maybe in December or January. First of all, I would like to thank AMD and the Rashtra Sant Tukudoji, Maharaj Nagpur University and Geological Survey of India for conducting this 2-day seminar. Organization is nothing but a group of people who dedicated their talent to the growth of society and welfare. Those organizations are being led by legendary personalities like Sinha sir, Panda sir, and Subhash Chaudhary sir. Lot many are there. I would like to thank everyone, and this seminar is an opportunity to everybody to share their knowledge on this dais. I experienced a lot, and this seminar helped me a lot to understand the subject, the way how to question the thing which was written already. Here lot many sirs, I don't know their names exactly, but they have ignited the minds of a lot many. They have proved that age is just a number. If we compare with them, we can achieve a lot. I'm extremely thankful to one and all for giving me this opportunity to be here. It's an honor for me, and thank you, sir.
Thank you, Hari Krishna. So you have looked to senior. So now I will request the great senior of ours who are here in the seminar hall, and I'll request Dr. S.K. Hansoti first. Basically, they are plus 75 years. Plus 75 years, we are celebrating the 75 years of independence, and they are pre-independence senior. So they have got a class. We all are younger to 75 years, and they are all senior to 75 years. We have that opportunity, and they have paid full 2 days time for the benefit of youngsters. So I'll request Dr. Hansoti to say whatever is in his mind. Yes, sir.
Well, my suggestion to all the institutions which are sitting in front of me on the dais, my suggestion is that there should be a better coordination between all the institutions. There should not be any duplication. There should, so that if one institution, as I heard this morning, that they are doing water sampling, water analysis. So whatever data they collect, they can add, as I suggested that time only, that radon, helium, all these elements also you include in your analysis. And then that data can be circulated to all the institutions. That is my suggestion.
And this is a very good, pertinent point what you have said. And I know since I have worked under you, so I am aware of this type of need. Now I'll request Tiwari sir to give his, of course, he has asked many questions.
I don't have any questions.
I'll not answer any questions, sir. Please give your suggestion.
Respected geoscientists of MD, GSI, university, and my young friends. When I came to Nagpur, just my boss, Mr. Sharma, asked me, you go through literature and find out where is the unconformity type of mineralization in this area. I went everywhere, searched so many books, searched so many records, but I did not find where it can be there. Now I am very happy that our young friends, Mr. Kamlesh Kumar, has given some arenite type of mineralization in this area. And it may be, I don't mind any age, it may be of any age, but it may be of the herbal type mineralization. Thank you.
Now we have a mining engineer with us. He is also a very senior person, and from Indian School of Mines, I request Sri Trivedi Saab to give his comment.
I was very happy when I learned that I have to attend the seminar. And I must thank at the first Ms. Sinha. I have attended 3 seminars in my career so far. One at Dhanbad, one at IBM, and one where I don't remember. 3 seminars I attended. Basically all pertaining to safety in mines. And mine safety depends upon the data available by geologists to me. This is bigger. And I was a student of about 23 years of age, roughly you can say that, when I joined the department. Narwapar is now a full-fledged mine at that stage. And the data given is naturally by our geologist friend. So I expect that the data must be available to all. Say, hello? Hello? The data is available, and I expect that GSI, AMD, and other organizations, RTM in Nagpur University, must be in collaboration with each other. As Dr. Hansoti said, I am of the same view, and I thank you all for inviting me here. Thank you once again.
Participating in this seminar. Now I'll request MECL is also available here with us. So as a part of MECL organization, I request the, somebody is there? Ravindran, yeah. Ravindran to say. Name thoda.
Thank you, Sinha sir, and this organization for arranging this very good seminar on the Chhattisgarh Basin. In this 2-day seminar, I was attending the seminar since yesterday morning. And unfortunately, we could not present any papers because of the time shortage. We thought of sending some papers, but could not materialize due to the workload. But the seminar was very fine because this is a very big basin in Chhattisgarh, and was very much thrust on the mineralization in the contact zone, especially at the brecciated zones where the uranium mineralization is there. That we know that in Bhima Basin and in Gogi Basin, AMD is doing exploration in the same setup with this granite, this nicely contact with the sedimentary basin. And in the geophysical paper presentation, they have given the thickness of the sedimentary basin, where the shallow basin we can go for further exploration, yes, suggested. And in some more papers, it has seen that because you know that Chhattisgarh Basin, that in the Chhattisgarh, the main potential is coal, iron ore, and dolomite and limestone. And MECL is carrying out most of exploration for coal and dolomite. And now we are engaged in exploration for this diamond as well as in gold. When during these two seminars, some papers are given some insight to this lithium mineralization. And as Sinasa presented in this paper, he mentioned that in uranium mineralization at the contact of the gneissic rock, some sulfide mineralization also is occurred. So my insight is there, we should give more stress on the exploration in this sulfide mineralization as well as the lithium mineralization reported in the pegmatite and phonogranitic rocks. Thank you for giving me this opportunity, sir. Thank you, Sinha sir, for giving this very good presentation.
Thank you, Ravindran Saab. He was from MECL. Now, next organization is Geological Survey of India. So I will start from young person. Youngest lady geologist first. Who is the youngest lady geologist? She has to claim. Please come forward. Will not ask date of birth certificate. You can come here. Yeah, it is better. Yeah, that was meant for seniors.
Yes, sir. I will conclude in 5 minutes. Very good evening to everyone. My heartiest respect and congratulations to everybody present over here. 2 दिन से हम a room full of scientists is discussing about sharing knowledge, sharing ideas. So I will start with quote from Arjuna Panda sir. Vidya dadati binayam, binaya jati patrotam, patrotam dhanavapnoti, dhana dharma tata sukham. So विद्या हम अभी तक डिस्कस ही कर रहे थे, नॉलेज शेयरिंग आइडियाज, यही सब की बात हो रहा था. और हमेशा से 2 दिन से कोलैबोरेशंस की भी बात हो रही है फ्रॉम ऑर्गेनाइजेशंस AMD, GSI, यूनिवर्सिटीज एंड अदर ऑर्गेनाइजेशंस. सर प्लीज करेक्ट मी इफ आई एम रॉन्ग. आज सुबह सर बोले थे चेयरमैन ऑफ MECL, he was talking about magnetotelluric survey where geophysical survey, very depth persistence, and also he was mentioning that MECL can drill up to 5 to 6 meter or 7 meter drill depth. Is it right, sir? Yes, yes.
They have tested for 1,000 meters.
Yes. I mean, sir is from MECL, chairman MECL.
He is
Direct.
technical. Engineer.
Okay, I'm referring to him. That's why I asked. Sir, AMD, GSI, MECL, every organization has some restriction of sharing data. And there is nothing wrong in it because there is some security purposes involved of our country. So that mandate or that code of conduct should be exist there. There is nothing wrong. But we should come to a discussion while sharing ideas. My question is how? There, I will request to all my peers, my authorities, and everybody taking charge of this thing. We should come. Let's come figure out something. Let's do some SOP. Let's come out of some SOP. How we could do it exactly? Like for uranium exploration, AMD will take care of that. We don't have to worry about it. So it will focus on uranium only and radioactivate explorations, and rest of the thing is like on research purposes, and when other mineral is concerned, then let's come up with some SOP, some particular way of sharing knowledge. Let's sit together and discuss while doing a project. There's some restriction of every organization, some limitations that we can do drill up to this meter. So everybody should come together and let's figure out something together so that we'll do means a good product will come out, some better aspect of every exploration will come out. So that is my suggestion, and I will conclude thanking everyone, and that's it. Thank you. Thank you so much.
Okay, thank you. But your name, I could not get your name.
I am S. Pushpanjali from GSI Chhattisgarh.
Okay, Pushpanjali. Okay.
I belong to Odisha.
Pushpanjali. Okay, Pushpanjali, thank you for giving this comment. Let me inform to the participant that rains are continuing at this session is further extended for 15 more minutes. Extended because nobody can go. So this is the ideal place to have discussions and continue further this seminar for till more 15 minutes. Probably God will allow us to go at 6:30. Coming back to the suggestion of Pushpanjali, yes, you are right. Government of India has declared the policy of data sharing. It is in place and it is taking care. Department of Science and Technology is drafting SOP, and there will not be any bar for sharing of the information. It was already there in organizations and it was being done, but now it is coming on paper. And as far as departments are concerned, say GSI, AMD, if I say, because we are part of that, it is already existing. We have not agreement, it's a just a paper gentleman agreement type of thing. Director General Geological Survey of India has signed and Director AMD has signed, and we are following that thing. Earlier also, without paper, we were having this type of exchange of knowledge, and it is continuing. Everywhere personal matters, one-to-one matters. Many times it may not have been provided. Somebody is asking and somebody is not providing. That is again one-to-one. But most of the time, what I have seen, that whatever was required from Geological Survey of India has been provided, and whatever they were asking, that we have given. And because of that, we are continuing. So it is there. But certainly your point is already taken care of by the Government of India, and that will come in a form of good knowledge. Everything is now has to be shared. Government of India says that whatever data is collected by Government of India fund has to be put up on website so that anybody can approach at any time. And Geological Survey of India is doing. We are also doing, but at the same time, because of some restrictions, atomic minerals cannot be made public. So that's why some restrictions are there with AMD, and we are continuing. But certainly geological knowledge, you might have seen that many papers are there which have clearly stated what is the knowledge what we have. So that is a very good suggestion. Now I'll invite the youngest Geological Survey of India officer, male now. Yeah. Aye. Yes, please. वेलकम. नाम पहले बताइएगा.
Good evening, respected dignitaries. And my name is Ravikant Gupta, geologist, GSI Raipur. So, sir, I am very happy to share my happiness that this is the first seminar I attended after joining GSI and in my career till now. So this is obviously a big opportunity for me, and I started my career in Geological Survey of India from Chhattisgarh Basin and started exploration regarding limestone, and now I am working in base metal and critical and strategic metals. So this 2 day session has opens up the eyes to look into the means in different perspective, in multi-dimensional and multi-directional perspective, how we should look into the Chhattisgarh Basin in coming time. And every presenters have given their best to emphasize the importance of the Chhattisgarh Basin as starting from the depositional environment, stratigraphic sequence, and mineral potential structures, and with additional input on a large scale from the geophysical division, has raised the status of the Chhattisgarh Basin in Indian stratigraphy. Sir, I extend my heartiest gratitude to the organizing team, organizing institution and organization under your leadership. I thank again. And as many suggestions are there for sharing data and coordinated studies. So I also request in future, and that is going to happen as you mentioned that there will be no bar. So thank you very much, sir, and thank you everyone. Thank you, sir.
Ravikant Gupta. Now I'll request the youngest officer from AMD. I cannot call youngest lady officer in AMD because we don't have right now. You have to look for somebody who will be available in next seminar. So please, youngest officer from AMD. Who claims to be youngest?
Good evening to all of you present here. Myself, Jyotiskar Hazarika. I'm working in AMD Central Region. And I'd like to thank esteemed director, Dr. Deepak Kumar Sinha sir, for giving me this opportunity to speak on this forum. So it was a very brainstorming 2 days national symposium on Chhattisgarh Basin and its environs. So starting from the depositional environment, its structure, tectonics, and going to the mineral exploration part, where we have integrated, where I have seen presenters with integration of aerial data in how to delineate the potential areas of mineral exploration. And coming last to the analytical part, which is very important because as a field geologist perspective, we collect the samples and then we send to various labs. And how this analytic part gets done. So it's very important. So I'd like to thank all of you for enriching my knowledge. And it was a very informative 2 day session. Thank you.
Thank you, Jyotiska. Now we'll be calling to senior professor from RTMNU, Professor M. Varade. can give his opinion and suggestions so that we can improve further.
So good evening, one and all. Thank you very much, sir, for giving me this opportunity to come over here and speak a few words. Being associated as a organizing secretary from RTM Nagpur University, we are closely working with AMD, GSI, and other organizations, but this particular experience is different. Of course, our way of working, style of working is different. We have certain limitations not in terms of working style, but also in terms of many other ways. But we have learned a lot from this particular episode. And as far as this particular seminar is concerned, yes, sir, this is a very fruitful event, not for us, but for all the people who have participated in this particular episode. One more important thing which I would like to say and express over here is there should be one volume, because most of the people who are here as a participant, they are in the opinion that there is no volume or there is no literature which is published in an amalgamated form. So this is my kind suggestion or request that there should be one volume, so that whatever findings so far people have come out with, it should be given to the younger generations, and that can be referred by all the people. So our experience with AMD and GSI people is very good, and we are thankful to you for giving this opportunity. Thank you, and best luck to you all.
Thank you, Professor Varade, and we look forward many more associations like this. We are in Nagpur, and this synergy will continue in future. We'll see in many more opportunity. And I'll come after what you have suggested in that. But before that, I would like to request colleague from Geological Survey of India, Mr. M.V. Dakate, if he can come and say a few words as a opinion of free opinion of your thoughts in for symposium and for the improvement of symposium in our next venture.
Thank you very much, sir. As far as this seminar is concerned, it was consulted by the AMD, and later on our request of our DG GSI, GSI is also became part of this seminar. And recently we have conducted one seminar on Mahakoshal. So that time also it was represented by various organizations. So that was a great success. And GSI is always ready to participate in such scientific interactions and seminars. So as a part of this seminar, we are feeling ourselves great, and our young scientists, they could get the opportunity to present their work in this forum. So this is much needed, sir, this type of interaction. It is always welcome from GSI side also. And we assure you, sir, as Professor Trivedi has declared, they are conducting next seminar in Vindhyans. So we are ready, sir. We are, please give us a chance to participate in that seminar also. And some more seminars are also in pipeline. That is also in collaboration with other organizations. So we are open to all, sir. Please come to us, and our knowledge and our data bank is already available to you through our portal and through Bhukosh. And we are there for any time. Anytime you can contact us, and we'll share our address also. And as a Director Technical, Central Region, I'm always there, sir. Thank you very much, sir.
Thank you, And the Katesam, this is a very open invitation, and this is the spirit what professionals have, in fact. We'll go further. More collaborations will be possible with this spirit, I'll say. I'll request Lovelace to come to dais as a part of Geological Survey of India officer.
Respected dignitaries on dais and august gathering, eminent geoscientists. I would like to say here few words that was inspired from the speech of Honorable Minister yesterday during the inauguration session of this seminar. Being a professional organization of geology, government have some expectation from us for the prosperity of nation, for the prosperity of society. Generally, roti, kapda, makan, ये सारी चीजें available हैं. For the prosperity, हम प्रोफेशनल ऑर्गेनाइजेशन जो जियोलॉजी से रिलेटेड हैं, GSI, AMD, MECL एंड many more, इनसे गवर्नमेंट के एक्सपेक्टेशंस हैं. वो एक्सपेक्टेशंस कहीं निकल के बाहर आते हैं और इन्हीं एक्सपेक्टेशंस के साथ हमारी लाइन ऑफ वर्क डिसाइड होता है. सर, यस्टरडे जब मिनिस्टर साहब आए थे तो उन्होंने 2 सवाल बहुत अच्छे हमारे सामने छोड़े. नंबर फर्स्ट, ग्रीन एनर्जी. ग्रीन एनर्जी को लेकर के उनका जो कॉन्सेप्ट था वो फॉसिल फ्यूल से थोड़ा सा बाहर आकर के और ग्रीन एनर्जी की तरफ आ रहे थे. सेकंड, जब किसी भी CGPB मीटिंग में डिस्कशन होता है तो बहुत ज्यादा थ्रस्ट दिया जा रहा है आज RE वियरिंग मिनरल्स पे. काफी सारे सैंपल मैं एनालाइज करता हूं. आपको जानकर खुशी होगी कि जियोलॉजिकल सर्वे ऑफ इंडिया में NGCM एक बहुत ही एंथुसियास्टिक प्रोग्राम चला और उसमें 2014 के बाद एक एस्पेक्ट जोड़ा गया हैवी मिनरल एनालिसिस. 5 मिनट बाई 5 मिनट की टोपोशीट, एक टोपोशीट से 9 सैंपल्स हैवी मिनरल के लिए निकाले जाते थे. उन हैवी मिनरल्स का एनालिसिस किया तो ये कंक्लूजन निकलता है कि जितने भी RE बियरिंग मिनरल्स हैं उन सेपरेटेड मिनरल की एनालिसिस करते हैं तो उसमें काफी हाई वैल्यू यूरेनियम की भी आती है. दैट इज एनोमलस ट्रेंड. बहुत हाई 5000 ppm से लेकर के कई मिनरल्स में मैंने 8000 ppm यूरेनियम तक एनालाइज किया है हैवी मिनरल RE के साथ, इंक्लूडिंग RE. तो एक ये कोलैबोरेटिव वर्क बनता है जिसमें GSI AMD को साइमल्टेनियसली काम करना चाहिए. लिथियम, हम और आप जानते हैं कि लिथियम एसिड मैग्नेटिक बॉडीज के साथ मैक्सिमम टाइम रिलेटेड होता है और सरफेस के ऊपर इसकी वॉलेटिलिटी की वजह से बहुत देर तक ये सस्टेन नहीं कर पाता. इसका लिथियम लीज्ड आउट हो जाता है. तो सेवरल टाइम्स, जैसे एक हमारे अभी मिश्रा जी हैं, उन्होंने एक पेपर पब्लिश किया था इसके ऊपर, अभी पेपर पढ़ा है. उसमें पॉलीलिथियोनाइट बन के आया. अर्लियर इट वाज लेपिडोलाइट, लेकिन लीच आउट होते होते लिथियम काफी सारा बाहर निकला एंड दैट मिनरल लेपिडोलाइट कन्वर्टेड इनटू पॉलीलिथियोनाइट. 2 एस्पेक्ट हो जाते हैं. थोड़ा सा डीपर जाने पर क्या सस्टेन करेगा मिनरल? दिस इज आल्सो अ क्वेश्चन एंड वी कैन वर्क ऑन इट. ये बहुत अच्छा मतलब ऐसे सेमिनार्स से जो नॉलेज मिलता है, लाइन ऑफ वर्क मिलती है. तीसरा, विंध्यंस की जब पर्टिकुलरली बात की जाती है तो दोनों चीजों में बहुत अच्छे से इस्तेमाल किया जा सकता है. सिरबू सेल that have a prospect for atomic based repository. It can be, it may be, उसको एक्सप्लोर किया जा सकता है। एटॉमिक प्लांट लगाना आसान है और एटॉमिक वेस्ट की हैंडलिंग बहुत मुश्किल है। ग्लोबल नॉर्म्स हैं ऐसे हैं कि जिनकी वजह से आप एटॉमिक वेस्ट को बड़ा मुश्किल से हैंडल कर पाते हैं। सिरबू सेल इज गिविंग यू अपॉर्चुनिटी that the thickness of Sirbu cell may be utilized as a atomic based repository. जून से इनको थोड़ा कम नॉलेज में आए हैं, तो दिस इज वेरी गुड अपॉर्चुनिटी. वी शुड गो फॉर अ सेमिनार ऑन Vindhyan. So thank you everyone.
Thank you, Lovelace, Dr. Lovelace. Your suggestions are very good. We'll look into the development, what you have suggested. Now I'll request from Sachin Saab from XAMDN. He has also sincerely attended the seminar and very hardcore field geologist. So I'll request him.
Thank you, Sinha Saab. And I thank the organizers who have given me chance to attend this seminar. Though I'm retired from AMD 15 years back, and after that probably I'm attending first seminar and busy in rather in my businesses and all. I have worked in many places, Shillong and then Jamshedpur, Tatanagar, and then in central India, also in Chhattisgarh. This seminar was long awaited, and it has brought 3 organizations together. All the deliberations, technical papers, they were of very good standard. And particularly the seminar venue being in university, I am seeing a lot of youngsters, students, they participated, and surely they are more benefited. As many seminars I attended in my service career of AMD, many times we meet in the seminar and we deliver our things, we listen the lectures and all that, and many times we just forget. But now the time has come, as it was being discussed by Sinha Saab, and probably a young girl, she also was the data sharing and all that. So my suggestion is that I saw few papers of the GSI here who were dealing with the structures of the basin. They will be very beneficial for the AMD to plan their strategy for the exploration. Earlier we were just doing the exploration on the basis of the outcrops, occurrences, and then we go for the subsurface exploration. But now I saw that in this deliberation after many years, as I said that after many years I'm attending the seminar, lot of geophysical data, which was probably not that time so intensive. That's very good. The data was so nice that even in the depth of so many meters we get the information. As Mr. Sarvanan has discussed about the geophysical data in his comments. So my suggestion is that use the data, have a good collaboration, exchange your mobile numbers. Of course, you all have. And my suggestion to students that you remain in touch with the other organization, with the people or the people who have presented the paper. So that will be the real benefit of the seminar. Thank you very much.
Thank you, sir. And this is the opinion after 15 years not attending to seminar and then giving the verdict. This is the real, not in geology. But the way he was speaking, nobody can say that he is out of 15 years from the geology. Thank you, sir. Thank you. Thank you. Thank you, sir. Now I'll invite whosoever voluntarily wants to come forward and share his experience for the benefit of all those who are sitting here. Volunteer, I think Jan Saab, yes, I missed you. Please, sorry, I could have called you.
Good evening, everybody. So, just right starting from giving a big salute to Dikesana Saab, because I was there in Hyderabad. So I was thinking that is his home headquarter, and in Nagpur he may be having a limitations, but at parallels with the Hyderabad, he did in the Nagpur also. So big round of applause to Dikesana Saab, number one, and his team, no doubt. And second thing, as we were talking a lot about the youngsters, so though it may be relevant to this seminar, we are seriously think about the placement of our youngsters who have just passed MSc or MTech, because I have seen that in GSI there is an exam is there. AMD also they have some recruitment policy, and recently the IBM has also started taking the exam passed by the Geological Survey of India and IBM. But other than that, so many public sector, state, center. So what I feel like that there should be one combined exam to get it recruited the person who is going in the geological service. So that can be one of the recommendation. And I don't know how best we can put forth. And second, as the data dissemination was there, and kindly don't take this as a suggestion of IBM. What I feel like that when we prepare a national mineral inventory, when there is a parliament, always one question or other about the critical mineral, strategic mineral, deep-seated mineral. So always we write, we don't have any specific information. However, one or two paper which has been shared in the public domain, that only given as a reply from the IBM. So what I feel like when we have so many data available and we are presenting in the paper, why don't we cannot make inventarization of these? Maybe there may be some limitations. That is in RE, so much of the cutoff is there. There is a uranium is there. There is a thorium is there. There is a decent mineral. Recently, the government has made it a zero threshold value. And one more thing, I think the audience may be knowing it. The part B of the schedule 1, that is a atomic mineral. Some mineral is now going to be given to the for private also for the investment purpose. Means whatever the restriction we are having on the name of the atomic mineral, now time has come that should be given open-ended opportunity for all. Because when we are thinking of the energy other than thermal, so this is could be one of my suggestion. And as far as the interaction is concerned, we talk in all the forum that there should be a close interaction, there should be a subsequent dissemination of the knowledge, but unfortunately it remain till the organization conference are there. We make in Nagpur, we can make a oath. Whatever may be the department, at least once in a month or quarterly in a month, we will have a formal discussion talking some technical points. Nagpur University, JNR, in Nagpur we are lucky, more than 50 departments of the geology is there. Government, state government, public sector. So why don't we make a oath to come out with the, and as and when there will be any such type of the seminar, already platform will be available. We have a close coordination, we know each other, we are
ready to disseminate the knowledge, and there will make a bridge between the youngster and the seniors, just like a stalwart sitting in the front. They may get the opportunity rarely. Whenever this, suppose this is AMD, they have called their people. When the GSI will call their people. But why don't we call them as a pathfinder, or they are as a torch bearer for us, whoever may be the organization. So this is a few suggestions, sir. Time is going to come. Thank you very much for giving me the opportunity, Sanan sir, and all. Thank you, sir.
Then, sir. Here, like to say, and I think the God is also not raining, so we can think of closing the ceremony. The last point which I wanted to say, when seminar is concluded, then it has to be published, and a good proceeding is a must. I'll share my experience, which recently we had. On 5th and 6th April, we conducted a seminar, which Jansa was referring, and the volume is already published on 29th July. I never saw this type of publications so fast. In April, only abstract volume was published, and in May and June, we got full paper, we got it reviewed. Geological Survey of India has made them to get peer reviewed as per their standards, Springer and Verlag, and they published it. It is over. That chapter is over on 29th of July. It is available. Anybody can Google it and see the August volume of Geological Society of India, which is available on web, and one can read the paper presented in that seminar. That time we were in hurry that in the August, this August is our 75th anniversary of independence. So we wanted it August, but now we are not in hurry. We can make this volume available if we get enough paper. I have seen many good papers, and I am looking for at least 15 papers which we can bring into one volume. We can request to Geological Society of India again. They can contribute a devoted volume to this seminar. I have to talk. I mean, that discussion has to come, and the panelists and you all have to give me that verdict. Yes, you go ahead. We can publish a dedicated volume in Geological Society of India on paper which have been published. That could be one. Second, also, we can request Geological Survey of India. They can also, a special volume can bring out. AMD can also bring out. But in my opinion, we can bring out, but the society's journal has got wide publicity, wide impact factor, and it is a Springer and Verlag. So, in my opinion, society, but we have to take the permission from them. Whether they are agreeing or not agreeing, that is again their management. For that, we took permission and they agreed. Professor Harske Gupta agreed for that. So if everybody agrees, if say yes, then I have to go ahead. I have to talk it, and then I have to take the. So I think. Yes or more. So I have to consider yes or more. No or not there. So I have to consider that we should go with Geological Society. We'll request them. That is again their decision. It is our verdict that we can request that the society, this is the recommendation that we can request the society to publish our volume, and we'll request all the authors that they should give the paper as early as possible. Of course, time limit is not there, but we should make it, if possible, in 22 or not later than 23. That is my thinking. So with all this, I say thank to one and all for giving this opportunity to have deliberations, have networking, and have spent 2 days fruitfully. Thank you very much. Yes, one more announcement is from Professor Ranadeve Saab.
Thank you, sir. Yeah, there's one announcement side. The 108th convention of the Indian Science Congress Association. This time it will be held in Nagpur between 3rd to 7th January. As you all already know that the Prime Minister of India, Honorable Prime Minister of India, inaugurates it every year. So this year being the centenary year of the Nagpur University, and for our Department of Geology, it is the Platinum Jubilee year. So we are the proud hosts of this organization. So I request you all to kindly visit the IS Indian Science Congress Association website and submit your abstract. And I'm looking forward to your participation and to meet you again in the month of January 2023. Thank you very much.
Thank you, sir. I want to sincerely thank you all for gracing the dais and engross us in a thought-provoking discussion about the seminar. Also, I'd like to thank our participants for sharing their thoughts on the seminar and showing us directions, which we will definitely include in our future endeavors. Now, it's time for distribution of participation certificates to all the lectures which have been delivered today. So I would like to request Sri Sheshashai sir, Director, Geology, GSA Nagpur, to distribute the participation certificates to our participants of today's first session, that is Mineral Exploration in Chhattisgarh Basin and Investment. So I would like to request Dr. D.K. Sinha sir to come forward because the keynote address was delivered by you. It would be followed by Pradeep Kumar Jain. Sri A.R. Mukundan sir. Vishal Sakare sir. A.K. Mishra. JSI Raipur. Priyanka Jha, JSI. So one. Thank you, sir. Now I would like to request Dr. D.K. Sinha sir, Director AMD, to felicitate the participants from our second session of today. So for the keynote address, I would like to request Sri B. Saravanan sir to come forward. Followed by S. Srinivas, JSI Hyderabad. C. Satish, AMD Central Region. And Dolomite Jalandhar, AMD Central Region. C. Satish. Thank you, sir. So we're moving towards our third session of today, which was Water and Soil Resources of Chhattisgarh Basin. I would like to request Sri Dongre sir, Director DGM Raipur, to come forward and hand over the participation certificates to our participants. Sir, the keynote address was delivered by Dr. Praveer Kumar Naik sir. So I would like to request Naik sir to come forward. It would be followed by A.K. Biswal, from CGWB Raipur. Sri Deepak Bej, Pandit Ravi Shankar University. And Dr. R.K. Trivedi, Dr. Hari Singh Gaur Vishwavidyalaya. ये नहीं सर आप Thank you, Dongre sir. Thank you, sir, for your time. Now, I would like to request Dr. Pravir Kumar Naik, sir, to hand over the participation certificates to all our participants in our last session today, which was utilization of advanced analytical techniques for mineral exploration in Chhattisgarh Basin. The keynote address was delivered by Dr. T.S. Sunil Kumar, Additional Director, Research and Development, MD Nagpur. So, Naik, sir, please, if you can felicitate our participants. So this would be followed by Sri Alok Pandey, AMD Central Region Nagpur. Followed by Dr. Ravin Kumar Mandal, AMD Central Region Nagpur. Sri V. Madhukarappan, AMD Central Region Nagpur. And today's last lecture was delivered by Sri Y. Srinivas, AMD Hyderabad. Sir, one more. Thank you, sir. That would be all about distribution of participation certificates to our guests who delivered their lectures today. So now it's time to conclude our seminar. And I would like to request Sri Milind Dakate, sir, to come and propose the vote of thanks on behalf of the seminar committee.
Respected Chairman, all the honorable dignitaries and audience, August gathering, and as Trivedi sir has quoted the Archean belt sitting in front, and that is very productive. And don't forget protozoic, who are experts sitting here. So they are also very fertile at present. And quaternary is sitting there at upstairs. So they have their own contribution. So tertiary हम लोग हैं. So 2 days long sessions we had, and there is a takeaway for everybody, and I hope everybody is benefited with all these deliberations. And as a organizing secretary, one of the organizing secretary, it is my duty to propose this vote of thanks. So this is my pleasure and I am feeling honored to present this vote of thanks on behalf of three great organizations, that is Atomic Minerals Directorate for Exploration and Research AMD, Rashtrasant Tuguduji Maharaj Nagpur University RTMNU, and Geological Survey of India. First of all, we all are grateful to our Honorable Minister of Road and Transport Highways, Government of India, Shri Nitin Gadkari ji, for accepting our invitation to this seminar and sparing his valuable time. Maybe it may be the short time, but he came here and inspired us for our future endeavors. And as we all know, he is a man of commitment. And what we all are seeing his commitments since last 8 years, and results are in front of us. And he is a local person. So there is a change in Nagpur city itself that everybody has noticed, those who have visited after some 10 years. So there is no doubt regarding that. And we all heard his advice and speech. Whatever he has talked about, that is just like order for us. We have taken this as order from the Government of India. So his main stress was to increase the export and reduce import. And he is propagating Government of India Make in India policy. So while doing so, he has told us to be very committed as he is. So we have to follow him. And as far as his advice is concerned to our seminar Chhattisgarh Basin, so all we know, 20% of our GDP is contributed by agriculture. So that is our main activity. And we are deficient in the minerals which are being used for preparation of fertilizers. Like potash, glauconite, gypsum, phosphorite. And Chhattisgarh Basin is rich in all those minerals. So as a geoscientist, that is our prime responsibility to explore for more and more minerals in which we are deficient. And as we know, as a geoscientist or any other science, until and unless it is beneficial to public and beneficial for the development of country, so that science is not going up to the mark. So it is not done. So our Honorable Minister also told same thing. He has quoted the example of IBM and WCL. So they are knowing each other, but they are not knowing what they are doing. So he was talking about maintaining the synergy. Today our respected experts have also told about this maintaining synergy, and everybody has talked about this. In this August gathering, I would like to tell you, sir, GSI has a foolproof system, as you must be knowing, for maintaining synergy. We are having CGPB system, and there are 12 groups, CGP 1 to 12, and CGPB 4. It is headquartered at Nagpur, and Nagpur, because Nagpur is conducting, CGBB Committee 4, in which industrial and fertilizer minerals are coming. And I being the member secretary of that committee, I appeal everyone here to attend the CGBB committee meeting, which is scheduled to be held on 12th of September, in which industrial and fertilizer minerals, what is the present status in country, that will be discussed, and it will be attended by several organizations throughout the India. And this time, this year onwards, we are inviting, sir, the special invitees, we are inviting, and even private players who are doing. Yes, sir. So, yes, sir. So, this is the thing. So, I appeal everyone to take advantage of this. I would like to thank Dr. Subhash Chaudhary ji, Honorable Vice President, RTMNU Nagpur, for his kind support and sparing his valuable time. He was very much accessible to us. Whenever we have visited him, he has helped us and guided us, and we are thankful for giving this beautiful auditorium to us and providing the university premises and all logistic support. On behalf of everyone, I would like to thank Dr. D.K. Sinha sir, Director AMD, and Shri Arjun Panda sir, Regional Director and Convener of this seminar, for conceptualizing this seminar. So very basic idea, it has came from you, sir, and because of that, this has happened, and you make it happen, sir. We have seen Panda sir actively participating in every meeting we have conducted prior to this seminar and running here and there. So he was very active for conducting the seminar. My heartfelt thanks to Dr. S. Raju, Director General GSI, for his support and keen interest in conducting the seminar in collaboration with AMD. And he has made everything readily available to us whenever and whichever we have asked. We are very much thankful to Dr. J. Rajeshwar, Additional Director General and HOD Central Region, for his valuable guidance and enormous support and time-to-time approvals in organizing the seminar. And he has made his gracious present and his active participation. He has actively participated and chaired one session also. So we are all thankful to him, sir. We are thankful to our editorial committee, who has timely scrutinized all the papers and abstracts and brought the abstract volume in time. Then I would like to thank all the presenters. Because of them only, this seminar is a fruitful and came to this successful end. So there are about 36 papers presented, and now we have set momentum. So this is not the culmination of this program. I hope this is the beginning, good beginning in this Azadi Ka Amrut Mahotsav year. So let us hope for best coming in future, and let us hope to achieve desirable goals. And I would like to thank all the logistics provided through e-platform and those who are connected through e-platform. And I express my sincere thanks to media, audiovisual team, live streaming team for effective coverage of this event. I would like to thank illumination and decoration teams, catering services, everyone. And then I would like to thank our sponsors who has funded this seminar, Data Code, Gemco Catty, Techno Enterprises, Kartikeya, Anton Par, then Parson and other sponsors. Then I would like to thank each and every member of the event and organizing committees, and all those persons who are worked hard to ensure that this occasion becomes a memorable success. Thank you all once again. Thank you, sir.
Thank you, sir. We have come to the end part of our today's seminar. So the journey we started together as a geological fraternity will definitely continue moving forward, and it will finally lead us to our final destination of Atmanirbhar Bharat. So with that hope, we will conclude our today's seminar today. I would like to request my co-host and friend Pritam Karmakar to join me on stage, and everybody to rise to your toes to salute our nation by reciting our national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, sir.